Now, when it comes to building out the tables or the database schema, SQL Alchemy has a little bit of a limitation, and that is that SQL Alchemy doesn't allow us to modify tables. It doesn't allow us to create extra columns, delete columns, add foreign key constraints. And that's because when we define these models, what SQL Alchemy does is it checks to see if the specific table name already exists in our Postgres database. And if it does, it's not going to touch it. So if we make any changes, it will never push out those changes. It'll only create these tables if it doesn't already see a table with that specific name. And so we've had to resort to dropping all of our tables and then restarting our application so that SQL Alchemy builds it from scratch. And it's something we can't obviously do in production. That would be an unacceptable thing to do. And just to show you guys, in case you've forgotten, if we go to our Postgres database and we can see that we've got our 3 tables. Now, if I add a phone number column to our user class, and I'll set this column to be just a string, and this is really just for demonstration purposes. You guys don't have to do this. If I save this and reload this, SQL Alchemy will not go into Postgres and actually create that column. If I refresh this and then go into users properties, you can see that it is not here. And so that's the limitation of SQL Alchemy. And so in this section, what we're going to do is we're going to take a look at another tool that'll allow us to do a couple things. First of all, it's going to allow us to automatically update the columns based off of the models that we define here. So moving forward, when we add this phone number column, it's going to automatically update our Postgres database. And this tool is called Alembic. It is what we refer to as a database migration tool. However, it's much more powerful than that. Right? It's able to allow us to create incremental changes to our database and actually track it, kind of like we do with code. So in this lesson and in the next coming lessons, we're going to take a look at Alembic. We're going to see everything it has to offer. And I'm going to hopefully get you guys at least a solid understanding of how to work with Alembic so that when you guys work on your projects, you can immediately get Alembic installed, running, and then manage your databases using Alembic instead of having to either do it manually or use any other kind of unusual workaround. Now, one of the motivations for a database migration tool came from the fact that developers can track changes to their code and roll back their code easily with Git. And they wanted to be able to do the same thing for our database models and our database schema. And so they went about implementing what is referred to as database migration tools. And so a database migration tool just allows us to incrementally track changes to our schema and roll back those changes to any point in time. And so as we go through our project, we kept adding new tables and new features. What a database migration tool is, it's going to allow us to track those changes. And so if we ever want to go back to a specific point in time so that we can kind of troubleshoot code at that point in time, it's so easy. It's just one simple command and it's going to automatically update our database so that the schema matches what it was at that specific point in time. And so that tool that we're going to use, like I mentioned, is going to be Alembic. And what's great about Alembic is that it can also automatically pull all of our SQL Alchemy models and generate the proper tables based off of them. All right, so this is the documentation for Alembic. So it's just alembic.sql.com.org. And if you want to kind of follow along, just select the tutorial right here. And this is just going to give you kind of a quick walkthrough of how to get Alembic set up. But I'm going to show you guys this so you don't actually have to follow the tutorial. So we're going to do first of all, we have to install the library. So we'll do pip install Alembic. And so that'll get Alembic installed. And what it does is it actually gives us access to the Alembic command. So if I do alembic --help, and actually before we proceed any further, I want you to go ahead and delete phone number. We don't actually need that anymore. And then go to your application and actually close that out. Stop it so that it doesn't automatically restart for any other reason. And then also what we're going to do is I'm actually going to delete all of our tables so that we can actually take a look at how this works. So do delete drop. And if you try to drop this table, it's going to say we can't drop it due to the foreign key constraint. That's okay. We could just do drop cascade and that's going to delete it. And we're just going to do that for all of them. All right, so now let's get back to Alembic. I'm going to make this bigger for you guys. All right. And so we'll do alembic --help to see what commands we have. And the first thing that we have to do is we have to initialize Alembic. And what that's going to do is it's going to actually create an Alembic directory for us. So we'll do alembic init. And then I'm just going to do a -- help to see if we need to pass in any extra flags. And then we have to give it a directory name. So when we run this command, it's going to create a directory. I'm going to name the directory Alembic. You could call it DB, database, whatever you want to call it, but I'm just going to call it Alembic. So it's going to create a folder called Alembic. And so you can see that we've got this folder called Alembic, and notice how it gets installed outside of the app folder, which is what we want. And it also created this alembic.ini file. So we'll take a look at both of those. And the first thing that we want to do is go up into Alembic, and there's really one main file. It's the env.py. So this is kind of like the King Kong configuration file. And there's going to be a couple of things that we have to add to this file to make sure that things work. Because Alembic works with SQL Alchemy and the models that you build with SQL Alchemy, we need to make sure that it has access to our base object right here. So we have to import this base object into the env.py file. So I'm going to just go right here, and we're going to say from, and what we're going to do is, how do we actually get to that database file, that base object? We have to go into app, and then we go into database, and then we'll import base. All right, and so this is kind of give us access to all of those SQL Alchemy models. And then for target underscore metadata, instead of saying none, what we want to do is we want to get base. So we're accessing, this should be a capital B. Actually, let's just double check that it's capitalized. Yep, it's capitalized here. So we'll go to base, and then we want to make sure we grab metadata. So that's all we have to do to rig this up to SQL Alchemy. The next thing that we have to do is if we go to alembic.ini, we have to pass in one value here, which is the SQL Alchemy URL, which is basically what's the URL to access our Postgres database. And so just to show you what this is going to look like, this is going to be fundamentally no different than the URL that we used within database.py, which is this one right here. And so I'm just going to write this out. Just going to copy this first part right here because I can never remember that. And so here, just going to copy that. So we say PostgreSQL. And optionally, with the URL, you can do a plus and then whatever driver you're using. So if you don't provide the driver, it's going to use whatever the default driver is. But we're using, let's see, which driver, what is our driver? If I do pip freeze, it's going to be this one right here. So this is the default driver for Postgres. So you don't actually need to provide it. But if you did, you could just say plus PSY COPG2. But like I said, it's the default one, so it's optional. Right, then we have to give it the username. So what's the username that's going to be using to log into your Postgres database? For me, it's just Postgres. The password is going to be password123. It's going to be running on localhost. And then if you want to, you can provide the port, which is 5432, and then your database name, which is fast API for me. So this is ultimately what the URL is going to look like. And at this point, Alembic is set up and ready to run. However, just like we did before, I don't like the fact that we're hard coding this data in here. It's gross. We're saving our password. And if we move into our production server, it's not going to work properly because they're not going to use these credentials or this IP. So instead of doing this, what we're actually going to do is we're going to override this value that's stored in this file within the env.py file. And so under this config right here, I'm going to set a new option under the config object. I'm going to say config.set underscore main underscore option. And then here we can override any options that we have in here. So I'm going to override this SQL Alchemy URL. So no matter what I put in here, we're actually going to override it. And here you just pass in a string. So SQLAlchemy.url. So that's the value we're going to override. And then we're going to pass in our string. So I can just cut this out, and it's okay to just leave this blank here. All right. And so we've hard-coded this string here, so we haven't technically fixed anything, but what we're going to do is, just like we have in our database.py file, you can see that we're using the settings object, right? That comes from our config file, which is making use of this Pydantic class, where we can grab it from our environment variable. And so what we're going to do is we're going to do the same exact thing we did with main, right? We imported settings, and we're just going to do that in our env.py file so we can access all of our environment variables. So I'm going to say from app.config import settings. And so now I have access to the settings object. I can override all of these. So this is going to be the username. So I can say settings.username. And actually, I don't think that's what it is. It's database_username. And then we'll override the password, which is settings.database_password. And in reality, instead of just typing this all out myself, we actually have this written out in our database.py file. So I can just copy this here. And that way we don't waste too much time. Okay, so we've got our URL set and we're not hard coding any values. And at this point, Alembic should be set to actually connect to our database and modify any of the tables, generate tables, and be able to really perform any actions that we wanted to moving forward. Hey guys, I made one tiny little mistake. If you take a look at where we're importing base, I wrote app.database. And if we take a look at that, it looks like we are grabbing our base right here, but this is not the one we want. Instead, what we want to do is we want to import it from models. So we want to import base, which is technically getting imported from that same file. But by doing it from here, it'll allow Alembic to read all of these models. And if we do it directly from database, it's not going to work. So what I want you guys to do is go to your env.py file and just change this from app.database to app.models. And that should fix any potential issues that you could have. Okay, so just to quickly recap, we have cleared out all of our tables, so there's nothing in our Postgres database. We don't have any tables defined, and we're going to do this all through Alembic. But what I want to do is I want to kind of go through this like we would have if we had already known about Alembic from the start of our project. And so we're going to take this step by step, right? Because when we first started creating tables in our Postgres database, we kind of went along with what we were working on in our app. So the first thing we did was we created a post table. And that's because we didn't learn about how to actually create users. We didn't learn about hashing passwords. We haven't gotten to the user section. So we originally just had a post table with a couple of fields. And then after working through our code, once we finished all the CRUD operations for posts, we then learned how to register users. And at that point, we had to create a table for users. And then after that, the next logical step was, hey, how do we set up the relationship between posts and users? Then we had to modify that and set up a foreign key. And then finally, after that, the last thing that we had to do was we created a voting table or a votes table, and then we set up all of the necessary foreign keys for that. So we're gonna do this step by step, just kind of like how we did it with our project, but we're gonna do this with the database so that you can see how we would have done it if we had already known how to work with Alembic. All right, so first things first, do alembic --help, just to see what commands we have. And so there's a few different commands, but the first one that I want to focus on is revision. So when we want to make a change to our database, we create a revision. So the revision is what really tracks all of the changes that we make on a step-by-step basis. So we're going to do alembic revision --help, and we'll see the different options that we have in our disposal. The first one is that really the only one that I care about is the -m flag. So it's kind of like when you do a git commit, you can add a -m, a message, so that you can kind of have a human readable name associated with each revision. So I'm going to say alembic revision -m, and I'm going to say this is going to be create post table. So this revision is going to be responsible for creating a post table. We'll run that. And I want you to notice something, right? You can see that it created this file under the versions. So the versions folder under the Alembic folder is going to contain all of our changes. And if we take a look at the revision, there's a couple of things to note. So you'll see that we import OP from the Alembic library, and then we import SA from the SQL Alchemy library. And then you can see the revision ID that it gives it. And then there's going to be two different functions that are empty at the moment. So these functions are pretty important. What they are is the upgrade function. When we run the upgrade, what it does is it runs the commands for making the changes that you want to do. So in this case, we want to create a post table. So what we're going to do is we're going to put all of the logic for creating a post table within this function. And then if we ever want to roll back, right, if maybe I create the table and I realize I messed it up and I don't want it anymore, then we have to put in all of the logic in the downgrade function to handle removing the table. So the upgrade just handles the changes and the downgrade handles rolling it back. But it's all manual. You have to define how to do all of that. So let's go ahead and set up the upgrade function. And let's configure all of the necessary columns for our post table. All right. And if you ever want to take a look at the documentation for this, what you want to do is select documentation here. And then you want to go down, 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 all the way down to API details. And then you want to go to DDL internals. So this is going to show you how to actually perform the various operations. So if you want to create a column, if you want to add a column, this is the command that you're going to run. If you want to alter a column, if you want to modify a table, drop a column, create a table, all of these are all listed here. So this is the sheet that you're going to reference on a fairly frequent basis when you're working with Alembic, because I can never remember each of the things. But we're going to go ahead and create our post table. And so we access the OP object from Alembic. I'm going to say OP. And then if you look at the documentation, the way to create a table is you do create _ table. And there's going to be a couple of properties we have to pass in. So what's the name of the table in Postgres? Well, we're going to call it posts. And then we have to define our columns. And I'm not going to do all of our post column because it's going to take a little bit of a while, and we might do it later on, but we're just going to define two columns. So the first one is going to be, well, first of all, we do SA column. So we're grabbing the SQL Alchemy object. And so this column is going to represent the ID. So the name of it's going to be ID. It's going to be type of integer. And I may have accidentally imported, nope, we're good. So integer. And then we can set nullable equals false, which means it's required. And then we also want this to be the primary key, so you just do primary key equals true. All right, fairly straightforward, right, guys? So we can then go in and create a second column. And so this is just going to follow the same exact pattern, sa.column. And then this one will be the title. It's going to be a type of sa.string. And this is going to be nullable equals false. And I'm just going to stop it right here. So we're going to just create two columns. I don't feel like creating all of the columns that we had for posts. And so the upgrade function is done. However, we also have to provide the logic for undoing these changes. So if we create a table, how do we undo that? Well, we delete the table. So we do op.drop _ table, and we just give it the name of the table. So it's going to be posts. All right, and so now we should be able to make these changes, and then we can roll back because we put the logic in for downgrading. So how exactly do we make these changes? Well, let's go to alembic -- help. And let's see what commands we have. So we've got a couple branches. That's probably not it. Current, that's going to show us what's the current revision, like what version are we on. And if you actually want to see that, we'll see alembic current. And it looks like it's giving me an error. Hold on. Let's go back to my env.py file. And I made a very silly mistake. This should be an F string, so it wasn't actually doing anything. That's why it was kind of highlighted weird. So let's try this now again. We're going to do alembic current. And it's not going to actually really give us any useful information at the moment because we haven't run any migrations, right? We're kind of starting from a clean slate. So let's go back and let's just do a -- help and see what else we've got. So we've got a downgrade. Well, we don't want to downgrade. Edit, not really. Heads, we'll come back to that. History, that's not going to be useful because we haven't done anything. But if we go down, we want to get to upgrade. So this is what's important. So if we do alembic upgrade, we could just do -- help and we'll see what options we have. And so we have to provide a revision number to tell Alembic like, hey, what version of our database do we want to go to? And so if you actually take a look at this specific revision, it provides a revision number. So if we actually want to get up to this point where it runs this upgrade, we provide this revision number. So I can say Alembic revision and then paste that. So let's run this and see what happens. Sorry, I didn't mean to type revision. I meant Alembic upgrade. And then, not Alembic revision. So that's going to upgrade it. And so you can see it did a couple of things. It said running upgrade, and it said it created post table. So let's go to Postgres. And let's just refresh this, and let's see if it actually did something. Right? And it looks like it created 2 tables. So that's interesting. So we see our post table, and let's just quickly inspect this. We'll go to columns. You can see that it created these columns, and this one got set to the primary key, and both are not null. So it looks like it did everything it was supposed to do. But what is this Alembic versions table? Well, this is what Alembic uses to kind of keep track of all of the revisions. And so if we just go to View, Edit, Data, All Rows, you can see that it just has one column at the moment, which has the revision number. You can see it's D18, and that's going to match up with this file, D18. So that's all that's doing. So it will create a table for you automatically so it can keep track of all of the revisions, but make sure you don't delete that. Okay, so that's cool. We just got our first table created through Alembic. And I think at this point, you probably still don't understand the brilliance of a database migration tool, and that's okay because we haven't really done much with it yet. So let's say that, as we're coding out our application, we realize we want to add a new column to our database. Specifically to our post table. Well, we can create a brand new revision to add a new column. So let's say, if you take a look at our models, we have a couple other fields that are missing. So let's say we want to add the content column now. I can type in Alembic revision. So this is going to create a brand new revision. We'll give it a name, and I'll say add content column to post table. All right, and it's going to create a brand new revision for us. And once again, we have to put in the logic for upgrade and downgrading. And you can see that now that we have more than one revision, we can see that there's also a down revision. So if you want to go down a step, it's going to go to the revision of the previous one. So let's put it in the logic for creating or adding in a brand new column for content. And the way we add a new column is we do op.add_column. And then we specify the table we want to modify. So it's going to be the post table. And then we do sa.column to define this column. So what's the column name? It's going to be content. And it's going to be a type of string. And we're going to make sure that its nullable is set to false. All right. And remember, every time you set up the upgrade function, you have to set up the downgrade function. So if we add a column, how do we undo that? Well, we drop the column. So it's just op.drop_column. And then from the post, we have to provide the table that we want to drop the column from, which is the post table. And then we need to provide the actual column we want to drop, which is going to be content. So we'll do content. Okay, and so let's test this out. First of all, we'll run a few new commands. So Alembic. All right, and let's see what the current revision is. So if I do Alembic current, right, we could see that we are currently on 2D18. That's the revision. So this is the revision where we created the post table. And if I type in the Alembic heads, we can see that the latest revision is actually 298A5, which is that new one we just created. So if we ever want to get to the latest revision, that's what's referred to as the head. So I can say, if we want to, upgrade to that revision, I can say Alembic upgrade like we did before, and I can grab the revision number like this, or because it also happens to be the head, I can just say Alembic upgrade head, and it's going to do the same thing. So let's try this. All right, it said it added a content column. We'll go and check this in Postgres. And I'm just going to refresh this table. And we'll go into properties. And we can see that we added the content. Now, let's say that after working on this for a bit, we realize we want to undo these changes for whatever reason. Maybe we no longer want the content column. So how do we actually roll back? Well, since upgrading makes the changes, downgrading is going to do the opposite. So we can do alembic downgrade. And then if you want to just roll back this revision, we can see what the down revision is. So we can just say this and just paste that in there. But we can also do a few other things. We can also say -1. So when I say -1, that means I'm going to go back to one revision earlier. And we can even go as far back as we want. So if I say I want to go back to -2, it's going to go back to 2 revisions earlier. But we just have 1, so I'm just going to say -1, or I can just paste in the revision number. And so if I run the downgrade, you can see that it ran this downgrade. And if I go and refresh this, and then go to properties, columns, we can see that we no longer have a content column. And that's how easy it is to downgrade or roll back your database using a database migration tool like Alembic. Okay, so we got our post table. We're not going to worry too much about that. The next part of our application was, hey, let's implement user functionality. Let's make it so that users can sign up and log in. So now we need to create a users table. How do we do that? Well, let's set up a new revision. We'll do alembic revision -m, and I'll say add user table. All right, so we've got our brand new revision, and we have to set up the upgrade and the downgrade. Now for this, I don't want to just type this out, one by one. It would be kind of slow and boring for you guys. So I'm just going to copy and paste this from my notes. And if you want to follow along, just, pause the video and just write this out. But we'll just quickly, walk through exactly what's happening. So once again, we're using the create table method. We're going to create a table called users, and then we're going to set up all of our columns. So we've got a column called ID, which is an integer set to nullable equals false. You notice how I haven't set this to be the primary key here? That's because there's 2 different ways to set the primary key. If we go back to the previous one, we set this to be primary key equals true. But on this one, if you actually go all the way down to the bottom, you can see that we can add in a constraint, SA primary key constraint, and then we pass the name of the column. That's going to be the primary key. So they both do the same thing. It's just whatever method you prefer. Now we've got the email column, which is going to be set to nullable equals false. Same thing with password. Then we've got the created at. And so here it's going to be of type timestamp. And you'll see that this is all coming from SQL Alchemy, essentially. Because if we go to our models and we go to our user table, it's the same thing. Type timestamp, time zone equals true, nullable equals false, server default equals text. Well, that's created at, but yeah. And we're just doing the same thing. So server default, and then we grab sa.text, now nullable equals false. And then you can see that we added a unique constraint under the email field to ensure that we can't have duplicate emails. And then to downgrade, we just do op.drop_table users. All right. And so once again, if you want to see where we currently are, because remember, we had originally upgraded, added the content column, but then we downgraded. So where exactly are we from a revision perspective? Well, let's do alembic current. You can see that we're on 2D18. So we're back on that first revision. And we can also do an alembic, I believe it's history. And you can see the history of our revision. So we created post, add content column to post, and then add user table. And this is the head. So if you want to go all the way to the front to the latest, you would just do alembic upgrade head. And I think there was one more I want to show you. Yeah, that's okay. So we're going to do an alembic. And let's say that we just want to go and go up one revision. So adding one revision is going to add that column back. We can do alembic upgrade, and we can either put in the name of this revision, or we can upgrade one level. If we want to go all the way to the latest, which is going to be adding the user table, we can say head. We can also go up 2 revisions. So if I do +2, that's going to go up to add content column 1. That's the first revision. And then one more, which is going to go up to the latest in this case. So there's a lot of different ways to get there. I'm just going to go to the latest. So this is going to add the column back in the post table and then add the users table. And you can see that it went ahead and added the users table. So if I refresh this, we can now see that we have a users table, and hopefully all of the properties are there. You can see all of these have been set. Constraints, primary key is set, and everything else looks good. I guess one thing just to check is the created at. So if we check the constraints here, you can see that we're going to grab the current time. Perfect. All right, so after we had added the user functionality, the next thing we had to do was we had to implement the relationships between users and posts. So we had to set up that foreign key that linked the user table to the post table, or the post table to the user table. So once again, we're going to do an alembic revision -m. And I'm just going to say add foreign key to post table. All right, we got our new revision. And what we're going to do is first of all, we have to add a column to our post table called owner ID. And that's going to be the one that has the foreign key constraint. So we have to do op.add_column. And we have to specify the table we want to add the column to, which is going to be the post table. And this is going to be sa.column. We're going to call this owner_ID. And it's going to be a type of SA integer. And nullable is going to be set to false. All right, so we've created the column. Now we have to set the link between the two tables, which is going to be the foreign key constraint. And so to do that, this is a little bit confusing at first for me, because the documentation is a little bit hard to read sometimes. So you do create foreign key. Then you have to give it, some arbitrary foreign key name. I'm going to call this posts_users_fk. So this is the foreign key between the posts and the users table. And then we have to specify what is the source table of the foreign key. So this is going to be the foreign key for the post table. So we're going to say source_table equals posts. Then we have to reference the remote table, which they call a referent_table. And so this is going to be the users table. And then we have to specify what is the local column that we're going to be using. So the column in the post table. And that's going to be owner_ID, which is the table, the column that we just created. And then finally, we have to specify the remote column in the users table. And this is going to be set, and we're also going to set the onDelete to be cascade. And yeah, by the way, the remote column is going to be the ID field of the user table. And we want to make sure we have the onDelete as well. And that pretty much, ooh, what happened there? It's a weird way to format things. All right, well, it wants to format it that way, so I'm just going to leave it like that. Let's set up the downgrade now, so we have to undo those changes. We'll do op.drop_constraint. And then we just mentioned the name of the constraint, which is post_users_fk. We have to specify the table that we're removing it from, so it's on the post table. So we do table name equals posts. And then we have to drop the column, so we do op.drop_column. And where does this column sit? It's in the post table, and it's called owner_ID. All right, and so if I do an alembic current, we're on F52, and alembic heads. Let's see what the latest one is. It should be 296, which is this one. So let's do an alembic upgrade head. Go to the latest. And I have a typo, so this should be integer. All right, looks like it ran with no issues. Let's double check that the foreign key is there now. So if we go to posts, properties, constraints, foreign key, you can see that we have our post user FK, and we can see that it points from owner ID in the post table to ID in the users table. And if you want to, you can go under actions and see that cascade has been set to on delete. Now in our post table at the moment, we didn't implement all of the columns that we actually have in our application. So I figured, why not just go in and add it? Might as well. So I'm going to create a new revision. All right, and then we go to that revision. There's really only 2 more columns that we have to add. And I'm once again going to just copy and paste from my notes just because I don't want to waste your guys' time too much. But you can see here, we're going to do an add column and we're going to add it add it to our post table. And then here we're going to specify the parameters of the column. So this is going to be called publish. It's going to be of type Boolean, and nullable equals false. And that's not correct. It should actually be nullable equals true, right? It should be, actually, no, it was false. And then server default is set to be true. So if we don't provide it, it's going to assume it's true. And then the next one is the column for created at. So once again, at the post table, we're going to create a column called created at. It's going to be of type timestamp, nullable false, and then the default means we're going to grab the current time. And to downgrade, we're going to delete those columns. Right, and let's do a Alembic upgrade. And we'll just go, instead of doing head, we can just do +1 just to show you guys how it's going to do the same thing in this case. And so it looks like it ran that. And if we go back to Postgres, refresh this, and then go to properties, we should see we've now got our published and our created at columns. All right, and once again, let's say that maybe we want to roll back. Right? Maybe we want to roll back all the way to back when we just created the post table. We can once again do Alembic downgrade and just provide the revision number of the specific revision you want to go to. So we can go down to add user table. We can go down to create post table. We can go down to any section we want. And it's really up to you. And so let's say this time, let's just go all the way down to, let's go down to add user table. So whatever revision this is, we can do that. All right, and so it deleted a whole bunch of stuff. Looks like it deleted the last few columns that we just added, as well as the foreign key constraint. And so now, if we refresh these tables, you can see that posts, it doesn't have the extra columns we added, and the constraints, foreign key, no longer exist. But fortunately, we can upgrade to a newer version, to one of the more recent versions. So I can do Alembic upgrade +1. So if I do this, it's going to go up 1 newer revision. So right now we're at the add user table. And if you forget wherever you are, you could just do Alembic current. All right, so we're on 32F52. And so if I do an upgrade, right, we're going to go up to, I think it's this one. Because you can see that in this one, this revision is 296, but the previous revision is 252, which is the one we're currently on. So I can do Alembic upgrade +1. All right, and so now we've added the foreign key. If I do Alembic current, we can see that we're on 296. And then if I just do Alembic upgrade, well, Alembic heads, it's going to show us whichever one's the latest one, which is 5B7. So we could just go upgrade directly to that by doing head. The last thing that we have to do now is generate the votes table. But I'm not going to manually create it myself this time. Instead, I'm going to make use of the auto-generate feature. So this is what I was talking about earlier, how we can use Alembic to be intelligent enough to figure out what exactly is missing from our Postgres database and figure out what needs to be created. And the way it actually does that is it takes a look at all of our models. So it's going to import all of our SQL Alchemy models, and based off of the columns that we have set here, it's going to figure out what our Postgres database is supposed to look like. And regardless of what our database is in its current state, we don't need to actually delete everything and build it from scratch. Instead, Alembic is going to be intelligent enough to figure out what columns are missing, what tables are missing, what extra columns do we currently have that we may need to remove, and it's going to figure out what's different between SQL Alchemy's models and our Postgres database, and it's going to make the necessary changes for us. And so the way to do that, and first of all, I guess just to kind of reiterate, the reason we can do that is because we imported the models and then we passed it into this target metadata. So let's run Alembic and we'll do revision. But if we do --help, you'll see that we're going to use one of the flags that we have never used before, which is the --auto generate. So we'll do --auto generate. And then we will send a message once again. We'll say add votes. How about auto vote? Maybe. Because it's auto-generated and I know it's going to add the votes table because that should be the only difference that we have. So we'll run that. And so if I go to auto vote, let's take a look at the changes it's going to make. And so you can see here, the changes where it looks like it's going to create the votes table like I had predicted. It's creating the 2 columns, and then it's going to add the primary key constraint as well as the 2 foreign keys as well. And it's going to even add in all of the on-delete properties and things like that. All right, and so all we got to do now is do an Alembic upgrade head. And now if I refresh this and go to votes and properties, right, we should have the 2 columns and then our constraints and foreign keys look pretty good. Everything looks set. And so that's how easy it was. So no matter what state your database is at any point in time, you can always do the auto generate functionality to get it back to a state that your code expects it to be. And the best part about this is moving forward, let's say I want to go back to my models and I want to change something. So I've got my user model. This time I'm going to add that phone number column. And this is going to be string. All right, so any changes we make, even on a table that already exists, what we can do now is I can do a revision auto-generate. Here I can just call it add phone number. All right, and then if we go take a look at that, we can see that, hey, look, we added our phone number column. And so the only thing else we have to do is do an Alembic upgrade head, and it's going to push out those changes. So let's refresh this and let's just double check. We go to users now, properties, we can see phone number column is now set. And I think that's pretty much going to wrap up everything I wanted to cover from Alembic. So moving forward, now that we have Alembic, we no longer actually need this command in our main.py file. This is the command that told SQL Alchemy to run the create statement so that it generated all of the tables when it first started up. But since we have Alembic now, you no longer need this command. However, if you want to keep it in, it's not really going to break anything. It just depends on how you want things to work, because if it does create the tables for you, then your first Alembic migration isn't going to have to do anything because everything is already there. But I'm going to leave this commented out moving forward because I don't really need it. And it's really up to you guys for what you guys want to do. For the most part, throughout this course, we've been testing our API by sending a request from Postman. And Postman is a great tool, but there's one thing to note, and that is that when you send a request from Postman, you're actually sending a request from your own computer. And it's important to understand this because your API can get requests from different types of devices. You can get a request from a computer or a server, whether that's through Postman or even through curl. If you've ever used curl, it's essentially doing the same thing that Postman's doing. It just doesn't have a nice little GUI. You can also get requests from mobile devices, but more importantly, you can get requests from a web browser. So when a web browser sends a request, using JavaScript's fetch API, there's going to be a slightly different behavior that we have to account for, which we can't take into consideration when sending requests with Postman because Postman isn't a web browser. So what I'm going to do is I'm going to show you exactly what happens when we send a request from a web browser instead of our own computer using Postman. So what I want you guys to do is open up your web browser and specifically go to google.com. It's important that you go to google.com, or technically this is going to work on any website, but I need you to actually go to a specific website like google.com. And then I want you to right click on the web browser and just hit inspect. So this is going to open up the Chrome developer tools. And if you aren't too familiar with it, don't worry. It's just it's a built-in tool that we have in Chrome or any web browser that allows you to makes it easier as a web developer to kind of troubleshoot things. But what we can do is if you go to console, we can actually send an API request to our API from google.com or from our web browser, which is on the google.com domain at the moment. And so I want you to just type this in. We're going to say fetch. So this is how you perform an API request from the web browser level. And we're going to send a request to our fast API. So that's going to be hosted on http://localhost:8000. And then just type in then. So don't worry too much about this, but it technically returns a promise. So we have to resolve the promise. We just say res.json. And then do another then and just say console.log. And I forgot one bracket right here. And so all this is doing is it's sending a request to the root URL of our API, and then it's going to print out the contents of whatever we get back from the server. So when I run this, I want you to notice something. We get an error. It says access to fetch localhost:8000 from origin, and then it has google.com here, has been blocked by CORS policy. So what is happening here? Why is it that I can't send a request from the web browser, but if I go to Postman and I just create a quick new request, and we can just go straight to URL, it resolves just fine. Well, it has to do with this CORS policy. So in this lesson, we're going to take a look at what exactly this CORS policy is and what we can do to ultimately resolve this issue. So what exactly is CORS? CORS is short for cross-origin resource sharing. And so CORS allows you to make requests from a web browser on one domain to a server on a different domain. And by default, when you configure an API, whether it's in Fast API or any other framework or language, you will only be allowed to send requests from a web browser running on the same exact domain as your server. And so what exactly do I mean by that? Well, if our API is hosted on google.com and our website is hosted on ebay.com, ebay.com by default cannot send a request to an API running on a different domain like google.com. It's going to get blocked by CORS. However, if our website was also running on google.com and our API was also running on google.com, then they'd be able to talk just fine by default. And just to prove that to you guys, if we go to our web browser and go to localhost:8000, which is the URL that our application is currently running on, you can see that I get a response back. So our web browser was able to make, and by the way, when I did this, right, it did the same thing as going into Chrome Developer Tools and actually sending a request. And just in case you don't believe me, I'm just going to actually just show you guys even on here. So if I paste it, you can see that it was able to resolve, and we can see the hello world. So the reason why it works on this website is because this is the same exact URL or domain name that our API is running on, right? Our API is running on localhost:8000. So by default, they're able to talk to one another only when the web browser domain is on the same exact domain as the API's domain. So to fix this, if you did want to allow people from other domains to talk to your API, what you can do is take a look at the Fast API documentation and just search for CORS, cross-origin resource sharing. And you'll see that setting this up is really simple. So the first thing that we have to do is from Fast API, middleware CORS, we're going to import CORS middleware. All right, and then just copy this section right here. And I'll explain line by line exactly what each one's doing. And so under the app right here, we'll just paste this in. And it's going to throw a little error here, but we'll come back. You can actually delete that and change that to an array for now. But what we want to do is, first of all, we have to pass in the middleware. And middleware is a term that's used in most web frameworks because it's basically a function that runs before every request. So if someone sends a request to our app, and before it actually goes through all of these routers, it'll actually go through the middleware, and then our middleware can perform some sort of operation. But what we want to do is, first of all, we have to specify the origins that we want to allow. So what domains should be able to talk to our API? Because right now it's no domains. Only if it's running on the same exact domain are you able to talk to our API. So the way we can do it is we can put in, we'll create a list called our origins. And I'll say origins equals, and it's just going to be a list. And here we're going to provide a list of all of the domains that can talk to our API. And before we fill that in, I just want to quickly talk about the other three as well. So our CORS policy can be pretty granular. So not only can we allow specific domains, we can also allow only specific HTTP methods. So if we were building like a public API where people can just retrieve data, we may not want them to allow. We may not want to allow them to send post requests and put requests and delete requests. So we could potentially just allow get requests. And then we can even allow specific headers as well. But for now, we're just going to allow all headers and all methods. And we're going to just kind of drill down based off of what origins can talk to us. And so, if we want Google to be able to talk to us, I can just say https://www.google.com. And so now this CORS policy is set to allow people from google.com to talk to us. And so if I go back to google.com, I just hit the up arrow so I can run this command again. You'll see that I do successfully get a response back and there's no CORS error. However, if I go to a different website, so some website on a different domain like youtube.com, and then we go and then we send the same exact request from the console, right? We once again get the CORS error. And that's because in our list of origins, we're not providing www.youtube.com. So if you wanted to also allow youtube.com, then we'd have to do https://www.youtube.com. So now if I hit the up arrow, we can see that it properly resolves. So you just have to provide the list of URLs that can talk to your API. And if you want to set up a public API so that everyone can access it, then your origins would just be a wildcard. So this means every single domain or every single origin. But if your API is being configured for a specific web app, then you definitely want to make sure that you provide a strict list of origins. So just whatever domain your web app is running on, so that no one else can, accidentally reach our application for some reason or another. It's just security best practices to really narrow down the scope of the origins that can actually access your API. For now, I'm just going to leave this as set to everyone so that when we actually go to deploy this, it'll be a little bit easier from a testing purpose. But feel free to update this accordingly. In this lesson, we're going to focus on setting up Git for our project so that we can start tracking our changes, as well as set up a remote repository to store all of our code. This is going to make the whole deployment process a whole lot easier. But before we set up Git, there's a couple of things that we need to do. Because when you check your files into Git, by default, it's going to check in all of your files. And there's going to be some files that you don't want to be uploaded to a remote repository or even into your Git in general. And so we have to create a file called a git ignore file. And so if you go to the main root folder of your project, I want you to create a file called .gitignore. And it's important that you put the dot in front of it. So it's .gitignore. And so this file is going to tell Git what are all of the files and folders we don't want uploaded to Git. And so some of the common things that you would not want to be tracked within Git is going to be your .env file. So this is going to be all of your environment variables. Obviously, you don't want to check those in, or then if this is part of a public repository, then anyone can see those. But also on top of that, you'll see all of these random PyCache, these underscore PyCache folders. So go ahead and add that in there as well, because we don't actually need to check that into Git. And then finally, we have our folder which contains our virtual environment. We don't want to check that in as well, just because we have no idea if someone else who wants to clone our repository is going to be using a virtual environment. And if they are, then they can create one on their own. There's no need for us to actually upload our virtual environment. It just wouldn't make sense. And on top of that, our virtual environment contains all of the third-party libraries that we've installed. So all of the different packages we installed through pip, including Fast API itself. So all of the code of Fast API is within that virtual environment folder. And so there's no need to actually upload all of that because that's a lot of files that actually take up a decent amount of space, and it just wouldn't be efficient to actually upload those to Git. However, this does create one bit of an issue because if we clone the repository at this point, right, we have no idea what packages we need to install because our virtual environment didn't get uploaded with it. So we need a way for other users, other people on our team to know what packages and dependencies we need our application so that our application actually works. And so the way that we actually do this is, well, first of all, before we even proceed, go ahead and copy this into your git ignore file and make sure you have this before you do anything else, because once certain files get checked in, it's very hard to get them removed. But after this, what we want to do is we want to create one more file and open up your terminal. And what we're going to do is type in pip freeze. So pip freeze is going to dump out all of the different packages and libraries that we have installed, as well as the specific versions. And so this is the information that we want to upload to Git so that if anyone else clones our repository, they'll know the exact versions of every package they need to install. So what we're going to do is we're just going to take this output and we're going to pipe it to a file. And the file name is going to be called requirements.txt. So this is standard convention with any Python application. You want to create a requirements.txt file that's going to contain the version of all of the different packages that you have installed. And so if we check this into Git now, then anyone else can just take a look at a requirements.txt file and then actually install dependencies based off of what's in this file. And so for anyone else that clones our repository, all they have to do, instead of going one by one and installing these, they can just type in pip install -r requirements.txt, and that's going to install everything that's in this file. So this does simplify the process, and it prevents us from having to upload all of those third-party packages into Git. But we've got everything set up at this point. We've got the git ignore file, and we've got the requirements.txt. So what we need to do now is actually set up and install Git on our local machine. If you don't already have Git installed, then in this lesson, we're going to focus on getting installed on your local machine. So just search for Git, and then you can either go to the main page or you can go straight to the downloads page. So I'm just going to select the downloads page. And then here you're going to see the different operating systems we can install Git on. And so just go ahead and select your respective operating system. I'm on a Windows machine, but regardless of your operating system, it's going to be a fairly similar procedure. So I'm going to select this. It's going to download that. All right. And then when the wizard opens, go ahead and select next. Next here. And you can leave everything default here as well. And here and here. Now, this is the one thing that we do have to change. So this is kind of a little bit of a nuisance at this point, but they used to call like the main branch the master branch, but I guess people are offended by that. So now the new term for the main branch is main. So go ahead and override the default branch and just change that to main. Because when you work on GitHub, they've already changed the default branch to be main. So we're going to want to do the same thing. So hit next. And then you can leave everything as default moving forward. There's a lot of windows to go through. And then it's going to proceed to install Git. All right, close that out. And then what you want to do is open up a new terminal. And just type in git -- version. And if it spits that out, that means you've got Git successfully installed. In this video, we're going to set up a remote repository so we can store all of our code on GitHub. And so if you don't already have an account on GitHub, go to the main GitHub page, just go to github.com and just click sign up and then follow those instructions. And then once that's done, just log in and you should see something similar to this, although you may not see an activity window if you just created a brand new account because you won't have any repositories. But just look for a new button to create a new repository. You can also go up here, I believe, and select new repository. So I'll select new. And then we have to give our repository name. You can give it any name you want. I'm just going to give it a dummy name. So this is going to be example fast API, but name it after whatever your project is. Technically, I've already set up Git for my project just so I can track all the changes I've made throughout the course. But I want to make sure that I can walk you through this if you've never done it before. You can give it an optional description, and then you can choose whether or not a repository is public or private. If it's public, anybody can see it. If it's private, then only you can see it. We're going to keep it as public. Don't worry, if you decide to change it in the future, you can change it to private. However, it does make a few things a little bit easier when it's public. So I'm going to leave this as public, and then we're going to leave all of these unchecked. They don't really matter. And we'll select Create Repository. And then you'll see that it's going to give us a couple of steps to follow. So if we haven't already set up Git for our project, these are the instructions we're going to follow. And if we've already set up Git in our project folder, then we can follow these steps. However, we haven't set up Git yet, so we're going to, for the most part, follow along here. But we're going to modify it just a little bit because we don't need to run some of these commands. So go ahead and open up your project in VS Code like you normally do. Then open up your terminal, and we're going to follow these steps, but we're going to ignore the first one. We don't need a README for now. But we are going to do a git init, which is going to initialize Git for our project. And so make sure you're at the root directory of your project. So whatever this is called right here at the top, make sure that's where you're at. And just do a git init. That's going to initialize Git. And you may not see anything different about your folders, but I think it's because VS Code actually hides the Git folder. But when you actually did a git init, if you open up this your project directory and you click on View here and then make sure you select Hidden Items, you'll see that it created a .git folder. So this is where it stores all of the Git information. Then we're going to skip this git add readme. Instead, what we're going to do is we're going to run git add --all. So this is going to add all of the files that we have in our directory into Git. All right, and you'll get a couple of warnings potentially. Don't worry about that. Those won't create any issues. Then we have to commit our changes. So anytime you add a file, you then have to commit it. So we'll say git commit -m. So the -m means we're going to provide a message. So you usually give a message for each commit to kind of describe what changes you're making. So we're just going to call this initial commit. All right. And you'll see that we probably get an error if this is the first time you've ever worked with Git. And that's okay. It's just telling us, hey, we need to set up our user for our account on this machine. So we're just going to run this command right here. And then we're just going to provide the email that we use to register for GitHub. So I'll say git config --global user.email. All right, we set that, and then it's telling us to also set our name. So we'll do that as well. Then we're going to run that same command, the git commit. So if you just hit the up arrow a couple of times, you'll get to that. All right, so we've committed those changes. Then what we need to do is we need to set what our branch is. So here, this is just going to set our main branch to be called main. And so we can copy that, paste it into here. Then we have to set up a remote branch. So this is what's going to allow us to store all of our code on GitHub. So we're just saying like, hey, listen, this is going to be the remote Git repository, and we just provide a URL to it. And so that if you take a look at the URL, it's going to match up with this. And in this case, we're naming it origin. You can technically call it anything you want. So we'll add that. And then finally, we need to do a git push -u origin main. And so this means we're actually going to push all of our code up to GitHub. And you'll see a pop-up asking you to sign in. And there's a couple of things we can do. We can get a personal access token, or we can sign in with our browser. So I'm just going to sign in with our browser. And we just select authorize right here. All right, and it says it's succeeded. So we should be able to go back, and we can see that a couple of things changed. So it looks like, well, that's our authentication. And then you can see that we're pushing all of this stuff up to GitHub. And so at this point, you're pretty much done. All of your code is now stored in GitHub. And we can just verify that by going back to this page and just select the name of the repository again. And you'll see all of our code stored on GitHub now. So at this point, our repository is set up, and we can move on to deploying our application. In this lesson, we're going to take a look at the first of two deployment methods that we're going to cover in this course. So what we're going to do is we're going to deploy our application to a platform called Heroku. And the reason I wanted to make sure to have this as one of the deployment methods was that Heroku has a very generous free tier. And so we can create an account for free, and we can deploy our application absolutely for free without having to pay a single dollar, and we don't even have to provide our credit cards. And I wanted to make sure to add that just because I know for some of you guys that isn't exactly an option, and I wanted to make sure that you can still deploy your application and show off to your friends and family what you have created. And you'll see that Heroku has made it very easy to deploy your application, and it's very easy to push out changes to your application. It's a fantastic platform, and I think you guys will learn a lot on how to actually deploy an application by making use of a platform like Heroku. So we'll take a look at how we can, make use of Heroku, learn about the Heroku CLI so that we can push our application to the platform and ultimately have anyone be able to access our API. Heroku has a lot of really good tutorials on how to deploy applications on their platforms, and they've got one for Python as well. So if we go to Google, just search for Heroku Python, and the first result is going to be their tutorial. It's going to walk us step by step on how to actually deploy our application. But before we do that, there's a couple of things that we have to do. First of all, go ahead and create an account on Heroku if you haven't already done so. It's completely free, so just provide your email and so on. Then there's two other requirements. We have to have Git installed on our machine, which we've already done. And then finally, we have to install Heroku itself. So if you go to the setup section right here, you're going to see the installers for all of the different operating systems they support. So just select whichever operating system you have and get the Heroku CLI installed on your machine. And after you get it installed, usually you have to close out any of your pre-existing terminals and reopen them to actually be able to access the Heroku command. If you have VS Code, a lot of times I've had to just close out VS Code altogether, not just close the terminals, but actually close out the entire application and then open it back up. But after you've done that, if you want to verify if Heroku was successfully installed, just go to your terminal and just type in Heroku -- version. And if it spits out a version, that means Heroku has been successfully installed. And after it's been installed, we want to log in. So we do Heroku login. And then you just press any key right here. And it's going to open up your web browser. You can just log in and then provide your credentials. All right, and then once you're logged in, you can just close out this window. We'll go back to our code, and you can see logging in is done, and we've logged in, and then that's my specific account right there. All right, and once that's done, we're going to go back to the tutorial. And we're just going to kind of follow along. So if you go to prepare the app, you can ignore this. So they give you like a demo application to kind of follow through the tutorial, but we already have our own app, so we don't need to worry about that. If we go to deploy the app, we have to run this command Heroku create. So we have to create an app within our Heroku account. So let's run that command. But before we run that, I'm going to do a Heroku create -- help. And we can see that one of the arguments is going to be the name of the app we want to create. And so if you don't provide a name, Heroku just gives you a random name, but I always like to use a more familiar name so I know that which app covers which one of my applications. And so I'm going to call this Fast API Sanjeev. And keep in mind, these app names are global. So if I deploy my app as Fast API Sanjeev, you will not be able to create an app with the same exact name. And that's because to actually access our application once deployed, the URL is going to be the specific app name embedded in there. So it has to be globally unique. So if it says your app name is already taken, then just try a different one, maybe add a couple of numbers at the end. It doesn't really matter what the name is. All right, and once we've created our app, the next thing that we have to do is, well, actually, before we even do that, I want to show you guys what it actually did. So there's a couple things that happen behind the scenes. And the first thing is if we actually log into our account, I'm going to log in right here. Right, we're going to see our dashboard. So in the dashboard, you can see the application that we just created. Right now, there's nothing interesting. Nothing's been set up with it, so we don't actually see anything. But the second thing that it also did was if I type in git remote, this is going to show all of the remotes that have been set up for our Git. And we can see there's two now. So there's Origin, which is the one we set up originally, and that's GitHub ultimately. But Heroku added a second one. And so this is ultimately how we deploy our application, because instead of doing a git push origin main to push it out to GitHub, we can just do git push Heroku main, and that's going to push out our code to the Heroku platform, and then it will then create an instance for our application. So let's go ahead and do that. We're going to do a git push Heroku main. And this is going to take a little bit of a while because it's got to, set up Python. It's got to do a few other things. It's got to install all of our dependencies. before it can actually get our app up and running. So I'm going to pause this video and then I'll touch base with you guys once that's complete. All right, so our application has successfully been deployed, and you'll see that in the logs, Heroku actually gives us the URL of our application. So I'm going to copy this URL and we're going to just open this up in the browser. And if you let this run long enough, you're eventually going to see an error. So it looks like something in our application is broken. And this is to be expected because there's still a few more things that we have to do to actually get this set up. Because if you take a look at what we've done, we pushed out our code to Heroku, right? But Heroku has no idea how to actually start our application. What is the command? It just knows that this is a Python app, but it doesn't know what it is. It doesn't know that it's a fast API app. It doesn't know that we're trying to build out an API. It has no idea. And when we deploy to our development environment, we ran uvcorn and then, app.main and then app, right? But we haven't given that command to Heroku. How does it have any idea that our code is in main.py and that within the main.py file, we have our app instance stored in a variable called app? It has no idea. So what we have to do is we actually have to create a file that's going to tell Heroku what is the exact command that we want to run. So inside your root directory, so just kind of collapse all the folders. Inside your root directory, so just right click here, create a new file, create a file called a Procfile. So I've already got this in here. It's going to be in the GitHub repo, so you can take a look at it and make sure you capitalize the P. And actually, if you take a look at the tutorial and we go to the next one, which is define a Procfile, this is going to just explain what the Procfile is, but the Procfile just tells Heroku what is the command that we need to start our application. And so here we give it a process type. So since this is a web application that's going to be responding to web requests, we want to use the word web, and then we specify the exact command that we need to run. And so in my Procfile, a couple of things have been set up. So we run the command uvcorn app.main and then app like we've done before. We're not going to pass in the -- reload flag because this is production. We don't want it to automatically reload on changes because there should be no changes. We do have to provide the host IP. So this is just saying that, hey, we should be able to respond to requests to any IP. So whatever IP Heroku gives us, this is going to accept it. Then the next flag is going to be the port flag. So what port should we run this on? If we don't provide a port flag, then it's going to default to port 8000 like it always has. However, the thing about Heroku is that they're actually going to provide us a port. So we don't know what this port is ahead of time. So we have to be able to accept this port regardless of what it is. And so it's actually going to pass this down as an environment variable. So anytime you want to accept an environment variable or reference one, you can just say $ and then curly braces. So we're really just saying we want to take whatever value Heroku gives us with the environment variable of port, and we want to assign it here. And then this is just giving it a default value of 5000 if they don't provide one. However, Heroku will always provide a support, so I don't think we even need that. And so after you make this file, you're then going to have to push out these changes to Git once again. And since I already had this file, there's nothing to change in my Git, so nothing will get pushed out. So I'm just going to change some random code. I'm going to delete this 1, 2, 3, 4 here so that I can at least have some changes in my code. You guys will already have changes in your code because you added the new file. So then go ahead and do a git add --all. So it's going to add all the changes. We're going to do a commit. And we'll give it a message of added Procfile. And then we do a git push. And then what do we push to? Well, first of all, moving forward, we want to make sure that this is stored in GitHub. So let's do a git push origin main. This is going to push it to GitHub. And then now we want to actually push out these changes to Heroku so that we can actually get our application up and running. So we'll do a git push Heroku main. And once again, we have to kind of wait through this entire process. Okay, so it's now finished. Once again, we're going to go back to the URL it's deployed at. And I'm just going to do a refresh to see if we fixed our issue. And the fact that it's still spinning for this long most likely means that we did not fix our issue. But I already know the exact reason why this is. And so we will take a look at exactly what is causing our application to not successfully get deployed in the next lesson. Anytime your application isn't working on Heroku's platform, they have a really easy way of accessing logs. So we can say Heroku logs, and then I'm just going to do a -- help just to see what options we have. And so here we could specify the app, or we can just dump the logs for all of our apps. But what I'm going to do is I'm going to pass in the -t flag so we can tail the logs as things happen. So if I do a -t and we scroll up, you can see that we've got a couple of different errors. And so it looks like there's some issues with settings, which, is the Pydantic model that we've set up for retrieving our environment variables. And it's saying that there's a couple of validation errors for our settings model. And it says that, hey, look, we don't have a database hostname, we don't have a database port, password, or any of the other information. So there's some issue with our environment variables. And this makes sense because in development, we use our .env file to provide all of the environment variables into that settings model right here. And we pass that by specifying the env file. However, we did not check our env file into Git. Remember, in Git, we used the git ignore file to make sure we excluded that because we don't want to actually check that into Git. So how does Heroku know what all of our environment variables should be? Well, they have and so we actually have to add those environment variables either through the command line or through the dashboard. But before we can do that, we need to actually get a Postgres database because right now we don't have a Postgres database. So what would we even provide for database hostname and port and password and things like that if we don't have one? So let's create one. And once again, Heroku provides us with a free Postgres instance that we can have access to. And that's one of my favorite parts about Heroku is that now we have access to Postgres. So let's go to Heroku, Postgres, and I'll just say tutorial. And this is going to take us to their dev center. So this is going to show us actually how to create a Postgres instance. And so Postgres is one of their many add-ons. If you want to actually go to their website and see all of the different add-ons they support a ton. If you want to read this add-on, you can get that added. But in this case, we want to create a Postgres instance. So we do Heroku add-ons, create, then the type of add-on, which means it's going to be PostgreSQL, and then plan name. So we are under the hobby dev, which is essentially the free one. And that's going to actually create a Postgres instance. So let's run this and just Control-C out of this. And let's just do a -- help real quick, just to see what other flags we have. And that should be fine. We don't need to actually provide any other flags. So let's run this. And Heroku is actually going to create our Postgres instance. And keep in mind that for Heroku to spin up a Postgres instance, it does take a little bit of time, but we can actually monitor that in our dashboard. So if we go back to my dashboard and do a refresh, you can see that this is the new Heroku instance. And I can just click on this and we can see some more information. It's going to open this up in a new tab. And if you want to, we can go into these settings. And here we can take a look at our database credentials. So if I view my credentials, you can see that this is the IP address my database lives on. This is the actual database name. So we don't get to create our own database name or our own database within Postgres. They give us a fixed name, and that's perfectly fine. And then this is going to be the username that we're going to log in as. This is the port it's running on. And then this is our password. And they also provide us the full Postgres URL if we want to use that. So now that we have this information, feel free to save this real quick. And I'm actually just going to do a quick screenshot and save this in my notes so that I don't have to keep bouncing back and forth. And now let's go back to our application. And if we go under settings, this config vars is where we actually provide environment variables to our Heroku instance. And by the way, Heroku calls our instance dynos, but you can use either term you want. And so you could see all of the config variables that have been set, and there should be nothing except for one. So when you add a Postgres instance to your application, what happens is Heroku automatically adds an environment variable called database URL, and it's going to contain the entire PostgreSQL URL. And so we could go into our application and then update our code so that in the database.py file, instead of breaking things down like this, we can just provide one specific URL and just put it in as settings.database _URL. However, I don't like to change my code. I like it just the way it is. So instead of using the default environment variable, we're going to actually break this URL out into multiple different environment variables. So just open this up and take a look at all of the environment variables that we expect by going into our config.py. So we need all of these set. So we're going to add one for database hostname. And from the URL, if you forgot what the host name is, and actually, I'm going to just open this one up in a new tab and then open up, actually, I don't even need to open up this one. I just need to flip between these two. So the host name is right here, but you can get it from this URL just by clicking on this icon and then just grabbing the IP address. But it's such a small little window. I hate having to do that. So I'm going to close that and just bounce between these two links. All right, so let's grab the host name. And we'll add this one. Then the next one is going to be the database port, password, name, and username. So let's just write those out. Database port, database username, database password, and then database name. I think that's it. Database port, password, name, username. And then we have to add the stuff for our token. So we got secret key, algorithm, and then the last one. And then now we can provide in the values. So the database port, we can see from here, it's going to be the default 5432. The username, and then here we'll grab the password. And then the actual database name here. The secret key, I'm just going to use whatever we used in development. Not actually recommended, but I'm just going to keep things as simple as possible for now. But you can provide any secret key you want. And I'll say in production, it'll expire after 60 minutes. All right, and so now we've got all of our environment variables set up, and our Postgres instance is already up and running. So I think at this point, our app should work. So we'll try this out again. So now that we set those new environment variables, how do we actually restart our Heroku instance? Well, let's do a Heroku apps -- help. And let's see if there's a restart. So there's apt create, destroy, and it doesn't look like there's a restart. So we can't actually use the apps argument to restart our application. Instead, we have to do Heroku ps -- help. So now we can see that we do have access to restart. So we're going to do Heroku ps restart. And that's going to restart our dyno, which is our Heroku instance. And once again, I'm going to do a Heroku logs -t to tail the logs. All right, and so now you can see those previous errors are gone, and we were now able to successfully run the startup command. And you can see that we actually got past a specific port of 34731. And so that's why we ultimately had to provide the port variable, because this will change every time we restart it. However, we don't actually need to use that specific port number in the URL that we need to access. So let's get our app URL, which I already forgot. And if you ever forget your URL, you can just type in Heroku apps info, then the name of the specific app, And then it's going to give you all of the specific information. So you can see this is actually where the Heroku Git is being stored. We can see that we have one instance in this case running the web. And then we have our URL down here. So I'm going to copy this. And you can see that we get message hello world. So it looks like things are working. If I actually go to /docs, let's test that out. And so now we have access to documents. I'm going to minimize that. So it looks like things are working. However, if I try to log in, whether it's either through the documentation or if I actually send a request from Postman, you're going to see that there's going to be some issues. So here I'm going to actually, I can't even log in. I have to create a user first because this is a fresh deployment. So let's go to users and we're going to create a user real quick. And I'm going to just try this out and put in whatever name you want. Now, so this is sanjeev@example.com. My password will be password123. We'll execute it. And you can see that we get an internal server error. So what is happening? Why can't we exactly create a user? Well, like usual, we're going to go back to our logs and we're going to see what happened. All right, so we can see the SQL that's getting inputted in the logs, and it looks like there's some kind of error with the SQL. And I don't know if that's going to give us a more specific error that's going to actually help us. I think that's all it's going to provide us in this case. But I think you guys can guess exactly what's happening. We deployed a brand new instance of Postgres. But right now, if we actually connect to our Postgres, you're going to see a few different issues. So I'm going to actually connect to this Postgres instance. And to create a Postgres instance, just right-click here and then select Create Server. So this is going to allow us to connect to another Postgres. And I'm going to call this Heroku-Postgres. And then here we're going to provide the same exact connection information. So we'll go back to Settings. We'll get our credentials. Okay, and so now we are successfully connected to our Heroku Postgres instance. And if I just drop this down and then go into databases, you'll see a ton of different databases. Keep in mind, we won't actually be able to access most of these. So the reason Postgres is able to, the reason Heroku is actually able to provide this for free is that they have one instance of Postgres, and then they give you one database within that instance that you can access, but only you can access that specific database. And so our database is D58. And I don't know if there's an easy way to search for databases. Let me see if I can right-click this. Nope, it doesn't look like there's an easy way, so I'm just going to have to scroll down to D5. And then what are the next letters? D5, 8RE05. All right, so I finally found my database. You'll see it's the one that I have access to, so it's actually colored. And if I just open this up real quick and go into schemas, public, and then tables, there's nothing in there. So that's really the reason why our application is not working, is because we have a brand new Postgres instance, but we haven't actually set up our tables or our schema. And so this is where Alembic is going to come into play once again. You'll see that since we already have all of our revisions set up, getting our production database to match our development database will be as simple as just running one simple command. So we'll take a look at that in the next video. In our development environment, we used Alembic to manage our database schema. So Alembic was responsible for creating all of those tables. And since we have all of these revision files within the Alembic folder, we can essentially track all the changes that we make. And so to actually get our development database up to date, we just ran alembic upgrade head. And that would go to whichever one of these is the latest revision and make sure that our Postgres instance matched whatever that is. In our production database, because in our production database, it's going to be no different. We're going to just run alembic upgrade head on our Heroku instance, and that's going to ensure that our Postgres database gets updated to our latest schema. And because we've checked all of these files into Git, because all of the Alembic folders was added to Git as well, that then our Heroku instance has access to all of our revisions. And so when we run Alembic, Alembic can keep track of all of those changes as well in our production server. And it's important to understand that we never run Alembic revision on our production server. We only run Alembic revision on our development server when we're staging out these changes. In our production server, whenever we want to push out those changes, we just do a git push. So we push out the code, all of our code changes, as well as all of the Alembic revisions to our production server, and we just run an Alembic upgrade head. It's as simple as that. So let's do that now. The first thing that we need to do is we got to figure out how do we actually run a command in our Heroku instance. I think your first guess is probably going to be, do we add another line into this Procfile that we can kind of call whenever we want to? Not exactly, although maybe you can do that. But if we go back to our tutorial and go to start a console, we can run a specific command on our Heroku instance by doing Heroku run and then the specific command that we want to run. So let's try that out. And you can even drop into the bash shell. So there's a lot of flexibility, but we're going to just do a Heroku run. And then we want to provide the command that we want to run. I'm going to put it in quotes. I don't remember if it's a requirement to put it in quotes, but I'm going to do that just in case. So we'll do Alembic upgrade head. All right. And you see that it's running that command right now. And take a look at the logs, right? You can see that not only did it get our Postgres instance up to the latest revision, it has all of the other incremental steps added in as well. So we can roll back to any of them just like we did in development. And if we go back to pgadmin, I'm going to just refresh tables. And if we go to our tables, you can see that we have all of our tables here now. And just in case, because I believe we crashed our application maybe when we tried to, create a user without having a Postgres database or table set up, I'm just going to do a Heroku PS restart again, just to restart the instance, just in case. And now I want to go back to here, and we're going to just go back to the root URL to see if that works. And that works. That's perfect. We'll go back to docs. We can see that that works. Now let's try to create a user. And so I'll do try it out. And I don't even feel like changing any of these values. Technically, these should still work. So let's just try that. And we got a response back. And look at this. We got a 201, and we can see the user that was created. So it looks like our application was now successfully able to access our database. If we go into the users table, right click on this and just do a view, edit all rows, we can see the one user that we created. All right, and so that's pretty much it. We've successfully deployed our application. The last thing that I want to show you guys is how do we push out changes to our application? So let's say that I go into my app, and right now I go into main.py, and I see that this just says message hello world. And let's say I make some kind of change. And let's say I just add a whole bunch of exclamation points or something. Just keep it simple, just to show you guys, regardless of what change you make, the steps are going to be identical. So we make some changes. The next thing that we have to do is we actually have to push out those changes. So first of all, you're definitely going to, push out those changes to your GitHub repository. So we'll do git push origin main. So that's going to push it out to GitHub. Well, sorry, I forgot to do a git add -- all. So we actually have to add those changes and then commit those changes. So we'll do git commit. Then we'll do a git push origin main. So that's going to push it out to GitHub. And then finally, to actually push those changes out to our production environment, we'll do a git push Heroku main. All right, and so that's pushed out now. And if we go back to our application, I'm going to go back to the root URL, and we can see that we now have the extra exclamation points. So we have successfully pushed out our changes. All it took was just one simple command. And keep in mind that if you make changes to your code, that's all you have to do. However, if you make changes to your database, so you go into Alembic and you create a new revision, then we have to follow the same exact steps. But on top of that, we have to do the Heroku run Alembic, upgrade head so that we actually push out those changes to the Postgres instance. But there you guys have it. You have successfully deployed the application that we have spent building the past couple of days. And so feel free to show this off to your friends and family. Feel free to make as many changes and modifications, really start to play around with it. Try to expand on the functionality of our application and just keep learning, I guess. For the second method of deployment, we're going to see how we can deploy our application on an Ubuntu server. And it's important to keep in mind that it does not matter where you host your Ubuntu server. You can run it on any of the major cloud providers, AWS, Azure, GCP. You can run it on DigitalOcean. You can run it on your local machine. Yeah, if you have VirtualBox installed on your computer, you can run it on Raspberry Pi. It doesn't matter. The steps are going to be identical as long as you run it on an Ubuntu server. Now, what we're going to do in this course is I'm going to show you guys how to deploy it on DigitalOcean, just because it's $5 a month. It's cheap. It's a fixed price. If you deploy it on AWS, then the price is it varies. And if you run it all month long, then it could spike up well past $5. So this is kind of the cheapest solution. But keep in mind, like I said, these steps are identical regardless of where you deploy. I just want to focus on making sure that you guys understand the steps that needs to take place to actually set up your Ubuntu server to be ready to host your application. And so if you don't have a DigitalOcean account, go ahead and make one. And then once you log in, you'll see this window. And what we want to do is select Get Started with the Droplet. So we'll select that. And what we want to do is we want to select Ubuntu 20.0.4. That's the latest version at the moment. If you're watching this in the future, you could probably grab one of the newer ones. Most of these commands are going to be identical. But if you wanted to make sure that you don't run into any issues, select the same exact version. Then for the CPU options, you want to select regular Intel with SSD. That's going to be the cheapest. And then you want to select the cheapest one right here, which is $5 a month, or 0.007 per hour. What is that? 7/10 of a cent? All right. And then select your data center. So I'm just going to select whatever's closest to me. I'm on the East Coast, so I'm going to select that. And then nothing else for the most part really matters. We can leave everything as default. And then you have two options for authentication. You can use SSH keys if you're familiar with how to work with that. If you're not, then start out with password for now. It's just a little bit simpler. And you'll see that DigitalOcean has some strict requirements for passwords. So you're probably going to have to try this a couple times before you find one that actually matches their criteria. And then here we can just give this a specific host name. I'm just going to call this Ubuntu-Fast API. It's nothing more than really just a tag. And that's all we have to do. We'll select Create Droplet, and DigitalOcean will create our Ubuntu VM. All right, and once the loading bar finishes, you should see a public IP. This is the IP that we're going to use to connect to our virtual machine. And so we'll take a look at how to connect to this in the next video. To connect to our Ubuntu virtual machine, we need to open up our terminal. So just search for terminal on Windows. If you're on Mac, you can do the same thing. Just search for terminal. And then on Windows, you can select command prompt. I installed another terminal, so I'm actually going to use that, but you can use this one as well. You can even use the built-in terminal within VS Code. It's all going to be the same thing. Okay, and to connect to a device, we have to use a protocol called SSH. So we do SSH, and then we have to provide the username that we want to connect to the device. And so this is going to vary depending on where you're deploying your virtual machine. On DigitalOcean, they're going to create an account for the root user. So this is like the most privileged user. This is where you can ultimately do anything with the device. You have unlimited access. So we're going to do SSH root @ and then you do the @ symbol, and then we provide the IP address. So I can just hover over this, select copy, and then paste it in here. And at this point, you'll get this, fingerprint message. So just hit yes. And then it's going to ask you for the password. So this is the password that we provided when we created the virtual machine. And at that point, we are now successfully logged in. And so you can, if you run ls, this is just going to print out the contents of your current directory. And so it looks like we've got one folder in our directory right here. But this is our Ubuntu virtual machine. And anytime you get a brand new Ubuntu virtual machine, the first thing that we want to do is we want to update all of the installed packages. So we want to make sure that it's up to date, right? It's just like installing any other operating system. And to run that, there's two commands that we want to run. So we do sudo. So this is going to give you, well, technically we don't need to run sudo because we're the root user, but if for some reason you're not the root user, then you always have to use the keyword sudo. So we do sudo apt update. And then the second command, we can do two and signs and say sudo apt upgrade. And then pass in a -y flag. The reason we pass in the -y flag is because if you don't pass in this flag, what's going to happen is it's going to do a few things and then a prompt will come up where you actually have to hit yes. And I always hate having to hit yes. When you pass in the -y, you can let it run, and then you can just go do something else, go get some coffee, because it is a fairly long process. If you get this pop-up, it doesn't really matter what option you choose. You can say keep local version currently installed or install the package maintainers version. I'm going to select this one, but it shouldn't make a difference. So once all of those packages are up to date, we need to install a couple of extra packages. And the first thing that we need to do is, well, let's actually check what version of Python we're running on this machine. So if I do Python -- version, all right, so it doesn't look like Python's installed. However, if I do a Python 3 -- version, we could see that we actually do have Python. It's just we have to use Python 3 because a version 3 of Python was installed. And so if you see anything that starts at 3.8.10 or later, you should be good. However, if you want to, you can always do a sudo apt install Python, and then I think you could just do a dash and specify the specific version that you want. But you can figure out how to do that by taking a look at the Python documentation. 3.8.10 or later is more than good enough for us. So we have Python. The next thing that we need to do is we need to install pip. And let's actually double check and make sure that it's not already installed on our machine. So we could just say pip -- version. We could see there's no pip here. However, let's try a pip 3 -- version. And it looks like we don't have pip installed, but it's giving us a little hint on how to install pip. So we can do sudo apt install Python 3 - pip. And we'll hit Y for yes. And once that's done, we're going to use pip to actually install virtual env, because we are going to make use of virtual environments on this machine as well. So we'll say sudo pip 3 install virtual env. And so now we should be able to use the virtual environment command. The next thing that we have to do is install Postgres on this machine. So we'll run sudo apt install, and then the libraries that we need are PostgreSQL and PostgreSQL-contrib. And then we'll do a -y so that we don't have to hit yes. Okay, so we've got Postgres installed. How exactly do we connect to it? So what we're going to first do is, before we try to connect to it from our local machine, I want to connect to it from the actual Ubuntu computer itself, the Ubuntu virtual machine. And so we're actually going to take a look at the CLI for accessing the Postgres database. And so the tool that we use to do this through CLI is called PSQL. Right? And we should be able to have access to it. So if you do PSQL - version, you should see that it should respond back with something. So that means PSQL is installed. And if I do a PSQL -- help, it's going to show us the different flags that we can pass in. But the main flag that we want to pass in is the -u, so we can specify what's the username that we want to connect to. So let's say PSQL, then -U, and then our username. And we know that when we install Postgres, it's going to install a user on the database called Postgres. So that's what we always use to connect to it by default. And so we say Postgres. And if you want to, you can specify the specific database you want to connect to. I believe there's a flag. It might be -d. Yep, the database name. So you could technically say -d Postgres, but Postgres is going to be the default, so you can leave that off. And we're connecting to our local host, which is going to be the default as well, so we don't need to pass in that. And the port, we can also pass that in. The default is 5432, which is what it's running on. So we don't really have to touch anything else, and we're going to try and connect like this. So let's see what happens. All right, and we get this error. It says a PSQL error, fatal, peer authentication failed for user Postgres. So for some reason, it's saying peer authentication failed. And this is a special meaning, right? It sounds like a regular login failure, but it's not. And it's because Postgres, when you install it on Ubuntu, it has a special way of authenticating users by default. So when it comes to local authentication, and what I mean by local authentication is the Ubuntu VM connecting to the database itself. That's what a local authentication means. Whereas if I'm connecting from my Windows machine to the Postgres database on this Ubuntu VM, that is not considered local authentication. So since we are on the same machine that we're trying to connect to our database, Postgres considers this a local authentication. And on Ubuntu, we have a special configuration called peer authentication. Now, this is the default configuration for Postgres. And what peer authentication does is it actually takes the user that's logged in to the Ubuntu machine and it tries to log in as that user, essentially. So even though we pass in the -u flag, since I am technically logged in as the root user, all right, Postgres is going to error out because it will only allow a Ubuntu user called Postgres to be able to log in as the user called Postgres on the Postgres database. A little confusing, right? But it actually connects, it actually obtains the username from the Linux kernel. So whoever you're logged in as, that's the only person you can log in as. And so what we can do is, first of all, because this is the default configuration, Postgres understands that. So Postgres actually created a user on our Ubuntu VM called Postgres. So if you want to see the list of all the users on your Ubuntu machine, you can do a sudo cat /etc/passwd. And you can see all of the users that have been installed. And you can see that it actually created a user called Postgres on this machine. So I'm going to change that user. So we can do that by doing su dash and then the name of the user, so Postgres. Right? And notice how we changed to this specific user. And so now if I try to do psql -u Postgres, we can now log into the database. So if you see this, that means you're successfully logged into the Postgres database. And while we're logged in here, before we do anything else, because first of all, we're going to get rid of that peer authentication because I hate it, we want to create a password for our Postgres user. And to assign a password to this user, we can say \password, and then the name of the user that we want to assign a password to. So we're going to use the Postgres user. And then here we're going to provide our password. All right, and so now we should have a password. And I'm going to exit out of here. So to exit out of the Postgres console or terminal, whatever you want to call it, you just do / and then Q for quit. And then we're still logged in as the Postgres user. And so if you type in exit, it's going to take us back to the root user. There's going to be a few more things that I want to change to our Postgres installation. And so anytime you want to modify the configs for Postgres, what we want to do is we want to move to a different directory. So the command to move to a different directory is cd. And then we specify the path to the directory. So we want to go to /etc. So generally, any application you install on Linux or an Ubuntu machine, usually the configs for that package or that application is going to be in /etc. And then here I'm going to say Postgres /. And then if I hit tab, you can see that it's going to autocomplete. So you're going to specify whatever version of Postgres you ran. And so in this case, I have Postgres 12, but if you installed a version 13, then you would put in, it would be a folder called 13. And then we will go to main. And if I type in ls, we'll see all of the files that we have in this folder. And the two main files that we want to focus on are pg_hpa conf. So this is where we configure Postgres, as well as postgresql.conf. And so we're going to open up postgresql.conf. So I'm going to say sudo vi postgresql.conf. And we want to kind of scroll down. And we want to take a look at the connections and authentication section. And so if you take a look at the default configuration, we can see that under listen addresses, it's only going to allow localhost to connect to our database. That means only when we're logged into this Ubuntu VM can we then log in to this Postgres database. It is not going to allow me to take pgadmin on my Windows machine and connect to it remotely. And so I want to change this. And technically, you don't have to do this, but if you do want to be able to connect to it remotely, then you want to change these configs. And so I'm going to put this config, we're going to say listen_addresses equals. And then here you would provide the IP addresses. And so, if you wanted to only be able to connect to this database from, your office, then you would put the IP address or domain name of your office. If you want to allow all IP addresses to connect to it, you would just do a star. So that's what I'm going to do. It's going to allow me to connect to this regardless of what computer I'm on or where I am on the network. However, it generally, when it comes to best practices, you want to really narrow down the scope of the different IPs and domains that can access your database, because that's the most important part of your application. You want to make sure it's as secure as possible. All right, so we'll save this. That's the only change we need to make in this file. Then the next file that we need to change is pg_hba_conf. So we'll do the same thing, sudo vi pg_hba_conf. And we're going to scroll down. And we're going to take a look at our default configuration. So I did mention that when we connect locally, it uses a peer authentication. So you can see that for local connections, and I forget what the second column is if we actually scroll up. Well, I got to go up. Actually, let's see what the second column is. Okay, so this is going to be the format of it. So this is going to specify what type of connection, then what database this connection should be associated with, or this rule should be associated with, what's the user, and then what's the method. Well, we also have address and method if you are connecting remotely. So we want to change this. So we want to say for local users, regardless of what database they connect to and what user they connect as, we want to make sure that we do not use peer authentication. We use regular password-based authentication, which is MD5 in this case. And so here, we're just going to change this. So this is saying for any database, this rule is going to apply. For the user Postgres, we're going to say, instead of peer, we want MD5 like we have here. We'll say MD5. And we're going to change this one to MD5 as well. And then lastly, for these two sections right here, these are going to be for remote connection. So if I want to connect from my Windows machine, this is the rule that's going to apply. So this is saying that for hosts, for any database, any user, right now the only IP addresses that can connect to it are going to be 127.0.0.1, which means localhost. So that's effectively blocking all remote connections. So I'm going to go here, and we are going to change this. And I'm going to say 0.0.0/0. So this means any IP address. And then just to keep things nicely formatted, I'm going to move that over there. And then we're going to do the same thing for IPv6, which is what this line is doing. And I'm going to say this. So this is the syntax in IPv6 for saying any IP address. And that should be all of the config changes that we need to make. And so I'm going to exit out of here and make sure to save it. All right. And at this point, you probably think the changes have been made. However, generally, when you change any configuration file, you actually have to restart the application for the changes to take effect. And so to restart an application, you do systemctl restart, and then the name of the application. So this is going to be PostgreSQL. All right. And it should be running at this point. So let's try this out now. Right now, we are still logged in as the root user. So remember, before we actually had to change to the Postgres user on our Ubuntu machine before we can log in as the Postgres user. So now instead, I'm going to do psql-u Postgres, and I want to see if I'm able to log in. And so now I actually get a prompt for a password. So it looks like things are working so far. So I'll try my password. And now we are successfully logged in to our Postgres database. That's perfect. Now let's actually try to connect to it using pgadmin. And so pgadmin, I've got my local machine, which is right here. If I want to add a new machine, I'm going to right click on servers. We're going to select create server. Give this a name. I'm going to call this fastapi-prod. Call it whatever you want. Connection details. Here we're going to provide the IP address. So I already forgot what's the IP address of our machine. We logged in 134.122, whatever that is. We're going to provide this. That's the default port. That's the user we're going to connect as. And then if we want to, we can put in a password here as well. All right, and now we are successfully logged in to our production database. If I open this up, take a look at the databases, we just have the one default database that always gets installed. Till now, we've done everything as the root user, and it's generally frowned upon in the Linux world, regardless of what flavor of Linux you're using. It could be Ubuntu, CentOS, Red Hat. You generally don't want to be logged in as the root user because it opens the door for potential security vulnerabilities, and it opens the door for you to potentially break your machine. And so what we're going to do is we're going to create another user. This user is going to have root privilege, so he'll still be able to make any of the changes, but it's better than being logged in as the root user. And more importantly, when we actually install our API, our Python application, we're going to have our non-root user be the one responsible for starting it. We don't want the root user to start the application because then we're giving our application root access to our machine, and that is very risky. So instead, we want a non-root user to start our API. So on Linux, to create a new user, you type in the command usermod. Sorry, not usermod. We do add user and then the name of the user. So pick any name you want. I'm going to do Sanjeev in this case, but you can name it like Fast API or whatever you want. And then it's going to ask you for a password. So put whatever password you want. And then you can provide your name, but none of that really matters. And just hit Y here. And so we've now created a user. And what we can do is, if you want to, you can do a su dash and then Sanjeev. And then it's going to move you to the Sanjeev user. Or what you can do is you can exit out of this connection and then exit out of here altogether. So now we're back on our local machine. And instead of when you do an SSH root at whatever, you can change this to the new user that you just created. And so that's going to log you in directly as that user. Now, this user by default doesn't have root access. So if I try to do, sudo apt upgrade, right, it's going to ask for sudo password for Sanjeev, and I'll put my password in and take a look at the error that we get. It says Sanjeev is not in the sudoers file. This incident will be reported. So anytime you create a user, you have to give him sudo access or root access so that he can actually perform operations that require root privilege. So we're going to have to exit out of here. Once again, I'm going to log back in as the root user. And to give a user root access, we run the command usermod, and then we pass in the flag -a and then capital G. Make sure it's capital. And we say sudo and then the name of the user. So I created a user named Sanjeev. So I'll just put that in. And so at this point, the user Sanjeev has root access. So let me exit out of here again, and we're going to connect back as the user Sanjeev. And so now I'm going to run sudo apt upgrade. And so if I try that, put my password in, you can see the command run. So we now successfully have root access. If you type in pwd, this is going to tell you the exact directory that you're in. So I'm in a folder called /home/Sanjeev. So whatever your username was created as, right, your default home directory is going to be /home and then your username. And so while you're in your home directory, and if you don't know how to get to your home directory, you could just say cd and then tilde. So that's going to take you to your home directory, or you can do cd/home and then your username. That's going to take you here. Whoops. All right. So once you're in your home directory, what we're going to do is we're going to create a folder for our application. Technically, you can put this anywhere on your machine. I'm just going to put it in my home directory. So I'm going to call this this folder app, or we could call it fast API. It doesn't really matter. So I'll say mkdir. This is the command to create an app. Create a directory. I'm going to call this app. And then to move into that app, we do cd app. And within this folder, what we're going to do is just like we did on our local machine, we're going to create a virtual environment. So I'm going to say virtual env, and then we'll call our virtual environment venv. All right, and then if I do an ls -la, let's just make sure I created the virtual env folder. Then to activate our virtual environment, we'll type in the command source. Then we go into that folder, the bin folder, and then the activate file. All right, and then we should see this little nugget right here. So this is going to let us know that we are currently in a virtual environment. And if you ever want to get out of the virtual environment, you can just say deactivate. Within our app directory, we're going to create another folder called source. So this is going to contain all of our source code. So we'll cd into the source. And now what we're going to do is we're going to copy all of our code onto this machine. And so how do we do that? Well, since we already have it stored on GitHub, all we have to do is just go to the URL for our repository. So this is my repository that I created. This is the main one called fast API-course. This is public, so any of you guys can access this. But you're going to go to your specific repository. And once you get to the repository, this is going to be the URL. Or you could just select code right here, and then this is going to give you a little link to copy. So we could just copy that. And then we can go back here, and we can say git clone, paste that in here. And then before you hit enter, hit space, and then dot. So that's going to install it in this current directory, and it's not going to create another directory that's the name of my repository, which is kind of annoying. I don't actually want a directory called fastapi.course. So we'll hit that, we'll run it, it's going to clone it. And at this point, if I do an ls, we should see all of our specific code. Great. Now, before we do anything else, let's reactivate our virtual environment. So we'll say source venv libbin activate. All right, we've got our virtual environment set up again, and we're going to move into our source directory. And if you recall, remember, we don't have any packages installed, so we don't even have FastAPI installed, but we do have our requirements.txt file. So if I just cat that real quick, if you forgot what that was, that's going to tell this machine exactly what version of every single dependency we need to install for our application to work. And so we can just install all of those with one command by doing pip install -r requirements.txt. All right, so I got an error, and this was expected on my end because when I was running through this, I ran into this error. And so if you see this error right here, anytime you see red, it's never good. But what you want to do is you want to go right about here where it says include and then libpq-fe.h. This is implying that we're missing a package that's probably called libpq. If you actually search this error, you're going to get the same result. So if you run into this exact issue or even another issue, just look for the library mentioned right here where it says that include line, right? And just search for that library and just see how to install it. Okay, so since it said we're missing this library, I'm going to do it's not actually a pip install. We actually have to do an apt install. So we do sudo apt install. And actually, before I even do that, I'm going to deactivate my virtual environment, and we're going to do a sudo apt install libpq-dev. All right, so now that we've got that library, that missing library installed, we're going to then go back into our virtual environment. And we're going to run that same command to install all of our requirements. And I have to move into my source folder. All right, and it looks like we have successfully installed all of our packages. The next thing that I actually want to do is let's go ahead and try to start our application. So we have access to uvcorn, so we can just do uvcorn app.main. So this is the same exact command that we ran on our local machine, and then app. We don't need to pass in the reload flag because this is our production server. So we would never want it to automatically reload on changes because no one should be making changes on our production server. So we'll run this and let's see what happens. Right? And it looks like we get 8 validation errors, which is to be expected because it looks like we are missing all of our environment variables. And that's correct. We never set our environment variables. So in the next section, we're going to take a look at how we can set up our environment variables on our Linux machine. Okay, so let's get started on creating our environment variables. So what we want to do is to create an environment variable on a Linux machine, we say export, and then we give the name of the variable. Here, this is just a demonstration. So I'm going to say my _name, and then we set equals, and then whatever value we want to give it. So you can give it anything. I'm just going to say this is Sanjeev. All right. So we'll hit that. We'll run that. And then to actually see if this worked, to see all of your environment variables, we just say print env. And so this is going to spit out a whole bunch of default environment variables. And then to see the one we sent, just kind of look down, look for my name, and we could see that it was successfully set. So at this point, we could just go one by one and manually set all of these. However, that is a very inconvenient process, and I wouldn't expect you guys to do that because we've got 7 or 8, and any other project could have 10, 20, 30. So it's not really realistic to do that, one environment variable at a time. So let me quickly remove this environment variable, which you can do with the unset command. And so I could just say unset my_name. And if I do a print env, we should see that it's no longer there. And what we're going to do is I'm going to go back to my home directory because I don't want to mess around in my application directory. I'm going to go cd and then the tilde, or you can do /home/ and then whatever your username is. I'm just going to do that. All right, so this is going to take me back to my home directory. And I'm going to create a brand new file. And if you want to create an empty file, you can just say touch. And then I'm going to just call this .env. All right, so we should, if I do an ls-la, we should have the .env file right here. And I'm going to open that up. And here I can provide a list of all of the environment variables. So I can say, and keep in mind, this has to be in the same exact syntax. So we have to say, just like we would put on the CLI, we would say export, then the name of the variable. So I'll say, my name again, which equals Sanjeev. And then let's do my_password, which is going to be password 123. So I can save this file and I can say source.env. So this is going to set all of those environment variables. So if I do a print env now, we do have my name, and somewhere along here, yep, we've got my password. So that's another way of setting things. It's a little bit easier to kind of keep everything in a file. But what I don't like is that I have to put it in this format where I put export and then the environment variable. What would be awesome is if I could just somehow get it so that the environment variable file in my Ubuntu machine matches with the environment variable file on my local machine. I want to just be able to put the key and the value pair like here. And so that way I could just copy this, paste it into my production server, and just change the values there. And so we can actually do that. It just requires a little bit of a modification. So let's go back here. And I'm just going to unset both of these real quick. And we'll just double check it got removed. So they're removed. And we're going to open up the .env file. And I'm going to just delete everything. And what I'm going to do is I'm actually just going to copy this for now and just paste it in there. Let's just see if I can get all of this set from a file, and then we'll change the values later. And so when you have a regular file, like the one we have right here, where we don't have the word export in front of it, it does require a little bit more of a complex command, but all you have to do is you run this command. So you do set -o all export, then source, and then you provide the path to the file. So this is going to be in my home directory. So it's /home/Sanjeev. Just make sure you swap it out with your specific username. And then we provide .env. And then we say set +o all export. All right. And so now if I do a print env, we can see I've got my database password, my database username, I've got my database port, hostname, and all of the variables that I set have now been set as environment variables. So that's what we're going to do. However, there's still one minor issue. If I exit out of here, or actually, sorry, not if I exit, if I reboot, and I actually have to do a sudo to actually reboot, but I'm going to reboot, and I'm going to show you guys that when you reload your machine, you lose your environment variables. So we'll give this about a minute or two to kind of boot back up. Although I find Ubuntu machines boot up fairly quickly, so let's just give this a shot, see if we can connect. Nope, not yet. All right, so I've logged back in after it rebooted. If I do a print env, you're going to see that all of the environment variables that I set are all now gone. So how can we get all of these environment variables to persist through a reboot? Because if our machine goes down and comes back up, then we lose those environment variables, then our application's broken. Well, there's a couple of different ways that we can have environment variables persist through a reboot. One of the ways is, let's go to our home directory. We're going to do an ls-la. And what I'm going to do is we're going to go into this .profile file, and we're going to set that exact command that we had run to set my environment variables. Where is that command? This one right here in that file. So copy this, and then just do a vi.profile, and then go to the bottom of the file, and below the last line, just paste that command in. And then we can just WQ. All right, and so this is going to cause, anytime we open up a session or a terminal, even through a reboot, it's going to run that specific command so that those environment variables are all set. Right now, if you do a print env, you will see that it's not set, and that's to be expected because we were already connected to it. But if I exit out of here, reconnect, do a print env, we can now see that our environment variables are set. And then just to prove to you that this actually persists through a reboot, we're going to reboot this machine. All right, so it's rebooted. Let's do a print env, and we can see all of our environment variables are still set. So this is the method that I'm going to go with. Keep in mind, when it comes to environment variables, there are 1,000 different ways to tackle this. And so people like to set their environment variables in different ways. This is just the way that I've done it. This is the simplest way, but there are a number of different other methods. Some of them will probably be more recommended, better, but I want to keep things as simple as possible. The one thing I do want to kind of highlight is that our environment variable is stored in my home directory. It is not in the app directory where all of my application code is. And that's important to me because I don't want to put it in my application code because I don't want it to accidentally get checked into Git. I don't want anyone to accidentally see my production passwords or anything like that, because then my entire application is compromised. So I like to keep it separate by moving it into a completely separate folder so that there's no chance that it gets mixed up in my application code. All right, so since we can connect to our Postgres database, let's go ahead and actually create the database within this machine. So I'm going to select, right-click here, and I'm going to say Create Database. Call your database whatever you want. I'm just going to call it Fast API to keep things simple. And so now we have our database once we click on it, and so now it's up and running. And so since we have that information and we have the information for connecting to our actual Postgres instance on this machine, let's update these environment variable files so that they are accurate at this point, because I believe they're still pointing to whatever our production was set as. Sorry, our development environment. So here, the host name is still going to be localhost. The port, since I installed Postgres on the default port, we can keep that the same. You want to make sure you update your production password. I chose the same exact password just to keep things simple. The database name, we just created one called Fast API. Here, this is going to be the database username. If you want to, it is recommended to create another Postgres user. However, I'm just going to keep this as the default Postgres user to keep things as simple. You definitely want to update the secret key. The algorithm, you can leave that as default. And then the access token, I'm going to make this a little bit longer. Let's do 300 minutes. All right, and now let's reactivate our environment. So I'm going to go into apps, and then we'll do source venv bin activate. So it's going to activate our virtual environment. And right now, you probably notice a little bit of an issue, and that is that we don't have any tables right now. You go to our schemas, and then we got no tables in here. Oh, sorry, we're in the wrong database. In the Fast API, we've got no tables. Right, nothing here. And so we have to set up all of our models now. However, since we are in our production environment and since we've set up Alembic, you'll see that this is dead simple. And when it comes to Alembic, it's important that in your production environment, you never create revisions in your production environment. You only create it in your development environment and you check it into Git. And since we checked it into Git, if we go to source and then go into our Alembic file folder and do an ls and then go into versions, we have all of our revision files. And so what we can do is we can just, sorry, I didn't mean to hit exit, got to log back in now. All right, make sure that virtual environment's enabled every time. I'm going to go into source. And what I'm going to do is I'm going to do alembic. Upgrade. And then head. So this is going to set up our database, and it's going to upgrade it to the latest revision. All right. And take a look at that. It created all of the individual revisions one at a time. So we could still roll back just the same exact way that we did in development. And with just a click of a button, we've got our entire database schema all set up. And we can just refresh this real quick and then go into our tables. And you can see that we've got our 3 tables plus the alembic table as well. So now that we have our database all set, I think it's time we try to start our application again. So move into your apps directory. And if you haven't activated your virtual environment, do that again. Move into the source directory. And now we're going to run the same uvcorn command that we ran in our development environment. All right, so it says it's running on the local host IP address of this machine on port 8000, which is the default port. So let's try to connect to it. So what we have to do is grab this, and we're just going to paste the IP address into our browser, and we're going to do :port 8000. And let's see if this works. And it looks like it didn't work. So what happened? Well, the problem here is that we needed to make sure that it can listen on any IP address. So when you just set this to 127.0.0.1, that means only this machine can access it. So I'm going to Control-C out of this, so we're going to stop it. And we're going to pass in one more flag. We're going to say --host, and then provide the IP of 0000. So we're going to listen on any IP that this machine is potentially running. And if you wanted to, if I did a --help real quick, we can also specify what port we want to listen on. So if I do --port, I can provide a different port so it doesn't go to the default port 8000, but I'm going to keep it as port 8000. You're going to see that it ultimately doesn't matter when we actually deploy, because we're going to deploy it in a way that it's always going to use either port 80 or port 443, which is the default ports for HTTP and HTTPS. So this is good enough. We're going to start it again. Now you can see it's listening on any IP, and we're going to refresh. And if you guys can't see that because it's tiny, we can see that I got message hello world, which is accessing that root path that we have. So it looks like things are working at this point. However, right now, if this program crashes, or if we reboot our machine, you're going to see that it doesn't actually restart automatically. And so what we're going to do is we're actually going to use a process manager. So we're going to use something called Gunicorn. So Control-C out of that. Instead of just starting our application with uvcorn, we're going to use Gunicorn. And if you haven't already installed it, which you probably haven't, do pip install Gunicorn. And make sure you're in the virtual environment. And so Gunicorn is going to be responsible for starting our application. Now, I've already got this installed because I added it to my requirements.txt file a little bit earlier. But if you haven't done that, that's fine because I haven't told you guys to do that. So just do a pip install Gunicorn. And if you get any errors, most likely you'll need 2 other packages. You'll need pip, you'll need HTTP tools. And so you could just do a pip install of HTTP tools. And you'll also need one extra library, which is UV tools. So if you hit any other errors moving forward, right, go ahead and install those 2 libraries, HTTP tools and UV tools, and that should fix any errors that you have. So those were some potential errors that I ran into when I was kind of doing a quick test run. But at this point, we should have access to a Gunicorn command. So I can say Gunicorn, and let's just do a quick --help just to see what options we have. And here, what's nice is that you can actually set the number of workers. So, if you're on a multi-threaded machine or you have a virtual machine with multiple CPUs, you could set up more than one worker so that they're all listening all at once, and then it's going to get load balanced across all of them. So we're going to set up 4 by default just to show you. You could set up 1. It doesn't really change anything. So the command is going to be gunicorn -w. So this is for the number of workers. We're going to say I want 4 workers. And then we're going to say -k. And we're going to say uvcorn dot workers dot capital uvcorn capital worker. All right. And then now we just specify how to start our application like we normally do. So we go into our app folder, we grab the main file, and then we start app. And then, just like we did with uvcorn a little bit while ago, we had to start it with the --host and then do all zeros. Here with gunicorn, we have to use a --bind, and then we do 0.0.0. And then we specify the port we want to listen on. So let me drag this so it looks a little easier to read. So we do that, and then the port that you want to listen on. Let's start that. And it looks like I got a couple of errors. So let's see what happened. All right. And so if you get this error, UV loop, it means we're missing a library. And so, like I said, if you get any errors, make sure you do the pip install http tools. I should have this one already installed. And then you want to do a pip install UV tools. And I realized I've been making a mistake. It's not called UV tools. It's going to be UV loop. All right. And so now it's successful. So not UV tools, UV loop. I guess I got it mixed up with HTTP tools. And so you can go ahead and if you actually wanted to, if you did a pip freeze, you could go ahead and copy this and make this your new requirements.txt file that you check into Git. This is going to have gunicorn automatically in there because we already installed it. It's going to have UV loop, and it's going to have what is the last one that we needed, HTTP tools, which is right here. And so you could check this version into Git, and so that way it's all up to date. And so when you deploy to other Ubuntu machines or other computers, it's going to have all of these extra packages so you can deploy right away. All right, and now let's run the same gunicorn command. And now it looks like it started. It says it's listening on this port. And notice something interesting. Look at this. It actually started up 4 worker nodes, and you can even see the process IDs. So this is probably the parent ID, and then these are the little worker IDs. So if you wanted to, we can open up another connection. And I can do a ps-aef pipe grep. We could probably just grep for gunicorn. Yep. And so you can see all of the different processes that were started. And so there should be 5 of them. 1, 2, 3, 4, 5. One of them is the parent process, and then the 4 are the other child processes. All right, now that's working. Let's just do a refresh just to make sure we didn't break anything and it's still working. And so if we do a refresh, you can see that we can still access our application. And if I go to /docs, the documentation should still be there. Perfect. So it looks like our app is working. We can test it now by testing the individual endpoints, but we're going to hold off on doing that because we're going to make a few more changes. So the first thing is, right now, this is running on our specific terminal, and so it kind of locks up our terminal. I want this to be running in the background, and more importantly, I want this to automatically start up on boot, because right now if we reboot our box, right, we'd have to manually log into this device and run this same command. So we have to find a way to kind of automate it so that upon reboot, it's going to run the application, and we want it to run in the background so that we don't see any logs by default. And we'll tackle that in the next video. All right, guys, so in this video, we're going to figure out how we can have this command automatically run upon reboot, as well as how can we run this as a background process so that we don't hang our terminal. So what we're going to do is just do a Control-C to stop it for now. And what we're going to do is we're going to create our own service. And if you ever run systemctl and then, either status or start or restart, and then the name of some application that you wanted to run, that is an example of making use of a service. And so what we're going to do is we're going to make our own service, which starts this application here for us. And you'll see that it's actually pretty simple. If we go to /etc/systemd, and then system. And I forgot to do a CD to move into that directory. If you do an ls, these are all of the services that have been installed on our machine. And we're just going to create a brand new one. So how do we create that? We have to create a couple of files. And I have actually created them for you guys ahead of time. So if you check my GitHub repo, you will see a file called gunicorn.service. And there's going to be a couple of things that we have to change. So let me just walk you through what each one of these lines mean. So under unit here, we're just going to give a description of what this is going to do. So this is going to be a gunicorn instance to server API. You can put whatever description you want. You can say demo, fast API application. Doesn't really matter. Now the next line right here where it says after network.target, what this is going to do is this is going to tell systemd or our Ubuntu machine when to actually start this service. And so it's saying that, hey, we need our network service running before we can start our API, because if the network's not up, then nothing else really matters. So we're going to wait for network to come up before we start this service. Then on the service, we're going to figure out, we have to specify what user is going to run this service. So we need this to be associated with a user. I created a user called Sanjeev, so I'm going to update this. And then for group, you want to just put the same exact name as the user. Then we have to specify the working directory. And so this is going to be the directory our service is going to be launched in. So go ahead and update this to point to the directory your app is running in. And if you don't know what that is, remember, just go home, then move into apps. And then you can go into the source folder if you want and just type in pwd. So that's going to get you the exact path that you want. And so I have to update this with my username. And then the environment. So because we want this service to run the gunicorn command, which is right here, we need it to run in a virtual environment. So to actually set the virtual environment through this script, we have to say environment equals, and then we set this path variable. And we just point it to the exact path to our bin folder. So once again, if you don't know how to get there, just go to your app folder, go into your virtual environment, go into your bin folder, and then just type in pwd, and that's going to get you the path. And so I just have to update this with my username, and you'll just do the same thing. You just have to update the username. Then we have to specify the exact command to run. So we have to provide the path to where the gunicorn command resides on. So it actually sits in the bin folder. So if you actually do an ls here, right, you can see the gunicorn command. And so that's going to give it the path to the command. And then after that, well, actually I have to update my username once again. Right? And after that, it's the same exact command that we ran before. So for workers -k, then we have this long command right here. And then we specify how to start our application, which is this command. And then we're going to bind it to 0.0.0. And then you can pick whatever port that you want. And this is just a default config. Don't worry too much about it. You need it, but I don't want to go too far into how Linux works to actually explain this. Just know that this is just a standard procedure for creating a service. So to actually create the service now, what we do is let's go to /etc systemd, then system. And let me deactivate my, we don't need to deactivate, it's fine. We're going to create our service file here. And so I'm going to do a sudo vi, and then the name of the service. So what do you want to call your service? So when you type in system CTL and then start, what's the name of the service you want to type in? You get to specify. I'm going to make it so that it's just called API. Very simple. You can call it fast API. You can call it social media app. It doesn't really matter. It's up to you, but I'm going to call it API. And since I want to call it API, I'm going to create a file called API.service. And then what we can do is just take this, copy it, and we will paste it in here. All right, and to test out our service, let's do a systemctl start API. And we're going to have to put in our password. And so this started our API. And if we do a systemctl status API, whoops, there shouldn't be a space, ctl status API, this should just give us the status of our service. We can see that it looks like it failed. That's not good. And it's going to provide us some logs. And if we take a look at the logs, you can see algorithm, field required, access token, expires, field required. So it looks like something is wrong with our environment variables, because we saw the same exact error when we were originally setting this up before we got the environment variable. So for some reason, it's not actually accepting these environment variables. And the reason for this is that the service file, the service that you create, doesn't have access to users' environment variables. And if you actually go back to our home directory, and then we go to ls, ls-la, remember we created this env file, and then we loaded it in the .profile. So the environment variables that get loaded from .profile aren't accessible within a service. And that's just the way services work. So what we have to do is we have to pass in another field in our service config so that it knows to pull the environment variables from that specific file. So what we can do here is in this file, we're going to go and just add another line. It doesn't matter where you add the line, but we want to say environment file. Make sure to capitalize the E and the F equals, and then you provide the path to your specific env file. So mine's going to be home/sanjeev.env. And I'll just copy all of this again. And we'll go back into etc systemd system. And then I'll just do a sudo vi api.service. And we're going to replace this file now. All right, so now we should be able to import all of those environment variables. And there's other ways to do this. You can also set up a config file for your new service. However, I figured it's just easier because we already have our environment our .env file, so we can just continue to use that. And now if I do a systemctl restart API, and notice you don't have to type in api.service. It's optional. You can technically do it like this. And it looks like since we actually changed the file, we have to run this command now. All right, and so now let's do a systemctl restart. Sorry, not restart, status API. And looks like we got the same exact error. Let's just do a restart one more time. And we'll do a status. And now it's up and running. Perfect. Look at that. So we've got our 4 workers. These are the process IDs. And let's just double check and make sure that we can access our specific website. So I'm going to just refresh on the /docs. And it looks like it works. Let's go to the root. And let's go to the root URL. So I'll just change this to the root URL and see if we get the API response. Perfect. So it looks like we've got our application up and running. There's just one last thing we need to do. And I wasn't sure if I had already covered this, but there's one last thing I want to do, and that is I want to make sure that our service automatically starts upon a reboot. So that way, in case our machine goes down, whether it's because of a power failure or something like that, or maybe we perform some sort of upgrade, I wanted to automatically start this service so that our application is always up and running. If you do a systemctl status API, you could find out pretty easily whether this service is going to get started upon a reboot. So if you take a look right here under loaded, and then right here is the keyword that you're looking for. If you see disabled right here, that means that it's not going to automatically get started upon a reboot. If you see it's enabled, that means it will automatically get started upon a reboot. So to actually make sure that it actually does get started upon a reboot, just do a sudo systemctl enable and then the name of the service, which is API. And after that, if we do a status again, we should see that it moved to enabled. And so now if we reboot our machine, and you guys can go ahead and test this, you'll see that it automatically starts up the service. Right now, the way that we have our deployment set up is that when we send a request to our server, to the specific IP address of our server and whatever port we decided to configure our app to listen on, we send that request directly to the app or GUnicorn in general. And this is technically perfectly fine. However, you'll see that in more professional type deployments, what we'll have is a intermediary web server. So we'll have a web server running on our Ubuntu machine, and that web server will receive the original request and then act as a proxy and proxy that request to our specific application, or gUnicorn in this case. And so one of the common web servers that can be used for that is Nginx. There's a couple others like Traffic and HA Proxy. You'll see that Nginx is fairly popular though. And some of the benefits of doing this or in configuring our application ultimately to be deployed like this is that Nginx is optimized for SSL termination. So Nginx is a high performance server and it can perform all of the SSL termination. So when we send an HTTPS request, we can send it to our Nginx server. The Nginx server can process it and then forward it as a plain HTTP packet to our application. Because technically we could configure our application to handle HTTPS, it's not optimized for that, right? Our app is designed to just act as a plain API. When we start adding responsibilities like performing SSL offload, well, then you'll see that we start to see a degradation in performance. And Nginx, like I said, is a high performance web server. It's optimized for this, so it makes sense to kind of handle that responsibility on Nginx instead of our application. So that's what we're going to do. We're going to configure Nginx, and this is going to act as the gateway into our system. So any request we send to our system, whether it's HTTPS or HTTP, doesn't really matter. We're going to send it to Nginx. And if we send it as HTTPS, what Nginx will do is it'll then take it and send it and forward it as an HTTP packet to our application. And so I'm going to walk you through how to set up Nginx. It's not difficult. We do have one config file that we have to add, but outside of that, it's fairly easy to get this up and running. Let's install Nginx now. To install a package, we can do sudo apt install and then Nginx and then -y. So that installed Nginx. If we do a systemctl start Nginx, that's going to start up the Nginx service. And so now if you go to your server IP address, you're going to see that you get this welcome message. So this is just the default page that Nginx loads up for you. And we're going to change this. So in Nginx, what we want to do is we want to go to /etc Nginx sites and then available. It's important that you do available because there's also a sites enabled, which is not what you want. You want available. And there's this default config file, or technically this is a server block. And if we take a look at this, you can see the default configuration in this case. Just to show you what that looks like, you can see that this is handling HTTP traffic. That's why it's port 80. It's going to listen on port 80. And this is going to act as the default server. So all requests that come here are going to land on this server block. And we've got the same thing for IPv6 as well. And then this is the file that you actually see. So when you navigate to this page, it's actually loading up a file that's in /var/www/html. And then the server name, so this is going to be the actual domain names it's going to handle requests for. This is basically saying everything. Everything else, don't worry too much about that. But what we're going to do is we're going to change that file a little bit. And I've provided an example file here. And so this is what the example file looks like. We can leave pretty much everything in place. The only thing I want to change is this location block. And so this is what is going to allow Nginx to act as a proxy. Specifically this line. This is the main line. You don't technically need the other ones. Those are more of optimizations. But all this is saying is that any requests that match the root path or beyond, essentially, is going to get proxied to localhost port 8000, which is what gUnicorn is running on. So you just specify the IP address and the port that you want to proxy traffic for. And so since gUnicorn was configured to run on port 8000, we're just going to forward it to gUnicorn in this case. So I want you to just copy these lines here, and we're going to go in, and I'm going to just open up that default file now. And we can delete these 3 lines. I'm just going to paste that in. And at that point, I can save this. And then we want to do a systemctl restart Nginx. So it's restarted. And if I refresh this, right, we can now see our API. And if I go to /docs, it should also work as well. So we got Nginx set up and running. The last thing that we have to do regarding Nginx specifically. Well, it's not really Nginx specific, but in general is that right now, if you take a look at it, you can see our web browser says not secure. And that's because I can actually copy this. If I paste it, right, we're using HTTP and not HTTPS. So we need to set this up for HTTPS. So how do we do that? Well, we're going to tackle that in the next video. But you're going to need a domain name if you want this to work with HTTPS. So I'll show you guys how to kind of grab a cheap domain name. However, if you don't have one, don't worry. You can just leave it as HTTPS for now, or you can create a self-signed certificate, whichever one works for you. For my application, I purchased a domain name called sanjeev.xyz. So if you've ever watched any of my other videos, this is always the default domain name that I use for demonstration purposes. You can see that I actually bought a .xyz because they're the cheapest. So if you just want to play around just for learning purposes, get a .xyz. They're usually like $1 for like an entire year. But if you get a .com, it's going to be a little bit more expensive. However, depending on what your domain name is, it at most is still, well, not at most, but you can still find plenty at $12 per year. So it's not too bad. And I happened to purchase my domain name from Namescheap. So this is my domain registrar. However, there's plenty of other options. If you want to use GoDaddy, if you want to use any of the other websites, you can even use Amazon if you wanted to. Feel free to use whichever one you want. You just need to get a domain name. I'm going to be using this one moving forward. So just keep that in mind. And what we want to do is we want to set up a couple of rules. And we actually have to point our domain name to DigitalOcean. And DigitalOcean has this excellent write-up, how to point your DigitalOcean name servers from common domain registrars. And they actually show you how to do this for a lot of the main domain registrars. And they have Namescheap here as well. So if you get one of these, you can just follow along. But you'll see that any domain provider, you'll be able to kind of relatively click around and just kind of navigate yourself and figure out what's the equivalent. Because for the most part, the UIs are all fairly similar. But if we go down to Namescheap, you can see that what we have to do is under the name server section, we have to do custom DNS, and then we point it to the DNS servers of DigitalOcean. So ns1.digitalocean.com, ns2, ns3. So let's do that. And I've actually already set that up for us. So you just go under name servers, select custom DNS, and then you have ns1.digitalocean.com, ns2.digitalocean.com, and ns3.digitalocean.com. And there'll be a little check mark, so just check that there. And at that point, it's going to point everything to our DigitalOcean servers. Then in DigitalOcean, if you just select your name here in your dashboard, what you want to do is you want to go to manage DNS on DigitalOcean. And then here you want to enter your domain. So this is going to be sanjeev.xyz. We'll add this domain. And the first thing that we have to do is we have to create an A record. So this is the root of your domain. So I'm just going to say @symbol. This is going to create an A record. And we want to select the specific droplet that we created. So this one is Ubuntu Fast API. You should only have one. But if you have other droplets, make sure you select the right one. And then select create record. And at this point, if we do sanjeev.xyz in our web browser, it's going to take us to our DigitalOcean server. However, keep in mind, the changes to DNS usually take a little while to propagate. So you could potentially have to wait up to an hour or 2 hours. Namescheap says it could take up to a day, but it never takes a day. So if you don't see these changes immediately, just give it 10, 15 minutes, and then you'll see that they work. But I'm going to add one more, and that's going to be for my subdomain, because I don't want to just do sanjeev.xyz. I also want to redirect www.sanjeev.xyz to my server. So I can create a CNAME record. And I can say www. And so you can see what this is going to look like. And I'm just going to say @symbol right here. So that's going to point it to this record essentially. All right. And so what this is saying is that if you send a request to sanjeev.xyz, it's going to send it to the IP address of our server. And then if you send a request to the subdomain of www.sanjeev.xyz, it's going to be an alias for sanjeev.xyz. So it's essentially just going to follow this. All right. And so now if I go to sanjeev.xyz, you can see that we are successfully able to access our API. And if I go to /docs, once again, this should still work as well. And that's pretty big. Let me minimize that. And if I do the same thing for my subdomain of www.sanjeev.xyz, this should also work. All right, so we've got our domain set up. And once we have our domain, we can now finally set up SSL. So we can handle secure HTTPS traffic because we don't want to send our application traffic over HTTP. And we want that nice little lock symbol, that green lock symbol. So we'll tackle that in the next video. Okay, so it's now time to set up SSL for our application. So I want you to search for Certbot. So this is the website for Let's Encrypt, which is a free SSL service. And here they've got excellent documentation. What we want to do is select get Certbot instructions, and then we can just specify what software we're running. So this is for Nginx, and the system is going to be Ubuntu 20.0.4. The reason it asks for this information is that it actually will automatically reconfigure Nginx for you to handle HTTPS because normally when you want to set up HTTPS, you have to change some configs in Nginx, and it gets a little complicated. And so it's saying the first thing that we have to do is we have to install snapd. If you installed Ubuntu, from DigitalOcean, snapd should automatically be installed for you. So you can do snapd -- version, I think. Or is it snap -- version? I think it's snap version. Yeah. Okay. So it's snap. Okay. So we've got snap installed. That's perfect. And then what we want to do is we want to install with this command right here. So just copy this. And we're pretty much just going to follow this website because like I said, the instructions are fantastic. So we'll install Certbot. All right, Certbot's installed. Then we want to do this command. So you have two options. You can either just generate a certificate, or you can have Certbot automatically configure Nginx for you. We're going to have Certbot do the work for us. And so we can just paste this in. All right, and then we have to provide an email address. So this is going to be whatever email you want to use. And then we got to agree to the terms of service. You can do no for this one. All right, then we have to specify what domain names we want to generate a certificate for. So we want to generate a certificate for sanjeev.xyz in my case, and then www.sanjeev.xyz. All right, and it looks like it did some magic to our default config file that we were originally changing. So if we actually go to the sites available folder, which we're already at, and just do a cat default, you're going to notice some changes to this file. And that's because Certbot actually made a whole bunch of changes. And the main change is, where are these changes? Not here, not here. Here we go. So this server block is for SSL configuration. And so these are the changes they made. So we're going to listen on port 443. So that's the default SSL or HTTPS port. That's good. And I guess that's for IPv6. This is for IPv4. These are going to be the two certificates that were generated. And then there's a few other configs that it added. And we also have this server block right here, which is going to actually redirect HTTP requests to HTTPS. So we can never even use HTTP anymore. It's going to ensure that our clients always use HTTPS and it'll redirect them to HTTPS. And if you can see that right here, if host equals www.sanjeev.xyz, we want to send a 301 redirect to HTTPS and then host request right here. And we're doing the same thing for just the sanjeev.xyz. And so that's all done by Certbot. And so now if I go here and I do sanjeev.xyz, take a look at this. We got the little green lock. That means connection secure. That means we're using HTTPS. And you can see the HTTPS here. And if I hard code it to be HTTP, look at that. It still has the lock because it redirected to HTTPS. And let's just make sure that the docs work now. And it looks like the docs still work. So we now have HTTPS set up on our Nginx server. And just like we did with our service, we want to make sure that Nginx has been set up to automatically start upon a reboot. So we could do a systemctl status Nginx, and let's just quickly verify if it has been set up to do so. And I can see that on mine, it's set up to be enabled, so it will automatically start upon reboot, which is what we want. And I think this is the default configuration when you install and set up Nginx. However, if you see disabled here, just go ahead and do a systemctl enable Nginx, and that's going to make sure that it will be moved to an enabled state so it'll get started upon a reboot. The last thing that we need to do to complete our deployment process is set up a firewall on our machine. And the reason we want to set up a firewall is just for basic security purposes. We want to make sure that we only open up ports that we're going to be using. Because right now you can access this box on any port, and we want to make sure that we really harden our system so that only the traffic that should be sent to this box is allowed to this box. We don't want people trying to connect to different services on our machine that they shouldn't be. So we're going to be using the built-in firewall called a UFW. And if we do a sudo UFW status, right, the UFW is the firewall. And so you can see right now it's inactive, and that's perfect. And what we have to do is we have to set up a whole bunch of rules. And we have to tell the firewall what kind of traffic should we allow to our machine. And we can run sudo UFW allow, and then we can specify what specific port we want to allow traffic on, what specific IP addresses we should be able to talk to. So since this is a public API, we want to make sure that technically anyone can access our server from HTTP and HTTPS. So we're going to do allow HTTP. So this is going to allow HTTP traffic. And you can see it created an IPv4 and an IPv6 rule. We want to allow HTTPS traffic. And keep in mind, we have to SSH to our machine so we can access it. So we have to allow SSH as well. And if you wanted to, you could also allow 5432. So that's going to be to allow Postgres traffic. Now, the way we've set things up, you don't need to actually allow this port because technically our app, right, our fast API is running on the local machine. So it's not going to be hindered by this firewall. So it can access the database because it's running on the local machine. So if you wanted to make it so that no one from the outside world can directly access your database, you would not want to allow this. And that's what a lot of people do because it can be a little risky opening up your database port because then people can potentially access your database. So it's up to you. However, if you want to be able to, go to pgadmin, and if you want to be able to connect to your box remotely, then you're going to have to allow 5432. So it's just up to you. It's your preference. Do whatever you want to do. I'm going to allow this just for demonstration purposes so that I can show you that, hey, when you allow 5432, we can connect remotely. So I'll add that rule. And then finally, we have to start our firewall. So we do sudo UFW enable. And it's just going to tell us that we could potentially lose connection because we're starting up a firewall. That's fine. And we've started up a firewall. So if I do a sudo UFW status, you can see that it's active and you can see all the rules that it's put in place. So it's saying we allow port 80 traffic from anywhere. We're going to allow that. Port 443, we're going to allow from anywhere. And same thing with SSH and 5432 and all of the IPv6 rules as well. And then everything else is dropped and blocked. And let's just double check that we can access the docs. And it looks like we can. And just to make sure it's not cached or something like that. Still works. And now we've got our firewall. And the firewall will start up automatically, so you don't actually have to configure anything else. If you do want to delete a rule, you can do sudo UFW delete allow, and then whatever rule. So you can do HTTP or you can do 5432, whichever one you want to delete. So now that we have our application deployed, one of the common things that you're going to have to do is make changes to your application and then push out those changes. So I'm going to show you guys how we can do this in a manual process. Ultimately, if you're developing an application, it's best to set up a very efficient CI/CD pipeline, but that's a little outside of the scope of this course. So I'm going to just show you how to do this manually, and you'll see that it only requires a couple of commands. So go ahead and make your changes, whatever code changes. So I'm going to say, hello world, couple of exclamation points. All right, we'll save that. And what we're going to do is we're going to do a git add -- all again. And we're going to do a git commit -m, give it some meaningful message. Changed the world. All right. And then we're going to do a git push. And before we do that, if you type in, just do a git push. Then we provide origin, which is the name of our remote, and then the branch that we're on. So we can say main. And that's going to push it up to our GitHub repository. And at that point, once it's there, you can just quickly verify if you want, but I'm going to assume that it's there. And then what we're going to do is we're going to go into our application folder, which is in our home directory. Then we go into apps and then source. And then here we're just going to do a git pull. So it's going to pull all the changes that were made. So it's going to grab the latest changes and we'll, all right. So we've pulled all of our code now. And keep in mind, if you had changed the requirements.txt file, then you definitely want to do a pip install, pip install -r requirements.txt if you did, but we didn't change any of that, so we don't need to do that. And what we can do now is we have to restart our application, because if I just refresh this, you can see nothing's changed. There's no exclamation points. So we'll do a sudo systemctl restart API. And let's try this out now. And we've got all of the exclamation points now. So that's how you push out changes through a manual process. But like I said, it's best to set up a CI/CD pipeline. In this section, we're going to focus on Dockerizing our application. I originally wasn't going to do anything on Docker, but I figured I would just make a quick video just to show you guys how we can quickly set up our fast API environment within a Docker-based environment. And I'll also show you guys how to set up a Postgres database within Docker. This is going to be a fairly quick run through of Docker. I'm going to assume that you guys have a basic understanding of Docker. I'm going to assume that you already have Docker installed on your machine. So we're going to get right to it and get started on setting up our fast API within Docker. So I have Docker Hub open, which is just, a public repository of different images that we have access to. You can create an account if you want to. You don't have to create one at this stage. The only time we'll need to create an account for this course is if you want to push an image up to a repository hosted on Docker Hub. If you don't want to do that, then you don't need to go ahead and create an account. But what we want to do is we want to figure out an image that we're going to use for our fast API, a Docker container. And so just go ahead and search for Python. And what we're going to do is we're going to use the official Python image. So select the official Python image. And you'll see that there's a couple of different options. So you can scroll down, you can see the different versions of Python. And we're actually going to use version 3.9.7 in this case. But you can see that with the default Python image, we have all of the different versions that we could pretty much ever want. And then they got Slim images, they got the Alpine images as well. But we're going to use just the standard image. Now, if we use this specific image, the problem with this is that this is just a basic image with Python. There's nothing else on it. And at that point, if we just have a basic Python container, then we have to do all of the work of copying our source code onto the Docker container. And then we have to install all of our dependencies and set up our application. And that kind of defeats the purpose of Docker, because the main idea behind Docker is that we actually create an image that has everything that we need to run our application. So we just start up the image, or I guess we technically start up the container, which is made from the image, and that should just have everything it needs, and it should just start working right away. So that's exactly what I want to do, and to actually get that to accomplished, we're going to have to create our own custom image. And all custom images need to start off with the base image. So we're going to start off with this base Python image, and we're going to customize it by doing a few things, including copying our source code into it, and installing all the dependencies, and setting up a few other details. So to actually create a custom Docker image, we're going to go to our project directory, and we're going to create a file that's referred to as a Docker file. Now, this Docker file is going to have all of the steps necessary to create our own custom image. And the first thing that we have to do is we have to set up or specify our base image. So we're going to use this Python 3.9.7 image as the base image. So what we do is we say from, and then the name of the image. So this is the Python image. And then if we want to, we can also do a version. So I'm going to do 3.9.7. And if you're wondering where I'm getting this from, this is all from the documentation. You just say from, the name of the image, which in this case is Python, and then you could see the different tags. So if you want 3.9.7, slim, bullseye, that you got that. And if you want to see them going over that in an example, we're kind of basically just following this essentially. The next step is going to be an optional step, but I always like to do this. We're going to use the workdir flag, and this is going to set the working directory. So I'm going to say this is going to be user source user/app. Now, how do I know that there's a folder called user/source? I've actually run the Python image myself, and I checked to see where I could actually set up my application. So I found that there is a path here, and then I want to create a folder called app, and this is where I'm going to store all of my application code. And once again, you can take a look at the documentation, and it does the same thing. So if you're ever lost, just take a look at the doc, and it's going to help explain things. But like I said, this is the optional command in this case, because what it really does is it's going to tell Docker, this is where all of the commands are going to essentially run from. So it's like doing a cd into /user/source/app, and then anytime we give it any instructions, it's always going to do everything in that directory. So it's just going to help simplify some of the later steps, but it is technically optional. The next thing that I want to do is I want to copy our requirements.txt file from our local machine onto our Docker container. So we use the copy command, and we see we want to copy requirements.txt, and then we have to specify the directory within our container or image that we want to copy it to. So I'm going to say /. So where does this exactly point to? Well, remember, we set our working directory. So everything is going to be with regards to that directory. So when I say the current directory, that means this directory. Now, if we didn't have this line right here, then we would have to specify the full path to that directory. So you can see that it's kind of simplifying things for us, because then we can just kind of say, hey, I want to use the current directory because that's what the working directory is. And the next thing that I want to do is run a command, which is going to be responsible for installing all of our dependencies, because we have our requirements.txt file copied into our Docker container. So we're going to do pip install -r and then requirements.txt. And if you want to, we could also specify the --no -cache -dir if you wanted to as well. And so that's going to install all of our dependencies. Then the next thing that I'm going to do is I'm going to do copy ... So what does this mean? This is going to copy everything in our current directory, so all of our source code, and then it's going to copy it into the current directory in our container. So what is the current directory? Well, that's the one that's set by workdir. And once again, if we don't have this defined, then we would have to specify the full path of /user/source/app. Now, one thing that you might notice that's a little unusual is the fact that we copy all of our source code at the end right here, which is going to include everything in our directory, including the requirements.txt file. So you might be wondering, well, why exactly do we copy just the requirements.txt file up here? Well, this is a little bit of an optimization that Docker provides us. So when Docker runs, when we build images from a Docker file, it actually treats each one of these lines or steps as a layer of the image. So kind of builds an image by running the first layer, then creating the second layer, the third, fourth, and fifth layer. And it actually caches the result of each step. So this is important because when you cache the result, if nothing changes, then we can just use the cache result. So let's say I run this image, or I create an image from this file. It's going to take a certain amount of time because it has to do a pip install requirements.txt, where it's installing all of the dependencies, which does take a decent amount of time. But if I run this again, right, and nothing changes, well, then it can just use the cache result because it knows nothing's changed. And this is important because when I change my source code here, maybe like my database.py file, it's going to see what steps changed, right? And so if I change my source code, does that change the base image? No, we're still using the same base image. Does it change the working directory that we used? Nope, still the same. Did it change the requirements.txt file? Nope, still the same. Did it change any of the dependencies that we installed? Absolutely not. It only changed the final step. So this causes Docker to be able to use the cached result of step 1, 2, 3, 4 of step 4, and it only has to rerun step 5. But if we change requirements.txt, this file right here, then it knows that this step changed here. So it's going to have to rerun this step, then this step, then this step. Right? And so this gives us an advantage because anytime we change our source code, we only have to run this last step. And if we change our requirements.txt, then we have to run all of these steps. And keep in mind that this step is the longest step. And so if I had actually, if I can comment this out. So if I didn't have this line and instead I copied all of my source code right here, what would happen is every time I changed any code in any of my files, I would have to rerun a pip install every single time. And that would cause us to have to rerun the longest step in our build process. And so that's why we have this optimization. That's why we copy the requirements.txt file so that we can cache that result. And so anytime we make any changes to that file, anytime we make any changes to our source code that's not in that file, we don't have to rerun a pip install. All right, and then finally, we have to give it the command that we want to run when we start the container. So we'll say cmd brackets. And so the command that we want to run is uvcorn app.main app. And so the way we actually specify the command is we break out each word of the command. So here we do uvcorn, and then we say app.main app. And then here we're going to pass in the host flag and the port flag like we did on our Ubuntu machine. So we do --host 000, and then we do --port. That's going to be 8,000. Okay, so it's basically anytime you have a space between the commands, you just split it up into a different string within this list. That's just kind of the syntax that you have to use with these Docker files. But it's the same thing as running uvcorn app.main app and then --host --port 8,000. Oops, 8,000. So it's just going to essentially run this in our container. We just have to provide it in this format. All right, and so now our Docker file is complete and we can actually build our image. So what we're going to do is I'm going to do a Docker, and then the command to build our image is build, and then we'll do a --help so we can see all of the different flags. And most of these don't really matter. The only one I really care about is a tag. So I want to give this a name. So I'm going to say Docker build -t. I'm going to give this image a name that I think is reasonable. I'm just going to call this fast API. And we have to pass in one last argument, which I forgot, which is going to be the context. You could think of the context as just kind of the directory where the Docker file is. So it's going to be in the current directory because we can see the Docker file is in the root of our folder structure. So I could just say dot. And so now it's actually going to build our image. And if I do a Docker image ls, we can see all of our Docker images, and you'll see that I've got a whole bunch, but we've got my fast API right up here. And so now we can go ahead and use this image for actually building out a container. And we can run a whole bunch of Docker commands like docker run, and then specify the image that you want to use, and then pass in all the flags. But I don't like doing that. I don't like working with Docker run. Instead, I want to use Docker compose. And if you have never worked with Docker compose it does the same thing as running Docker commands on the CLI. We just provide all the instructions on a file so that we don't have to remember all of these long commands with all of these extra flags. We literally write out the flags in a file, and then we can just say Docker compose up, and it's going to bring up all of our containers. So we're going to take a look at Docker compose in the next video and see how we can get that set up. All right, so we're going to learn about how we can use Docker compose to automatically spin up our containers with the desired configuration. And you're going to see that it's so much easier to use Docker compose than just running docker run whenever you need to, because we can spin up multiple containers all with one command, and we can also tear them down all with one command. And to use Docker compose, we have to provide the set of instructions using a file called docker-compose.yml. And so this is a YAML file. And if you don't know too much about YAML, it's just I guess it's technically like a markup language, I guess. But the most important thing to understand is that spacing matters. So this is kind of like Python, where you need to make sure that the tabs and the spaces are just right and everything lines up, or then it's going to start to throw errors. And the first thing that we need to do is specify what version of Docker Compose we want to use. So we say version, and I'm going to say just version 3. It's not the latest, it's just kind of the most common one. If you actually go to the Docker documentation for Compose file, you'll see the different versions that you can specify, and you can actually take a look at the documentation and see what feature was introduced in what version, so you can figure out what version you need to perform all of your operations. We're not doing anything special, so version 3 is just fine for us. Then within Docker Compose, we have a concept of services. And so a service, really, at the heart of it, is nothing more than just a container. So if you want Docker Compose to spin you up a container, you have to define a service. If you want Docker Compose to spin up 4 containers, we're going to have 4 different services. Pretty simple. So we have to give each service or each container a name. So we're going to have one container for our fast API. And I'm just going to call this container API, or this service API. And the first thing that we need to do is we have to specify either the image that we use. So I could technically say like image, and then we can point to like the Python image, or I can specify build, where we can essentially do the same thing that we did before in the previous video, where we ran docker build and then provided the location of the Docker file. But we could just specify that here within Docker Compose, so that Docker Compose will automatically build the image for us if it doesn't exist. So we'll say docker build, and then we specify the context or the path to the Docker file, which is the current directory, based off of where the Docker Compose is. So they're in the same directory. So I just say current directory. And then we have to specify a port that we want to open up, because this is an API. So the outside world needs to be able to reach our container. But by default, all containers can't talk to by default, the outside world can't actually talk to your container. So we have to open up or poke holes on our local machine to open up some ports. So we say ports, and this expects an array of ports. And so there's 2 different ways to do an array. With YAML or with a Docker Compose file, we can do, just an array like this, where we just provide a list of things. Or we can also do it like this, where we do a dash and then provide, something, and then a dash for the next entry in the list. So I'm going to use this syntax because I kind of like it better. But to open a port, there's a specific format that we're going to use. So what we say is there's going to be 2 numbers. There's going to be the port on local host, and then we do that, and then we do the port on container. All right, so what's essentially happening is we're telling Docker, if we receive traffic on our local host on this port specified here, we're going to forward it to this specific port on the container. So the second number is a little bit easier to set up, because it's going to be whatever port our application's running on. So if we take a look at our Docker file, we can see that our container is going to be listening on port 8000. So we want to set this second number to be port 8000. And keep in mind, you could choose to use any other value. So if you decided to use port 80 here, then you would just change it to port 80 here. But I'm going to leave it as 8000 just for simplicity's sake. Then the second number that we're going to use is going to be the port on the local machine, or on the local host, which in this case is my Windows machine. But if it's on like a production server, it's going to be whatever machine or IP of that specific server is. And so here we could specify any port. So you can literally pick any port that's open. So if I said port 4000, what that means is that, if I go to my my Postman, this would be the equivalent of doing localhost colon 4000, right? Which is that first number. And so anytime we send traffic to that specific port on our local machine, it's going to route it to port 8000 in our container, which is what port our application's listening on. But if I change this to port 8000 as well, then our request would be localhost port 8000. So I always like to have the 2 numbers match up because it's just simpler, but sometimes that's not an option. So just pick a open port on your localhost machine. It doesn't really matter what it is. Just make sure that you remember what it is. And I'm going to leave it like that, and I'll delete this line right here. And for now, I think this is good enough. And what we're going to do is we're going to try to run this and see what happens. So I'll say docker-compose up. And then if I do a -- help, we can see some other flags that we may need. And the only flag that I really need right now is the -d. So this is going to run the containers in the background so that we're not automatically connected to it. So I'll do just -d. Right. And so you'll see, if you take a look, what's happening is we're rebuilding our image. So because we specified the build right here, it's going to build our image. And then it's going to start our containers. So you can see that it's creating fast API _API_1. And so the naming syntax comes from the project directory. So it's called fast API, right? So that's why the first word. Then we do underscore, then the name of the service. So I called this service API, so then it's API. And then it has the number 1 because there's one instance. But if I told it to spin up 4, then I'd have 1, 2, 3, and 4. So we've got our container. If I do a docker ps, we should be able to see. Nope. Oh, we can see it's down. And that's because if I do a docker ps-a, and we can see that this one right here looks like it stopped 43 seconds ago. And so it crashed for whatever reason, and that's okay. What we can do is, I think we can actually see the logs after it goes down. So if I do docker logs fast API 1, we can actually take a look at the logs at what caused it to go down. And we can see a couple things, but we can see that we get the Pydantic error for our settings object, which is all of our environment variables. So obviously a container is like its own separate machine. So it needs all of the environment variables passed to it, or then our application is going to crash. So how do we pass an environment variable in Docker? Pretty simple. We just pass a environment field. And then here it's going to provide, you need to provide an array of environment variables. So I do dash. And then here we just specify our environment variables. So I'm actually going to copy and paste this section right here. And so these are all of our environment variables. Keep in mind, if you don't want to actually write out all of your environment variables, we can actually use Docker to point to a .env file or a environment file on your local machine. And if you want to do that, it's pretty simple. Here we would just specify the env_file. And then you can actually provide multiple files, but in this case, you just provide the path to the file. So it's going to be in the current directory, and it's going to be .env. So you can do either one or a combination of both. I'm just going to use this format so that we can see all of the environment variables, and I'm going to just comment this out for now, just for documentation purposes. And now what we're going to do is we're going to do a docker compose down just to tear everything down. And I'm going to bring it back up in detached. And notice this time it didn't build the image. So why exactly didn't it build the image? Well, Docker Compose is very simple. All it does is it goes to Docker image, basically just runs the Docker image ls, and it looks for the image that it would have created. And there's a very specific format that it uses, which is going to be the name of the folder or the directory, and then underscore, and then the service. So since the image was already created previously, it doesn't recreate it. However, if you obviously make changes to your Docker file and you want to make changes, then you would have to do Docker up. And then if you look for the flags, there should be a let's see, build. This is going to force it to build a new image. So keep in mind, anytime the image has to change, and but the image already exists, then you have to pass in that flag to force Docker Compose to let it know that, hey, I made some changes. I need you to rebuild it for me, because Docker Compose can't detect that. All right, so now if we do a docker ps, we can see that it's running now and it didn't crash. And we should be able to access it on port 8000. So if I actually go here and just do localhost 8000 with the GET request, looks like it's working. Okay, so now that we can actually access our API, which is running in a container, the next thing that I want to do is I want to set up our Postgres database. And you might be thinking, well, we already have one installed on our local machine. Why are we setting up another one? Well, a couple things. First of all, if we're already Dockerizing our environment, it makes sense to set up our Postgres database, especially from a development perspective within a Docker container, because it's so much easier to set up a database in a container than it is to install it on our local machine, because we just spin up a pre-built image and that's it. So even if you don't actually want to Dockerize your application, from a development perspective, I strongly recommend you make use of Docker containers so that you can spin up a quick database just for testing purposes. But since we already have a Docker-based application now, we're going to just use a Postgres database that's running in a Docker container instead of on our local machine. Because if we take a look at the environment variables that we pass to our container, we provide a value of localhost. And so localhost means that the container is going to, or the API running in the container is going to try to access a database running locally on that container, which it's not. So let's create a brand new service, which once again is nothing more than another container for running our Postgres database. And so I'm going to go down here And we're going to create another service called Postgres. And here we're going to provide a image flag, right? Because here we did build because we're building a custom image. Here we're going to use the pre-built default Postgres image. So if we go back to Docker Hub and search for Postgres, you'll see this is the official Postgres image. And this is going to contain all of the documentation for setting up Postgres. But the main thing is there's a couple of environment variables that we have to pass. So first of all, the password that's going to be used for our database. We can give an optional Postgres user, but it's going to default to Postgres if we don't provide it. And then we also want to give it a Postgres database name. So we'll call it Fast API like we've been using in our development environment. And that should be all that we have to do for the most part. So here I'll say environment. And we'll do Postgres _ password equals, and then we can give this anything we want. So password 123. And then we want Postgres _ DB. So this is going to be Fast API. All right. The next thing that we want to do is when it comes to data within a container, that data doesn't persist as soon as the container goes down. Right. So when you delete the container, you lose all of your data. All right. And so from a database perspective, we don't actually want to lose our data. We want that to persist even if we kill off the container. So how do we actually save that data? We have to create something that's called a volume. And that's what allows us to save data from a container onto our local machine so that if we kill the container, we can always spin up a new container and just point it to those files. And there's a couple of different volumes that we can use, or types of volumes in Docker. There's anonymous volumes, named volumes, and I think bind mounts is the other one. We're going to make use of named volumes. And so to create a named volume, here under the Postgres database section or service, we're going to say volumes. And then we say dash, and then provide a name for the volume. So you call it whatever you want. I'm going to call this Postgres-DB. Right? And then we have to specify the path in the container that we want to actually save. So what directory do we want to persist on our local machine? And the path that the Postgres container or image actually stores all of its data, we can actually take a look at the documentation to figure this out. So if you search for volume, and so right here, this gives us an example, and this is going to tell us what we need to know. So we want to save /var/lib postgresql/data. So that's where it's going to save all that data. So we'll copy that. And once again, this is the path in the container that Postgres is going to write to. So that's where all of our tables, all of the entries are going to get stored. So we want to copy that essentially and save it on our local machine. And the last thing that we want to do is anytime you use named volumes, we have to create another volume section globally and then just pass the name that we created. So whatever is here, you just put it down here. And the reason we have to do this is because named volumes are designed so that technically multiple containers can access them. So you define it down here first technically, and then multiple containers can reference them by just calling that. All right, so we've got this set up, and actually I realized I left my containers running. So what I'm going to do is I'm going to comment this out for a second, save this, and I'm going to do a docker compose down. So it's going to delete everything. Then we'll uncomment our Postgres service. Then the next thing that we want to do is we have to figure out, what is the host name, or what's the IP address of our Postgres database. And, there's a couple of different ways to do that. But what's awesome about Docker is when you use Docker Compose, it creates a custom network. And a Docker network uses DNS. So we can actually say to reach the Postgres database, instead of looking for the IP address of that container, we can use DNS, and I can just say, if I try to reach the name Postgres, right, it's automatically going to resolve to our Postgres service. So whatever our service is called, we can just reference that. And this is going to allow this container to know that when you want to talk to the Postgres database, this name here is going to resolve to the IP address of this container. And so networking with Docker within Docker is so simple because that's all we have to do. And then the rest of the things, the default port, the password, the database name, the database username, those should all be okay. And we can just leave as default. And now I can then start this up. And it looks like image, something's wrong with the image. I forgot to give the image. So what's the image name? It's just Postgres. So that's just whatever this name is. That's all you need. All right. And so now we can see that it started up both. Let's just quickly test our API so we didn't break anything. So that works. And then let's go to create user, make sure it's point to port 8000 in this case. And if we create user, right, you can see that we have successfully created the user. So it looks like we can now access the database from our fast API container. Now, what I'm going to do now is delete everything again. So Docker compose down deletes everything. And you can see I'm essentially able to destroy both of my containers with a single command. And that's kind of the power behind Docker compose. And ideally, we want our Postgres container to start up first because our API is dependent on the container. So for our API, we can pass in another option. And I can say depends on. And here we can specify a list of services, in this case, just Postgres. And so this is going to tell Docker, I want you to start the Postgres container before the API container starts. Now, technically, it's not going to wait for Postgres to actually fully initialize. It'll just start the container. So you still want to put in checks in your code to make sure that, if you can't access the database because it's not initialized, you want to keep retrying. And so once again, we can bring this back up with a single command. And if you take a look at the order, you can see that we started up the database first. So now you'll always start up your database first and then start up Fast API. And then you'll stop Fast API first before stopping the database because we set up the depends on. When it comes to working with Docker containers, we do experience a few extra challenges, especially from a development perspective. And I'm going to show you how those challenges actually work or what those challenges actually are. And if I actually go back to my test request, wherever that is, where I'm just going to reach the default URL. So if I hit send, you can see it says hello world pushing out to Ubuntu, right? And that's because in my main.py file, it just says hello world pushing out to Ubuntu. Now, if I save this or change this and then save this, and then I send a request, right? We still get the same response. I don't get the new text that I added. So why is that? Well, there's a couple things that are happening, but the easiest way to figure this out is to actually poke around in your container and figure out what's happening. So I'm going to do docker ps, and I want to see what the file system of Fast API container actually looks like. So to do that, we do docker exec-it. So that's going to enter into interactive mode. We specify the container name, and then we type in the word bash. So what we're doing is we're entering interactive mode, and we're going to override the default command of the container. So the default command is specified right here from the Docker file. So we don't want to run that. We just want to run bash, which is going to allow us to access the file system. That's the image name. So the name of the container is fastapi_1. So let me add the 1. So now you can see that we get a Linux prompt. So we're in the Linux file system. And if I go into app and then go into, if I do cat, which is going to print out the contents of a file, we'll take a look at the main.py file. And you can see that it just says hello world pushing out to Ubuntu. So when I made these changes and added these extra characters, it didn't get pushed out to our container. And if you're trying to figure out why that is, it's pretty obvious, right? Because what we did was we created an image which copied all of our code here at that point in time. And then when we did a Docker compose up, it created the image. And then that was it, right? Nothing else changes, right? Afterwards, we went in and changed the code, but the image was already created. So whatever's in the image, nothing changes after that point. So any changes we make will not get copied over to our container. So what do we do in this case? How do we get around this limitation? Well, what we can do is we can make use of a special volume called bind mount. And a bind mount is a special volume because it allows us to sync a folder on our local machine with a folder in our container. So this app folder, which has all of our application code, what we want to do is we want to sync this folder in our container with this folder here so that if any changes get made here, it's going to get copied over to our container. And so under volumes in our API, we're going to define a volume here. And I'll say volumes, right? Just like we did with Postgres, very similar, except we're going to use a different syntax because this is a bind mount. So a bind mount, we have to first provide the path of the folder that we want to sync on our local machine. So this is our current directory. So we can just do / for current directory. But if you wanted to sync just one individual folder, maybe like the app folder, then you can do / app. Up to you, but I'm going to sync everything. And then we have to specify the path in our Docker container, which is going to be this folder right here. And that's going to automatically sync the two folders. And if you wanted to add some extra security, you can do RO. This means read only. So what this does is this makes it so your container can't change any of these files, because only we should be changing the files, not the container itself. So this just adds a little bit of extra security if you wanted to, but it's still technically optional. And let me exit out of here. And now we'll do a docker-compose down. And we'll do a docker compose up again. And now let's just change this all together. So bind mount works. So if we see that, that means everything's working. So let's save it. And if I send, we can see that I get the old one now, right? So whatever I changed here doesn't get copied over. So it looks like we didn't fix the issue. So let's actually take a look and see what's happening. And so how do we do that? We'll do the docker exec command again to go into the file system. Let's go into the app folder and let's cat that main.py file. And this is interesting because it looks like the bind mount did work, because we can see that the code got updated. And if I make another change again, this time let's just add sort of. And if I cat this again, we can see that it's in there. So the bind mount is working and it's syncing the code with our local directory and our container, but there's one issue. And if I go back to my Docker file, you can see that I have my command right here, but this doesn't have the -- reload flag, which is what we need to restart the application. So anytime we make changes to our code, we need it to automatically reload when it detects any changes so that we can actually see the new application. And we didn't provide that in the Docker file, and so that's why it's not working. So this is actually a pretty simple fix. We just add the -- reload flag. So let's tear everything down. And we have a couple of options. So I can go here and say -- reload, and that would work just fine. But instead of doing that, what I would rather do is, I like this default one because this is the one you would technically use in production, because you don't want dash reload in production. But in our Docker compose file, we can actually overwrite it. So we can provide another flag called command. And here we can provide a command to overwrite that from the Docker file. So I'll say uvcorn app.main app -- host 000 -- port 8000 -- reload. All right, and let's bring this back up. Let's just see what it is currently right now. So we got whatever it is now, and let's make a quick change. And I'll just delete all of this and change this back to hello world. And let's test this out. And we can see that it does successfully update. And so now our bind mount works and we automatically restart our code. So our development environment more closely matches up with what we had before we moved to Docker. Okay, so if you haven't already done so, go ahead and create an account on Docker Hub. It's a free account, but I want to show you guys how we can set up a repository on Docker Hub so that we can actually store our images here. And so Docker Hub is kind of like the Docker equivalent of GitHub, where it's kind of acting as a repository, but instead of a repository for our code, it's a repository for our images. So we can upload our images. Anytime we make a new image, we can actually upload it so that we can track changes to our images over time. So make an account, and then we want to go into repositories, and we want to select create repository, and then give this a name. It doesn't really matter what you want to call it. I'm just going to call it Fast API. And then we're going to do public because you only get one private repository. And so now we have a private it's the public repository. And so this is the URL to the repository, which is going to be your username. This is my username. And then this is the name that I gave it, so Fast API. And so now what I want to do is I have an image, right? If I do Docker image ls, we could see that I have my fast API underscore API. This is going to be the image that I want. And so how do I actually upload this image to Docker Hub? Well, there's a command called docker push. All right, so if I do a docker push -- help, you just pass in docker push and then the name of the image. So let's try doing that. We'll do docker push and then the name of the image, which remember, yours is going to be a little bit different because it's going to be based off of your folder. Let's try this. And it says requested access to resource is denied. So the first thing that we have to do is we actually have to do a Docker login. So we have to log into our account. So you do Docker login here. It's going to ask for your credentials. So we'll do sloppy networks in this case for me, and then it's going to be whatever it is for you guys. And then now let's try to push it again. And once again, we get a access to resource is denied. So what exactly is happening here? Well, when we want to push up a image, right, there's a very specific naming convention that we have to use, right? We have to name it exactly like this, sloppy networks / fast API. And we even see an example right here. So you do docker push, the name of your email or your account name, then the name of the specific repository, and then you can give it an optional tag name. So what we got to do is we got to rename our image. So how do we do that? I think it's docker image. I think, well, let's do -- help just to see if we can figure it out. We want tag. So this essentially copies an image and renames it for you. So let's do docker image tag -- help. And here we just provide the source image and then the target image. So what is my image called again? It's going to be this one right here. And we just do docker image tag, then the image that we want to rename. And then we give it the new name, which has to be your account / then the repository. And then you have an optional, tag. The default is just going to be latest. So I'm just going to leave it without a tag. So I do that. And if I do a docker image ls, we should see the new one right here. And so now I can do a docker push. It looks like I didn't copy that. So let's try this one more time. And now it looks like it's pushing something. So let's give this a minute or two. And then once it's done, let's take a look to see if we have successfully pushed it to our repository. All right, so it looks like it's successfully pushed. So now if I go back to my Docker Hub page and do a refresh, we can see that last pushed was a few seconds ago. So now we've successfully pushed it to our Docker Hub. And so, if we set up an actual production Docker environment, we could just pull the image from this specific URL or this specific repository. Now, before we wrap up the Docker section of this course, there's one last thing that I want to show you guys. And that is that if you take a look at what we have right now, we have a identical clone of our previous development environment, but we're now developing within a Docker container. So our Docker container environment is a exact clone of our previous development environment. The issue is that, when we move to production, assuming that you're using Docker in production, which is kind of the main idea behind Docker, is that your development environment and your production environment are almost exactly the same because you're using the same exact Docker images and containers. But if we try to use this Docker compose file in production, there's going to be a whole bunch of issues. First of all, obviously these environment variables would need to change and we can't hard code them. We wouldn't want the -- reload flag. And you certainly don't want a bind mount because the code shouldn't be changing. And then the ports that we use could also potentially be different. So even though the Docker environments from our production and development environment should be roughly similar, there are going to be some differences. And so we need to account for that. And so what I like to do is I actually like to create two different Docker compose files, one for development and one for production. So that's what we're going to do. But first of all, let's do a docker compose -down. That we can just tear everything down for a second. And once that's down, I'm going to copy this. And paste it. And we're going to rename these files. So this one is going to be called docker compose-dev. So this is going to represent our development environment. And this one is going to represent our prod environment. All right, so we've got our dev and our prod environment. The dev doesn't need to change because we had already set that up for a development environment. The production one is going to change a little bit. So first of all, the command, right? We don't want the -- reload. So we could specify the exact command we want, which is the one without the -- reload. And that should be all that we need. However, keep in mind, this is the default command from the Docker file, right? So we could technically just remove this or just comment it out. And so I'm just going to comment it out in this case. But if you wanted a specific custom command for production, you can just provide that here. The whole idea is that this file is going to represent all the changes for our production environment. Then maybe we want, instead of listening on port 8000, we want port 80 so that we can use our web browser. Most of the things can stay the same. The environment variables definitely need to change. And so with a production environment, first of all, we're not going to hard code the values. We usually want to grab these values from the environment variable set on the host machine. So instead of actually hard coding these instead we can reference environment variables. So to reference an environment variable, what we do is we do $ curly braces and then the name of the environment variable. So it's going to look on the Linux machine that it's running on for a environment variable called database hostname. So I figured we would just have them match just to show you what that would look like. And then we're going to do the same for all of these. And I'm just going to copy and paste this once again. So it's going to look like this. So it's just grabbing the the environment variable from the local machine. Keep in mind, they don't technically need to match, but it just makes it easier for troubleshooting purposes. And then for the Postgres database, right, we would want the password to be the same environment variable. And then we would want the database name so that we're not hard coding that one as well. And we don't want the bind mount, so we will remove that. And that's about it. So that's all you have to do. So this just gives us both a development environment and a production environment. We'll save all of that. Now, starting up Docker Compose is going to be a little bit different now because we don't use the default docker-compose.yaml file name. So if I do a docker compose, if I can find the up, docker-compose up, right, you're going to see that it throws an error, right? Because it says it can't find a docker-compose.yaml or .yaml with an A or compose.yaml or compose.yaml with an A. So it looks for only these file names. So when we have a custom file name, we have to do docker-compose, and then we pass in the -f flag for the file name. And so we provide the path to the file. So it's just in the current directory. So I could just do docker-compose-dev.yaml. And then we just do an up and then -d. And then we can start it back up. And if you want to bring up a production environment, then you would do --prod. That's the only difference. So you don't really have to do anything else other than running the different specific Docker Compose file. And the last thing that I want to change is actually in your production environment, you don't actually ever want to build the image in a production environment. Instead, what's recommended is that when you're done developing, you push the brand new image to Docker Hub, right? And then in the production environment, we just pull this image from Docker Hub. So how do we pull this image from Docker Hub? Easy. We remove this build option. Remember, this is going to be in the prod file. And we set this to be a image. And here we just set this to the name of the repository. So we just do, your username /fast-api -app, just fast API. So whatever is essentially right here. And then if you want a specific image with a specific tag, then you would add the tag as well. And so that's all we have to do. Feel free to stop your containers now if you want. And even when you do a down, you want to make sure you do a -f. So it knows which file to actually look for. And I misspelled that. And that's going to conclude the Docker section of this course. And so I think this is going to give you a solid foundation on how to dockerize your fast API. Now, currently, whenever we make changes to our code, whether it's implementing a new feature or modifying the behavior of a previous feature or even fixing some bugs that we happen to catch, right, we have no idea if the changes we make break other functionality in our code. And so normally anytime we make any changes, we then have to go into Postman and essentially manually test out every single scenario to ensure that things are working. And this isn't a very scalable solution. It's going to result in a lot of wasted hours. For every single time you make any changes to your code, you're going to have to test everything because you don't know what code you've broken by making those changes. And so this is where an automated testing library comes into play, where we can define a whole bunch of tests to test a majority of the functionality of our code. And so that way, anytime we make changes to our code, we can run our tests to see if we've broken anything. And keep in mind, obviously we can't test for everything, but we can at least test for enough things that we can catch some of the more obvious bugs. And so this section of the course is going to be dedicated to getting started with testing and really understanding the concepts of testing and seeing how we can get started with a library like Pytest. But I do want to provide one little disclaimer before moving forward. I wasn't originally going to post a section on testing for this course. And the reason for that is that I don't have much experience with testing. It's not something I do a lot of or at all, really. And so I want to make sure that you guys understand where I'm coming from when it comes to testing. And that is that, since I am not super proficient at testing, I don't really feel too qualified to actually teach it. And so what I want you guys to do take out of this section of the course is just how to get started with testing. How do you set things up? And what's the main ideas behind a test? I may not necessarily be teaching the best, most efficient way to test. I may not be using the most efficient way of testing. And there may be scenarios where I may not even be following best practices, but I want to show you guys how we can at least get some integration tests set up. And then at that point, what you guys can do is you can just forget everything else that I've taught you when it comes to testing. Once you at least have the groundwork, then you guys can, do your own research, figure out how you ultimately want to implement testing with any of your projects, and then go ahead and just run with that. So with that in mind, in the next video, we'll get started with getting Pytest installed and writing our first test. For testing, the library that we're going to be using is Pytest. So if you do a quick Google search, you can just search for Pytest, and the first result is going to take you to the documentation page for the Pytest library. And so I recommend you guys take a quick look at this just to see how it gets set up. And if you go on and do a little bit of reading before we actually get started writing our first test, definitely go ahead and do that. But once we've got that opened up, what we can do is we can install Pytest. So we can just do pip install Pytest just like we would with any other package. Then once that's done, we have access to the Pytest command. So just go ahead and run Pytest and see what happens. So it prints out a few things. You notice that we can see that the test session starts. So this is when we start testing. It prints out some information about the platform that we're running on, and that's okay. We can ignore all of that. And you'll notice that it says collected 0 items. We'll talk about this in a bit, but the more important thing to look at is it says no test ran in 0.04 seconds. And this is expected. We haven't created any tests, so obviously it's not going to be able to run any tests. But to run our testing, all we have to do is just run this command, and then you'll see that Pytest will go through all of your tests, run it to verify, that they all pass. And if there's any errors or anything like that, it's going to report that. So it really is as simple as that. But let's go ahead and create our test. And I want to store all of our tests inside a directory called tests. So inside the root directory of your project, just create a new folder. We'll call it tests. And technically, you can put this folder anywhere. If you wanted to put this test directory within your app directory, you absolutely could. It's a matter of personal preference. I'm just going to keep it outside of the app directory for now. And within here, I'm going to actually create a file. And this is going to store our first test. I'm just going to call this mytest.py for now. All right. And we obviously need to test a part of our code, whether that's a route or a path operation or a function or a class. We need to test something. And right now our code is a little advanced. And when I say advanced, I don't mean advanced because anything we've done is super advanced so far. It's advanced from the perspective of testing, where we're coming in from a background of no knowledge of testing. So we want to start out with testing the simplest functions. So I'm going to actually create a brand new module and essentially create the simplest module or function that I can possibly think of. So I'm going to create a new file, call it whatever you want. I'm going to call this calculations because it's essentially going to be a bunch of functions that we use to perform certain calculations. And I'm going to define the world's simplest function, which is called add. And I think you can guess what this function is going to do. It's going to take two numbers, which is going to be of type int, and it's just going to return the sum of them. So we just say return num1 plus num2. Right? And the reason, once again, is because this is going to be very simple when it comes to testing, so you guys can at least have an understanding of how to actually perform these tests. So we've got this module defined inside our app directory. And then in our tests folder, we've got our mytest.py. And we're going to define our first test. So what is a test? Well, it's really just a function. It's either a function or a method within a class. We're going to start off with just doing functions because it's just a lot easier. And we're going to call this function test_add. Why did I give it that name? Well, it's testing the add function, so I think that makes sense. And technically the naming does matter, but we'll come back to that in a bit. Now, how does this function actually work from a testing perspective? Well, it's very simple. Pytest will run through all of our tests. And when it runs through this specific test, what it's going to do is if it runs through it and there's no errors get thrown, that means the test has passed. It's succeeded. That means our code is good. If our function throws an error of any kind, it's going to consider our function or our test as failing. Then the test has failed. So how exactly does that work? It's simple. We use something called assert. And if you aren't familiar with what the assert command does in Python, anytime you assert a true value, nothing's going to happen. The code just runs. However, if you assert a false value, that means it's going to throw an error. So it's no different than raising an error or throwing an error. In Python, it's just a simple way of doing that for testing purposes. If we return something that's true, then the assert won't do anything. If we return something that's false, then it will raise a Python error. And I'm going to show you exactly how that works. So if I just say assert true, and before this, I'm just going to do a print testing add function. And then down here, I'm going to just call the test_add function right here. And I'm going to just run this as a normal Python module. So we're not going to even treat it as an actual test or anything like that. We're not even going to use Pytest. So I'm just going to call Python. And keep in mind, the command is Python on Mac, but it's Py-3 on Windows. And then we're going to go into the test directory. And we're going to call mytest.py, and I'm going to show you what happens. All right, we can see it says testing add function, which is from this print statement. And then you can see the assert did nothing. So it just ran and everything's fine. And that's expected because, like I said, assert only does something when we return a false value. So if I say false now, and I run this code, take a look at what happens. Hey, look, Python throws an error. So assert is simple as that. True means nothing's going to happen. False means it's going to throw an error. And we don't have to just say true or false. We can actually pass in a condition. So if I say 1 = 1, that's going to return true, right? So technically, an assert of true won't do anything. However, if I say 1 = 2, that's going to be a false statement. And if I run that, we can see that it asserts and it throws an error. So that's how we make use of assert within our testing functions. So I'm going to remove this. And we're actually going to test out our code now. So to test out our add function, the first thing that we have to do is we actually have to import it into this file. So we're going to import it. So we'll say from, and we have to go into the app directory and the calculations module. So we'll say app.calculations, import add. And now what we're going to do is we're just going to call the add function like we normally do. And we need to give it some test data. So I want you to think of two numbers that you want to use for testing, add them up, and what is the result should it be? So I'm going to say, I'm going to do 5 and 3. And I know that this function, if it works properly, should return a value of 8 because 5 + 3 = 8. And so I can just take the sum, store that in a variable called sum. And what we can do is, since I know sum should ultimately be equal to 8, I can assert that. And there should be no e there. So I can say sum equals 8. So that means if our code runs fine, sum should ultimately equal 8. And if we assert 8 = 8, that means it's going to return true and nothing should happen. Or Pytest should consider it as passing. However, if I mess up my code and for some reason the add function returns a value of 20, then when we do assert 20 equals 8, well, that's going to be false, and it's going to throw an error, and it's going to consider that as a failing test because an error means a failed test. So that is the main idea behind a simple automated test within Pytest, right? You run the code with some test data, and you know what the result should be because you created this test data, and you just make sure that the result of the code matches with your expected result. So let's actually run our test now. So I'm going to do Pytest, and let's see what happens, right? And you see the same exact thing we saw before. Once again, it says it collected 0 items, no tests ran. And so why exactly is this happening? Well, if we go to our documentation, and you scroll down to this feature section, you go to the auto discovery section. And so this auto discovery section is going to explain how Pytest finds all of the tests in your code, because it does have a auto discovery functionality where it can actually go through all of your code, all of the directories and packages, and recursively look through them and find the tests. But it looks for specific keywords. And you can see in these directories, it looks for any files that start with test. So you have to do test underscore and then some name, or some name underscore test.py. And if we go to our code, right, we name this my test. This does not match what it's going to look for. And that's why it doesn't actually find any tests from that. So let's change this. I'm going to call this, let me rename this, and I'm going to call this, how about test underscore calculations. All right, and so now if I run this, you can see that it throws an error, but I realized that, within my tests package, I do need to have the usual underscore init underscore.py to actually make it a package. So I'm going to do the same thing. I'll do underscore init underscore.py. Because of that, it wasn't able to actually import the file properly. So let's save that and let's try this again. So now if I run this, you can see that, hey, look, we collected 1 item. So I think it's safe to say that this collected 1 item probably means we have 1 test. So the number of tests equals items. And then we can see that inside the tests package, we have a module called test underscore calculations.py. And then there's a little dot. So the dot represents 1 individual test. And a green dot means good. A red dot means it failed, right? Green is pass, red is fail. And so if you have 2 tests, then you would see 2 dots. And then if the second test passed, it would be green. If it failed, it would be red. Simple as that. And so now we have successfully ran our first test. And just to make our code a little bit simpler, right, I could just, instead of having the sum variable, I can just cut this out, just paste it into here just to make it a little bit cleaner, and then we can remove all of this. And just to make sure I didn't break anything, let's run our test again. And we can see that once again, it worked just fine. Now, when it comes to the auto discovery of files, a few things to note. You don't necessarily have to follow this convention of test underscore calculations. If I actually rename this, and I call this, my underscore test, what did I call this? My test.py. Right, now if I obviously run this, it's not going to find any tests, but I can pass in the specific path or the specific module that I want to test. So if I do my test.py, then it is able to find the test. But I like to have Pytest be able to automatically find all my tests so that I don't have to specify this. So we'll rename this and go back to test underscore calculations, because it ultimately is a module that's going to be testing my calculations module. And another thing to note, the name of the test within the module also matters. If I call this, maybe something like testing underscore add, take a look at what happens. Whoops. I wanted to auto find it now, and I forgot to save it. Now if I run this, it looks like it still works, but let me change this to just something random. Right? And so now we can see that no tests ran. So the naming of the function absolutely matters when it comes to auto-discovering tests, and you want to stick to the standard of test underscore something. And I think somewhere in this documentation, it's going to go over, here we go, test from those files, collect test items. So a test prefixed test function or method outside of a class, or a test prefix test function or method inside a test prefix test clause. So it's got to start with test, essentially. It doesn't necessarily have to be test underscore. That's why testing underscore add worked just fine. It does have to start with the word test. That's why if I said add underscore test, I don't think this will work actually. Shouldn't based off of their description, and it doesn't. So keep in mind that the naming does matter. And I recommend you stick to the convention of naming all of your testing modules test underscore, then the name of the module that you want to test, and then your functions test underscore, and then the name of the function that you want to test or the functionality that you want to test. Now, a couple of things to note. I'm going to run this test again, and you'll see that it doesn't really give us much detail as to what's happening, but we can pass in other flags to get a little bit more detail or to change the functionality. So if I do pytest -help, you'll see that there's a lot of options, but I think something that would probably be helpful is like a -v for verbose, and I think we should have that in here. So let's see if I can find that. Here we go. -v is increased verbosity, so we'll just do pytest -v, and let's see what happens. And so now, instead of just having a dot, it's actually going to list out the specific test that's running. So I think that's a little bit more helpful, and I usually like to run these tests with a little bit of extra verbosity, just so that I know what's happening. However, maybe in an automated environment, you don't really care about that. And the other thing to note is that we have this print statement here, but nowhere in the output do we actually see anything get printed out. I don't see testing add function anywhere in here. And the reason for that is that by default, Pytest will not actually print out any of your print statements. We have to pass in an extra flag to do that. So to see the print statements, you have to pass in -s. So now if I run this, we can see that we ran this specific test and it ran testing add function. And so keep in mind, anytime you want to print something, you got to pass in the -s flag. Okay, guys, so testing really is as simple as that. But before we go on to more complicated tests, I want to just make sure that we fully understand how this works. So we're going to create a few more dummy functions that we can use for testings. And if I go back to my calculations.py, I've already written this out, so I'm just going to paste it in here not to waste your time. But you'll see that they all essentially do the same exact thing. They just perform some sort of mathematical operation. So I've got the subtract function, which just subtracts two numbers. I've got the multiply, which adds two numbers. And I've got the divide, which just divides two numbers. So let's test this out now. The first thing that we got to do is, well, let's import all of those. So there's subtract, multiply, and divide. And let's define our function for subtracting. All right. And so just like before, I'm going to do a one-liner. So I'm just going to say assert, and we'll say subtract two numbers. What numbers do I want to subtract? How about 9 and 4? Whoops, 9 comma 4. And we know that 9 minus 4 should equal 5. So I can do assert equals 5. All right. And if I run this again, all right, we can see that both tests pass. And just to make sure that, our testing actually works, let's actually go into our code and let's essentially create a bug. So if I want to add two numbers, right, we know that's going to be num1 plus num2, but let's say, one of our moron colleagues went in and added 1, which is ultimately going to cause our function to break. And so ideally, if everything works fine in our testing, it should be able to catch this. Because if we add 5 plus 3, it's going to do 5 plus 3, and then it's going to add that extra 1. It's going to return 9. 9 equals 8 is going to assert to a false, which is going to throw an error. So if we try this out now, right, we can see that it did in fact fail. And because we set this to be verbose, we can see exactly what happened. So we ran the test add, and what happened was it asserted add 5 comma 3 equals 8. So it's asserting 9 equals 8, and that's going to throw an error. And so that way we see one failed, one passed, so the subtract function still passed because we didn't touch the code for that. So I'm going to go back and fix our bug in this case. And we're going to just set up a couple more test functions for multiply and divide. And I can just really just copy these actually. And I'll just change this to multiply, divide, and we'll just select a couple of numbers. So let's say, and I realized, looks like that's a typo. This should be multiply with an L. All right, and we'll say 4 and 3. So when we multiply 4 times 3, that should equal 12. And for divide, we'll change the function that we're calling to be divide, and we'll do 25. So 20 divided by 5 should equal 4. And so now if I save everything, we should ideally see all 4 of our tests pass. So let's try this out again. And you don't have to use the -v or the -s flag. If you're not printing anything or you don't want to see it, you don't need the -s. And maybe you don't want the verbosity, so you could technically remove those as well. And we can see that we get 4 dots, which means all 4 of our test functions have succeeded. If you're like me, the first thing that you may have noticed is that, testing with one set of numbers doesn't seem ultra reliable, right? That doesn't necessarily assure us that the function that we wrote actually does what it's supposed to do. I would ideally like to test with a couple of different sets of numbers. And the way to do that is, well, I'm sure if you just took a guess, right, you're probably thinking, well, maybe we just copy this function, paste it. Well, that should be back here. And then maybe just call this test add 2. Maybe we don't need this print statement anymore. And then you provide the other sets of numbers. So maybe like 4 and 2 should equal 6. And then you try this out and you run this. And we can see that that worked. And technically you can do that, but Pytest provides us a simpler way of doing this. So I'm going to delete this because we don't need that. I'm going to show you how we can do this using something called parameterize. So I'm going to import Pytest. So I'll say from, actually I'll just say import Pytest. And we're going to add a special decorator from the Pytest library. So we say at pytest.mark.parameterize. And so here we can essentially provide a list of numbers that we want to use for testing and then provide what is the expected result. And so, our function takes 2 inputs, 5 and 3, and we also need to provide what is the result. So these are all the values that we're providing. We have 3 values for this specific function. So we're going to tell this specific decorator what are the 3 things that we want to provide for each test case. So in quotations, we'll do num1, num2, and then the expected value. Now, what you call these doesn't matter. It's up to you, right? But these are going to be treated like variables, essentially. So you can call them whatever you want. You can call this X. You can call this Y. You could call this result. It doesn't really matter. But I'm going to stick with num1, num2, and expected. And more importantly, take a look at how this is set up, right? Your instinct is probably to do the end quote here, and then quote here, and then quote here like that. That's not what we want. That is not how it actually works, which I don't know why they decided to do it like this, but that's just what they've chosen. So instead, you remove these, and everything should just be one big string. So that's the first argument into this decorator. The second thing is going to be a list. And it's going to be a list of tuples, and each tuple should represent one specific test case. So the first tuple, we're going to provide our test case values. So we want, what is the value of num1? So in the first test, let's say we want 3 for num1. What's the second one? That's going to be num2. So it's going to line up with what we've put here. So we'll say 3, 2. And then what is going to be the expected value? Well, 3 plus 2 should equal 5. So we just say 5. And so that's our first test. If we want to add a second test, just do comma, add another tuple. And let's just add another set of numbers. So let's say num1 is 7, num2 is 1. We know that should equal 8. And just one more test. And here I'll say 12 and 4 should give us 16. All right. And so now what we can do is we can pass these variable names into our test_add function. So I'll say num1, num2, and expected. All right. So you want to make sure these match up with what you've placed here. Because if this was called X, then you want to make sure that this is called X. But we'll change that back. And now in our code, we want to replace all of our test values with these variables. So this is going to be num1, this is going to be num2, and this is going to be expected. And so now if I run this, and we'll just do a -v just to see it more in detail what's happening. Take a look at what's happening now. We can see that test add ran, and it ran with 325, which is the first test case. It passed. Then it ran the same exact test with these values, 718. That passed. And then it ran with these values, and that ran, and it passed just fine. And then finally, all of the other functions also passed as well. So this is one way of running the same test over with multiple values without having to just define 3, 4, 5 functions and just copying and pasting. It's a little bit cleaner doing it like this. So till now, we've just tested some simple functions, and you'll see that when it comes to testing, anytime you want to test a function, it's actually pretty easy. However, when you're working with classes, it gets a little bit trickier, and it usually involves having to write a little bit more code. So I've created a simple dummy class in this case called bank account, and this represents a person's bank account. And I've already written this out because I didn't want to waste your time writing this out. So if you want to pause this video and just copy down the code so you can follow along, go ahead and do that. But let me just quickly walk you through what this specific class is doing. But like I said, this represents a bank account. So first of all, we've got the constructor. So when we create a bank account, we can create a bank account with a specific amount of money, which is going to be referenced by the starting balance value. And then it's just going to set the balance property of the bank account class to be whatever you provide. If you don't provide a starting value, it's going to default to a value of 0. Then we've got 3 different methods. We've got deposit, which means we're going to deposit money into our bank account. So all we're doing is we're going to pass in a value, and then we're just going to add it to our total balance. Withdraw is the opposite. We're going to subtract a certain amount from our balance. And then collect interest is simple. We're just collecting interest. So here we just take our balance and then multiply it by 1.1, which I guess would represent a 1% interest rate. And so those are the 3 or 4 functions, methods, if you want to count the constructor method as well, that our bank account class has. So I want to go ahead and test this out now. So we'll go to our test calculations. And first of all, we want to import our bank account class. So let's create a test for our bank account. And the first thing I want to test is let's create a brand new bank account. Where we set the default value, to, the initial amount to be 50. So here I'll say test, and I'm just going to call this maybe test bank set initial amount. I want this to be as descriptive as possible. And so here what we're going to do is, first of all, we're going to create a brand new bank account instance. And since this test is going to test to ensure that we have actually created a brand new bank account with a certain amount of money, I'm going to provide a value. Doesn't matter what value you decide to use, but I'm going to use 50. And we'll just store this in a variable called bank account. All right. And so to test if our function actually worked, or the functionality of our constructor method actually worked, what we're going to do is we just say assert. And we want to check the bank account dot balance property equals 50, because we set the default value to be 50. And if we just quickly go back to our code, you can see that we set the starting balance, or we set our balance property to be whatever the starting balance is. It just happens to be a default of 0 if we don't provide one, but we are providing one, and that's what we're testing. So we can test this. Let's run our code now, and let's see if this worked. We can see that it did in fact work. And just to introduce a bug, maybe we set starting balance to be, -1, right? So we've broken our code. Now if we run this one more time, all right, you can see it failed because we subtracted 1, so we're asserting 49 equals 50, which throws an error, which means we ultimately failed the test. So let me remove that bug. All right, the next thing that we want to do is let's test to make sure that the default starting balance works as well. So I'm going to create another function, and I'll call this about test bank _ default amount. So in this case, we're just going to create a brand new bank account, and we're not going to pass in a value, so it should default to 0 if our code works. And then we'll store this in a variable just like we did before, and then we'll assert. I can copy this, but now it should equal 0. Okay, and let's test this out now. All right, and it looks like it worked, so great. And let's just quickly go ahead and test our last two functions out. Sorry, we got three more actually, so let's test the withdrawing functionality. So we'll do test_withdraw. And here we're going to initialize another bank account instance because we have to do that every time we want to test it. I'm going to give it a default value of 50. It doesn't have to be 50. Once again, you can choose whatever number you want. And we'll store that in a variable called bank account. And we'll call the bank account withdraw method. And we're going to withdraw, let's say $20. So we start out with 50, we withdraw 20. We know that the result should be 30. So if I just copy this assert statement once again, I can just change this to 30 and it should be no problem. Run this. Once again, all of our tests have passed. Let's try the deposit functionality now. So I'll create a test to test that. And I'm actually just going to copy all of this code because it's pretty much identical. You'll see that testing can become a little repetitive. We'll start out with an initial value of 50. Doesn't really matter. We'll change the method to be deposit. Maybe we want to deposit $30. So 50 plus 30 should equal 80. We test this out. Looks like everything's working. And the last thing that we want to test is the collect interest method. So let's create a function for that. We'll do test_collect_interest. And once again, I'm going to copy this code. And we'll just use it here. We're just going to change the method to interest or collect interest. Okay, so we start out with the value of 50. And so what should the interest be? Well, if I take a look at what my method actually does, it just takes the number, multiplies by 1.1. So that should give us 55, right? 1.1 times 50 should be 55. So I will say this should be 55. And let's see what happens. So if I run this, we can see that we did have one test failed, and I'm assuming it's going to be the last test, the one we just created. And we can see the test collect_interest failed. And the reason for that is that it looks like bank account.balance returns a value of 55.0000001, which in Python is not the same thing as 55. So this isn't necessarily an issue with our code. It's just the way that we're comparing numbers in our test. So this is an issue with our test in this case because it's not accounting for some of the different rounding and the way that calculations occur within Python. So what we're going to do is we can just call the round method right here, and we can round it to 5 or 6 decimal places, depending on how accurate you want it to be. So it should now round it to this value, however many decimals is 5 or 6, and then convert it to an integer. So then we can compare these two because this is an integer, this is technically a float, so they're not going to be equal in that case. So now if I run this, we can see that it did successfully pass. So that's just something to keep in mind. That's why I added that little extra test case, just to make sure that, especially when it comes to those calculations, you got to make sure that you're comparing the right two numbers. If you look through all of the test cases for the bank account, you'll notice that there's some repetitive code. Right? For every single test case that we have for testing our bank account, you'll notice that we always have to initialize a bank account instance. Right? And you can see that right now, look at that. We are repeating our code across all of our tests. And when you get to more complex classes, more complex test case scenarios, right, you might have 50 tests for a single class. And we're, in this case, just repeating the same exact code for each one of them. And so when it comes to writing these tests, Pytest does provide us with some tools that we can use to minimize the amount of repetitive code. And one of those is called fixtures. And a fixture is a very simple concept. It's nothing more than a function that gets run before each one of your tests, or at least the specific test that you want. So we can create a function which does nothing more than initialize a bank account and then return it to our function that's about to run. So I'll show you how we can do that. Right, the first thing we have to do is let's create our fixture, and we can put it anywhere. I'm just going to put it here for now. But generally, you want to put it at the top of the file. Actually, I'll stick to the best practice. I'll say at pytest.fixture. And then here we create a name for our fixture. So I'll say this is going to give us or initialize us a bank account with a 0 initial value. So I'll call this 0_bank account. Right, and so all we're going to do is we're just going to return an instance of bank account with an initial default value of 0. And then we'll create one more fixture. And this one is going to return a regular bank account with an initial value. And what value we want to give it, we get to decide. So I'll just say return bank account. And in this case, 50. All right. And so now what we can do is for all of these tests, I don't need to initialize them here because I can have these guys reference the fixture. So to assign a fixture or have a fixture get called for a function, we just pass it in as an argument. So for test bank account set initial amount, we're going to reference the 0_bank account fixture. So what exactly happens is when Pytest goes to run this test case, because it sees this as an argument into the function, it's going to, oops, that should be a 0. Okay. But what it's going to do is it's going to call this function before it actually runs the test case. So it calls this function, and then whatever we return here, which is the bank account, gets passed into a variable called 0_bank account. And so now, instead of creating a bank account instance, I can remove this and I can reference this variable, which is 0_bank account. So let's test this out. Let's see if that broke anything. If we run this. Oh, sorry, guys. Let me undo this. I didn't mean to use this function. This is going to be for the test bank account default amount. So we want to remove this one. My apologies. And we don't need that in this one. And then this will be 0_bank account. So now all tests should pass. All right, so everything passes. But if you're still a little confused as to what exactly is happening behind the scenes or what is the order of operations, I'm going to add a few print statements. So I'm going to say testing my bank account. And then I'm going to put in a print statement inside my fixture as well, which is say creating empty bank account. And so now if we run this, I want you to take a look at the code. And I realize I have to pass in the -s flag to see the print statements. All right, so here we go. We're going to test bank set initial amount. Sorry, no, test bank default amount. And so you'll see that when we start this test, first things first is we create an empty bank account. That's that print statement for the fixture. So before the test even runs, we call the fixture because we've defined that here by saying, where is it? That it's going to be an argument into the default amount test case. Then after the fixtures run, which is just a function, we then run our actual test case, and then we get the print testing my bank account right after that. So once again, just to really drive home this point, a fixture is just a function that runs before a specific test case. That's all. But the great part is we can use the same fixture for all of our other tests. So let's go to the next test, which is setting an initial amount. And in this case, we have this fixture right here, which is the bank account one. And so I'm going to say this is going to go to bank account. So this will call the bank account fixture, and then we can remove this line. And we can just keep this here because it's referencing this variable now. And this should work now. So we run this, once again, all tests pass. And I can just do this for all of them. So I can just call the bank account fixture. And I can just remove that line. Everything else can stay the same. And the same thing here as well. And finally, for the last one, we can do that. And so now you can see that we have saved us ourselves a couple of lines of code for each function. And if I run this, you can see that all the tests pass. So at this point, you're probably thinking, this doesn't really look like it saved us a lot of code or a lot of, coding out. However, there's going to be certain things that you want to do that you want to initialize before every single test of your entire application. So maybe something like setting up a test database, right? You'd want that to be set up for each single test. Having to manually do that for each test case would become very cumbersome. And then the lines of codes that you're repeating start to become a serious problem. And that's really one of the best use cases for using fixtures is something like setting up a database or setting up, some sort of email service or something that you're going to use across a lot of your tests, and then having to initialize that manually for each test is going to require a lot of work. And so that's where fixtures really help save us some time. Okay, what I want to do is I want to create one more test. And this test is going to be a little bit different. I'm going to call this test about bank transaction, maybe. And so this is going to test us both depositing money and withdrawing money in one test case so that we can have a couple of different actions on a bank account. And so just like we've done before, when it comes to setting up a fixture so that we can retrieve an instance of our bank account class, I'm going to do the same thing, but we're going to use the 0 bank account. So it starts out with no money. And then what we're going to do here is we're going to reference the 0, and we're going to start off by depositing money. And let's say I'll deposit $200. And then we can also then withdraw a certain amount of money. So now we're testing both in one specific test case. And I'll say I'll withdraw 100. And we know that we should ultimately be left with $100. So we'll do assert 0 bank account dot balance equals 100. So let's test this out. And let's see how this works. And that works as well. But what I wanted to do is, for this specific test case, I wanted to show you that we can use fixtures and parameterize so we can test multiple values like we did for this specific test case. So what I'm going to do is I'm going to copy this so that we don't have to type this all from scratch. And we're going to create a couple of different test scenarios for this specific function. And in this case, we're going to have a deposited, we're going to have a withdrew, and we can have the expected amount. And keep in mind, you're not limited to having 3 variables. You can put as many as you want. It just happens to work out that I only need 3 in this case. And then we can provide some test data. So how about the same one we have right now? We're going to deposit 200, withdraw 100, and we expect 100 in the end. We can do the same thing. How about deposit 50, withdraw 10, and we should end up with 40. And then we've got our high roller, which is sitting there with a whopping $1,200. And he withdrew, how about 200? And he's going to end up with $1,000 at the end. And so now we can pass deposited, withdrew, and expected. And now we can use deposited here, withdrew here, and then we know what the expected is going to be. So let's try this out. All right, and we can see all 3 test cases run, and in this case, all 3 test cases passed. So I just wanted to show you guys that you can use this with our fixture. So it's okay if you're using a fixture, you can still use the parameterize decorator in this case to test multiple scenarios. If we go back to our bank account class and you take a look at the withdraw method, you'll notice that right now we're not performing any check to make sure that the user has enough money. And that's not really how a bank account works, because if you have $100 and you withdraw 500, the bank's going to be like, we can't do that. So it just makes sense in our code to actually perform some sort of check. And so usually, something simple is we'll say, hey, if amount that you're trying to withdraw is greater than your balance, well, what are we going to do? Well, we're probably going to raise an exception. So I'll say raise, and we're just going to raise a standard Python exception, and we'll just say something, hey, insufficient funds in account. Right? However, if we do have enough money, then we will actually perform that operation. So this is all good. If we go to our test calculations, and we just add one more scenario in this case, but this time we deposit, let's say, only $10, and we try to withdraw, I don't know, 50. Well, what is the expected scenario, the expected value? And it doesn't really matter what we put in, because this is ultimately going to, break our code, because we're raising an exception. So if I try to run this, right, it's going to fail because we're raising an exception. And remember, anytime you throw an error, that's going to automatically make the test fail. So what do we do? Well, first of all, let's remove this test case, because for scenarios like this where you expect to receive an error, we need to create a different test case. So I'll call this, well, how about test insufficient funds? And let's say we start out with, instead of using the 0 bank account, where's the, instead of using this bank account, we're going to use the 0 bank account, and then we'll just try to withdraw money. So that's an easy way of testing it. So we'll say 0 underscore bank account. So we'll have no money in our account. And we're going to withdraw some money. So we would do, actually, I'll just do a regular bank account. I don't know why I want 0. So we'll start out with $50, and we'll try to do a bank account dot withdraw, and we'll try to withdraw $200. So that should raise the exception. But how exactly in our test do we tell Python it's expected to receive an exception? Because right now, if we run this, once again, we're going to get the same exact error. Right? Failed. So what do? This is how you tell Python that you expect an exception. You do with, and then you call Pytest. Remember, we imported Pytest all the way at the top, right here. So we'll do Pytest dot raises, and then you provide the exception that you expect. So in this case, this is just a regular Python exception. So you can just say that, and then you provide the command that you're going to run. Okay, and so that way, if this command throws an error or raises an exception, Pytest will be told to expect this. So then it would consider the test as passing. So now if I run this, we can see that the insufficient funds test passed. And if we go back to our code and actually remove this exception, we'll comment out that entire statement. What do you think is going to happen here? Right now it's failed because it did not raise an exception. Pytest is expecting an exception and we didn't raise one. So then it considers that an error in our code, because when we expect an exception, we should expect an exception. So I'll uncomment this. And now, in real code, right, you wouldn't just throw just a generic Python exception. You're going to usually create your own exception classes. So let's say we define our own exception, and I'll call this insufficient funds, and this is going to extend the exception class. And we'll just say there's no properties, so I'll just say pass. And in this case, I'll say we'll raise an insufficient fund, insufficient funds. All right, so if I make this change, what do you think is going to happen? Do you think it's going to break our code? Well, let's run this. We can see that it passed. And the reason why it passed is because insufficient funds is a child class to the exception class. So when we say we expect an exception, technically we are getting the exception. It's just we haven't specified we specifically want a insufficient funds exception. And because this is inheriting from this class, Python says, hey, look, everything looks good. But if you did want to be as specific as possible, which is generally recommended, what we can do is I can import that exception. So we'll say from app.calculations, we can import insufficient funds. And now here we can say we expect a insufficient funds. And so now if I run this, we can see that it passes. And the benefit of this is that if for some reason our code raised another type of exception, it would consider this test as failing. So if I go back to my code and let's say that, for some reason something broke in our code and all of a sudden, instead of raising an insufficient funds error, we get some other kind of exception. And I can just simulate this by doing raise zero division error. So if you ever try to divide a number by zero, this is the exception that's expected. And so now if I run this, right, we can see that the test failed because we expected a insufficient funds exception, but we got a zero division error. And so that considers the test as failing because we've told it we've expected something, but we got something else. So it's generally best to explicitly define the exact exception that you expect so that you can make sure that, that nothing else is broken, because technically any part of your code can break and throw an error. And if it throws an error and we just try to, if we just tell, our test to expect any exception, then it may not be doing what we actually expect it to do. But we'll change this back. We don't need that anymore. Okay, so I think we have a good enough understanding on how to create a test, and I think it's time we actually started testing our application. When it comes to FastAPI automatically provides us a test client. So all we have to do is we just say from FastAPI.testClient import test client. And then all we have to do is then just pass in our FastAPI instance, which is stored under the variable app, and then we can just perform any requests to our application by doing client, which is what we named the test client, and then just doing a .get or a .post or whatever, and then we can get the response, and then we can assert anything that we want just to make sure that we get the responses that we ultimately expect. And keep in mind, when you make use of this test client, right, if you take a look at the documentation, it says that you use this the same way you would any requests object. So if you've ever used the request library from Python, right, this is the same exact object. So anything you could do with requests, you can do with the test client. So you can customize the request. You can, change the HTTP method. You can add a body, a payload. You can add a authorization header. It's really just doing what Postman's doing for us, but we're going to do it through code instead of manually opening up Postman and then, figuring out which request we want to send. We're just going to do it out in Python so we can do it all in an automated fashion. But if you haven't worked with the request library, definitely take a look at this. Just take a look at how we generate requests. It's not too difficult, right? It's just request.get, or in our case, we're going to call it client, but it doesn't really matter. And then you provide the URL that you want to run this against. And then, you can add in other properties like an auth header or anything like that. So it's just about customizing your specific HTTP request. And so I'm going to create a new file, and I'm going to call this, how about test_users. This module will represent tests for, creating users and getting user profiles information and things like that. And just like it shows in the FastAPI documentation, let's just copy this line right here. And then what we want to do is we want to import from our app package, go to our main file. We want to import our FastAPI instance. So we want to import this app right here so that we can actually test it. So I'll say from app.main import app. All right, so we have our app instance, and we'll just copy this line right here, which is just setting our test client to a variable called client. And so now we can run whatever tests that we want. And I think, just to keep things simple, let's start off with the simple root path that we have right here, just to test that this works. Because that way we don't have to worry about authentication or passing any other data. Let's start off with the simplest scenarios. So this is at the root URL. So we will go to our test users. And I'm just going to call this test root, because it's not really a real function or anything like that. And then here we'll say client dot. And since we are testing a specific path operation, this is a get method. So we want to send a get. So we'll do client.get. Then the URL, so we could just say /. We don't have to do localhost because it's not technically a running server. We actually just pass the actual app instance. So we just say the root path. And then you can pass in other things like what payload and things like that. But we'll leave that for now. Leave it empty, and we'll store the response under a variable called res. And instead of doing an assert or anything like that, for now I just want to print out the response. All right, and if I run this, okay, so a little bit annoying thing, right now it's going to run all of our tests. And if you just want to test one test or one module, then I recommend you just do the same thing except pass in the path to just your specific module so that we don't run all of our tests all over again. So we can just run one in this case. And if we take a look at this, we can see that it just prints out a response object. Not very helpful. But if you want to see what's the actual payload, we can say .json to see what the data looks like. And so then I can run this, and we can see that, hey, look, we get message hello world. And if I wanted to grab the message property, I could say .get and then message, and it should return hello world. Let's try this out one more time. And we can see that it prints out hello world. So to test that this route actually works, what we can do is we can just do an assert. And I could say assert and then literally just copy this exact message. And I could say, hey, the message should return a value of hello world. It's as simple as that, right? It's no different than what we did before with our addition function, right? We're just performing some action, running our code, and then making sure that the results are what we expect them to be. Right? And so now if I run this again, right, once again, still passes because it does return a value of hello world for the message property. And we can assert multiple things, right? It's not just one. We can do a second test case, and I can say res dot, and we can access a property called status code. It's even recommending that. So we can say, get me the status code. And I could say, well, I expect this to be a, if we don't change what the default status code is, it's going to default to a value of 200 as per the fast API documentation. So this should be a 200. We shouldn't get any other values. So if I run this, once again, everything works. But if I go into my code and create a little bug, let's say I just add, an exclamation point or something. Then if I run this, we can see that it fails. And that's because we expected hello world, but we got hello world exclamation. So let's change that back. And this time, let's create a different bug. Let's actually change what is the status code. And so I can't exactly remember how to do that. So let's go to our post router. And we just set the status code right here like this. So if I copy this and go back to here, and actually, was it in the decorator? Yeah, it's in the decorator. You put that in there. And we have to import status. And so now if I try this out and run this, once again, it's going to fail. And that's because we're asserting, and the response was a 201, but we expected a 200 as per our test, which over here says it should be 200, and it throws an error. So you can see we could test a lot of different things. You can choose to test each and every property that you're interested in to make sure that the response is exactly what you expect it to be. But at this point, I think we understand how to send requests. So let me just, first of all, undo those changes that I just made just to make sure I don't break anything else in my app. And we no longer need to import that. So remove that. We'll save everything and let's just run our test one more time just to make sure that everything's good. And it looks like everything passes. Before moving any further, I want to show you a couple of other flags that we can pass to the Pytest command so that we can kind of tweak the behavior of our testing. And the first thing that I want to do is if you take a look at the output, you can see that we get a whole bunch of warnings. And depending on how many packages and libraries that you have installed, you could potentially see a lot more warnings. And I actually hate looking at these things. So what I normally like to do is I usually like to pass in the dash dash. I think it's a disable warnings, I think. And so now if I run this, you can see that there's no more warnings and we just see the testing information. So I think that looks a lot cleaner. And then the other thing that I want to show you guys is till now, all of our testing when we've broken a specific function or class, we've only had one test fail. And I want to show you what happens when you have multiple tests fail. So we go all the way to the top in the test calculations folder, and then maybe I just change, the subtract function. So I'll change this to be 6 so we know that it's going to error out. And then also at the bottom, I'm going to change this test right here so that it returns 56 instead of 55. And so if we run this, and I'm going to do -v so we can see verbose, but you don't have to do that. But if you take a look at what happens, you can see that it runs the first 3 tests, and then the 4th test fails, and then it just continues running through all of the other tests, and then it fails on the next one, and then it finishes running all of the other tests. So the default behavior is when a test fails, we're going to continue running all of the other tests. And this may not be the behavior you want, so maybe you've changed your code and you just want to see if we've broken anything. And so you want your code to ideally run through the test, and the first time it fails, you want it to stop so that you can then fix that issue and then run through the rest of the tests afterwards. Or you can manually run it again because right now we only have like 16, 17 tests, so it doesn't take that long. But when you start to write a lot more tests and your code starts to grow, these tests can take minutes, sometimes more than that, depending on are you using an external API, are you using a database? These all add a significant amount of time to your tests. And so if you just want to see if you've broken anything, you may want Pytest to stop on the first failure. So if you ever want Pytest to do that, all you have to do is you have to pass in the -x flag. So this will tell Pytest to stop after the first test fails. So if I run this, you can see that we get pass, and then the first test failed, and then we stop and we don't do anything else. And so those are just the 2 flags that I wanted to go over. I don't think we'll really cover any other specific flags. I just wanted to go over these 2 because they just happen to be 2 of the ones that I do like to use occasionally. But let's make sure we go ahead and change all of our code back. So I think we changed this one. This should be back to 5. And this should be changed back to 55. And just to make sure, let's just run our code once more, just to make sure we didn't break anything and we could see all 16 tests pass. So now that we know how to simulate a request to our API, let's create a test for testing the user create functionality. So what we're doing is we're going to create a user and we're going to test this specific route right here where we create a user. So let's try this out. We're going to do the same thing. I'll call this def test _ create _ user. And here I can say res equals client like we did before, but this time it's going to be a post request. And the URL that's going to be /users. All right, and then since we're now sending a request, to create a user, we have to send data in the body. So to send data in the body, you say JSON equals, and then you pass in a Python dictionary. So this is going to get sent as the body. And if you go back to our specific route, which is right here, you can see that we expect the users create schema. So if we take a look at the schemas, you could see that somewhere in here, where's user create? Here we go. We expect an email and a password. So let's send an email and a password. And so for email, we'll say this is going to be hello123@gmail.com. And the password is going to be password123. And just to see that it worked, let's do a print, and I'll say res.json. And then the test requirements, how do we verify that it works? Well, let's start off with something very simple. So we'll say assert, and I'll say res.statuscode. We know that when we create a user, we expect a 201, and we can just verify that by taking a look at the path operation. But I think this should be good. And then now if I run this, and I'm going to run just this file. So I'll say test user. And let's see what happens. So we see both of them passed. And how do we verify that? Well, I mean, we should see this user in our database, right? So if I go to my PG admin, go to my database, and we'll go to our schemas, tables, and go to users, and we'll do a view edit all. All right, we could see the hello 123, so it was successfully created. I'm just going to quickly delete this again. Well, actually, let me show you what happens if we don't. I'm actually going to do something unique here. I'm going to say, well, actually, let's just do an assert, and I'll say res.json.get, and we want to get one field just to verify that it's correct. So what's the data going to look like when it comes back? Well, we should see a print, but I didn't. That's because I forgot to do the -s flag. But going back to the route, we're going to send the response as a user out. So we expect it to match this specific model right here. So it should have an ID, an email, and a created at. So let's add that in there. I expect the email to equal the email that I gave it. And you can really do as many, asserts as you want. So you could verify each single property has been set. You can verify that an ID has been set. I'm just going to keep it simple. We'll just say just the email. We'll just run that check. And so we'll run it again. And I'm going to do the -s flag as well. All right. And we see that it failed. And we can see that it failed because there's a duplicate key violates unique constraint of email. And that's because this user was already created, so I can't recreate him. So let me delete this. And I don't think if I select the number and then go to, oh no, it doesn't look like I can. There we go. Now once I select that number, I can delete this user. And then we could save that to database. And so now if I run this again, we should see it work. And we can see that both tests pass. And we can see that both of our assert statements were checked and validated, and they both looked good. But instead of doing it like this, we can even take it one step further. Instead, what we can do is I can actually import this user out schema into my test. So I can say from app.schemas import user out. And then I can remove this print statement. And what I can do is here, I can actually use the schemas. Actually, sorry. I'm actually going to change this import. I'm going to just import all schemas. So I'll say from app import schemas. And now I can actually create a new Pydantic model, and I'll say schemas dot user out. So we're going to create a new schema, save this as a variable. I'll call this new user. And we can pass in the data that we get back from the response. So I can say res.json. And remember, we have to actually unpack the dictionary so it's in the right format to create a new user out model. And now this is going to perform a certain level of validation. So it's going to confirm, hey, do we have an ID? Do we have an email? Do we have what was the other thing that we needed? And do we have a created at? So it's going to make sure it's got these three things. It's not going to check to make sure that it's the right email. It's not going to check to see if it's the right ID, but it's going to check to make sure that at least it has these three properties. So it automatically does some of the validation for us, and it'll throw an error if one of those are missing. And if it throws an error, then obviously Pytest will consider this test a failure. So by doing this, we've kind of saved us a little time. And now I can actually change this. Instead of doing this, I could say new underscore user dot email equals this value. So now if I run this, Hopefully this works. And it looks like it failed. And let's quickly see what happened here. Oh, once again, I forgot to delete the user beforehand. So we'll delete him and then try this test one more time. And they passed. So I think this is what we're going to do moving forward. We're going to make use of our Pydantic models to do some of the validation for us automatically so that we don't have 60 or 7, well, probably not 60, but we won't have 5, 10 different assert statements, which you can absolutely do. And you probably do want to, but this will remove some of them because it's at least checking to see if some of them are there. So before moving any further, we need to address something important. And that is that right now we are using our development database for our tests. And that's not good. I don't want to use my development database. I want to create my own separate database to perform testing on so that I don't get in the way of development or staging or any of our production databases. I want to create a completely separate database for testing. Right now, when we import our client, right, we're going to be using whatever the database is that we've defined in the rest of our app, which is going to be our fast API database within pgadmin. And we can see that right here. And so that's why I'm having to go in and make sure that it's created. And we've already got some other data which could potentially break our tests. And so I want to make sure that we have a completely separate database for testing so that it does not get in the way of anything else. So how exactly do we do that? Well, one of the great parts about the way we've set up our database is if we actually go to our database.py file, right, you could see that we've actually set up a dependency. So when we set up our dependency, you can see we created this function called getDB. And this getDB actually returns the session local. So this is what allows us to actually, make queries using SQL Alchemy. And that comes from this right here, from the session maker where we passed in all of our database connection details. And if we go into any one of our routes, it doesn't really matter which one, you can see that we pass in the dependency into the route. And the great part about having dependencies is that it's very easy to override a dependency in any environment, especially a testing environment. We can say, hey, instead of passing in, get DB, we can say, something like get, underscore test underscore DB, which is going to be a function that returns a test instance of our database instead of our development instance of our database. So I'm going to show you guys how we can set that up and how easy that is. So we'll go back to our test users. And we're essentially just going to copy all of this right here. So I want you to copy this all the way up to the URL. And we'll have to set up some imports, and we'll come back to that in a second. So let's just create some space. All right, so we've got all of this, and we need to import a few things. So we'll start off by, we'll have to import settings. So we'll say from app import. Actually, we'll say from app.config import, I think it's settings. Yep. All right, so we've got that cleared. We then have to import create engine. And so we'll go up here and I'll say from SQL Alchemy import create underscore engine. And then we need our session maker as well. And I think if I hover over this, nope, it doesn't look like it'll auto import that for me. So I'll say from SqlAlchemy.orm import session maker. All right, it looks like we got most of the issues. We still need declarative base, and we'll import that. I'll say from SqlAlchemy.ext.declarative import declarative base. And if you guys don't know where I'm getting this, I'm literally just copying this straight from this file. So everything that's here, you can just copy it as well. And if we go down, I think we have everything, right? We no longer have any errors, so we've got all of our imports. And so this is the function that returns our session local. So this is what allows us to query the database. This is our session object, right? And this is how it's set up exactly in the database.py file. So what I'm going to do is I'm going to create another function, but this time I'm going to call it override underscore get underscore DB. And this is going to return this session local instance. But I'm going to rename this just so I don't get it confused. And I'll call this testing session local. And then I'll reference this. All right. And so that means right now in our current application, we're referencing the one that we created in our database.py file, but the one in our test, we're going to actually make use of this new one right here if we call this override getDB. So how exactly do we override the database or any dependency, really? Well, FastAPI has a section on here, and I think if I search for dependency, testing dependencies with overrides. Right. To actually set up the override, you just do app.dependency override, and then you provide what you want to override it with. And there's actually a better example. If I go to testing database, this will actually show you how to do that. So we've got the override DB, where we've created a different session object. And to override it, we just do app.dependency overrides. We pass in, we specify the dependency we want to override, which is anything with getDB, and then we want to override it with override_getDB. So essentially, all that's really doing is in the functions, any of our routes, right? You can see we've got this depends getDB. So when we run that command right here, this override, all it's going to do is it's going to swap this out with the function that we have right here under test users called override getDB, which is just going to give a different session object. And this session object can point to another Postgres database. That's all we're doing. It's really that simple. That's why we set up that dependency when we first started configuring our database, so that we can easily test this during testing, because we can just use the override functionality that's used within a FastAPI. So I'm going to copy this. And right here, I'm going to paste it down here. And I realize I misspelled override, but we do have to import getDB now. So let's import that. So I'll say from app.database, import get_db. And so it's going to swap the dependencies out. And since we're still referencing the app object, we're going to pass that into test client. And so now anytime we use this client, it's going to use the new database. Now, currently our database is using the environment variables, which once again is going to point to our development database. So there's a couple of things we can do. Since this is testing, we 100% could just hard code our URL, because I mean, it's our testing database. Who cares if our password and our information is already out there? So we could technically do an F string. Actually, we don't even need an F string. I could just say PostgreSQL. Whoops, this should be a string. PostgreSQL : // then we have the username. Right now for my database, it's just Postgres. And then we have the password, which is password123. Remember, this would technically be for your testing database, so it's not technically a problem if you put this in there and hard code it. However, you'll see that we could just use the environment variables and make a small tweak, but I'm just going to quickly write this out for you guys if you wanted to see it. And then the host name is going to be localhost, port is going to be 5432, and then our database name. So we could call this, my development database is called FastAPI. I could call my testing database maybe FastAPI_test. So whatever my project name is and then _test, you can call it whatever you want. And so I could just hard code that and then comment this out, something like that. Or I could use this same thing, but just do a _test here. And so that way I don't have to hard code anything. It's going to actually pull it from the environment variables. So whichever method works for you, ultimately, that's all that matters. Now, I technically already have a FastAPI test database. So I'm going to actually delete this for now. So we'll say delete drop. All right. So I'm now in however your Postgres instance is set up. But since we're going to be using a database called FastAPI_test, we actually have to create one. So I'll say create database, and I'll say FastAPI_test. Okay, so we've got our test database created. And we've set up the override. Let's now actually test this out. So we're going to do one last thing. And I realize since we have a brand new database, there's no tables, right? If I go down to schemas, tables, right? There's nothing there. So we actually have to build out our tables before we actually do anything. So easiest way to do that is just copy Where's my main file? Here we go. This command right here. So this will tell SQL Alchemy to build all the tables based off of the models. We could use Alembic as well. So I'll show you guys how we can kind of get Alembic set up in our testing database so that it actually performs the migrations before test. But for now, we're going to keep things simple and we're going to use this. And so I'll just paste it right there. And we can remove this models. I don't know why that's there. And you can see that we get a warning right here. So we don't have anything based. So we actually have to import that from our database file. So I'll say from app.database, import base. And I realize we actually don't need this line right here. So we'll remove that. All right. So now our test database is completely set up. And when we actually run our first test, it's going to run this right here, which should create all of our tables for us. So let's take a look at our test create user. Everything should be good. We shouldn't have to touch anything. And our URL should point to fastapi_test. So let's try this out. And I'm just going to refresh this. And yep, we shouldn't have any tables. Good, perfect. And let's run this now. So let's run just the test users. All right, and both of them passed. So how can we verify both of them passed? Well, let's go to our tables. I'm going to refresh this. We can now see we've got all three tables, right? And that's because we ran this specific, well, not that command, this command right here. And if I do a users and then where is it? View edit all data, all rows, right? We can see that our user was successfully created. So we have now gotten our test database set up so that we no longer interfere with our development database. And keep in mind, right, your test database doesn't even have to run on your local machine. You can run it anywhere. You can run it in a Docker container. You can run it on a remote machine. You pass in the details of your test database, and then your testing environment will handle the rest. So now that we've got our test database and we've successfully ran our tests, if we run our test one more time, take a look at what happens. We get an error, right? And we get an error because we saw this before in our development database. We already have a user, so we get this duplicate key violates unique constraint because this user already exists. So when we run this again, we try to create a new user with the same exact email. And this obviously causes things to break. And so how do we get around this limitation, right? I want to be able to run my tests as many times as possible, and I want it to kind of start out with a clean slate. Well, we can make use of fixtures. So let's take a look at our fixture. And if you already forgot what a fixture was, it's just a function that runs before your test runs. I'm going to create a fixture, and I'm going to have to, do we already import Pytest? We did not import Pytest, so let me import that in here. We'll say import Pytest. And I'm going to say, I'm going to create my fixture. Call this whatever you want. I'm going to call this client. So this is actually going to return our client, right? This is our client object right here, which is the test client, which is what we use to actually generate the request. So I'm going to call this def client. And what this is going to do is I'm going to remove this line right here and just copy this. And I'm going to say return this. And we can just remove this line at that point. So this is going to return our test client instance. And so now, to get this to actually work, I'm going to pass in our client. And so now this client object references the client that we get from this fixture. And we'll do the same thing here. So what exactly has this solved? Right now, it hasn't really done anything for us, right? Our code is going to work exactly the same. If I save things and run it again, right, same exact issue. And obviously, I can go in and I can delete this. And then run this, right? It's going to work just fine. But it is nice because we now have this function that runs before each one of these tests that gives us our testing client. And what's even better is I can actually change this a little bit because I can change this to be a yield. Right? When you change it to yield, what it does is it gives us a little bit more flexibility because now we can, run our code before we return our test client. And after the yield, we can then run our code. Actually, this should be run our code before we run our test. And then this is going to run our code after our test finishes. So now we can put in logic for, what should we run before our code runs or before our test runs. We then yield, which is the same thing as return. It's going to return our test client. And then we can run some code after the test finishes. So what we can do is, before our code runs, I can copy this line right here. So before our code runs, I can create my tables. And then after my code runs, I can drop my tables. And if you want to drop a table, you just run base.metadata.dropAll instead of createAll, and it's going to drop these tables. And so now every single time my tests run, I'm essentially going to be starting out with a clean slate. It's going to drop all of our tables, all the data in each table. It's going to return the test client. We're going to run the test. And then, I messed that up. So when we finish a test, we're going to drop all of our tables, delete our data. Then the next time the test runs, what's going to happen is we're going to create all the tables again because there's no tables. We're then going to run the test. And then just like we did before, we're going to then drop all of our tables again. So what I'm going to do is, first of all, I'm going to manually drop these. And I'm going to have to drop votes first, or then it's going to throw some foreign key errors. And then we'll drop posts and then users. Okay, so now everything should work. And I'm actually going to test this out. So once again, just to reiterate, we're going to create our tables because we don't have any. We're going to then run our test, right? Yield just returns our test client to our create user, and then we can, perform all of this logic. After that's done, we'll then drop the tables again, so we start from scratch the next time around. So let's try this out. All right, everything's worked. And if I actually go back to here and hit refresh tables, you can see there's no tables because we dropped the tables after we're done. And if I run this again, it works. We can run this as many times as we want. We don't have to worry about duplicate users because we're clearing out our database. And there's one more thing that you can do as well. If you wanted to, we could actually take this drop all and move it up here. So what's the benefit of doing like this, or why would you want to do it like this? Well, the nice part about this is, right, it's going to clear out anything we had previously. It's going to create our tables, and then it's going to run our test. And then the next test that we run, we're once again going to clear out our table. We're going to clear it out, and then we're going to build our new tables again. So this way, if your test fails, you can, pass in the -X flag to stop after it fails. And what's going to happen is it's going to keep all your tables and all of the data so you can see what was the current state of your database when the test failed, so that you can, ideally have a little bit of better idea of what's happening, troubleshoot a little bit more because you have access to your tables. Whereas if this is down here, right, it's just going to delete the tables after you're done and you can't even see it. So it's a matter of personal preference, but I like to keep the tables after it's done so that, if I do want to stop it and just kind of poke around and take a look, then I can. And if you guys don't want to use SQL Alchemy, you can do the same thing with Alembic, right? I can import, alembic.config. Actually, I think technically the import is from alembic.config import config. Sorry, not that. Nope. It's from alembic import command. So what we could theoretically do is in here, instead of using these, we could say something like, I think it's command.upgrade. So you can upgrade, and then you can go upgrade to, I think, head, right? So this will build out all the tables for you. And then after you're done, you could then go in and say command.downgrade to base or something, right? You'd have to make sure you set up Alembic with all of the right environment variables and things like that. But that's all you would have to do if you didn't want to use SQL Alchemy's built-in functionality. So I'm going to just delete that just to keep things simple. We're going to let SQL Alchemy build the tables for us moving forward, just because it's a little bit quicker than having to build all of your revisions and things like that. So one of the cool things with fixtures is that we can actually configure a fixture to be dependent on another fixture. So we can essentially pass one fixture into an argument of another fixture. And the reason why I want to do this is I want to have one fixture that returns my database object. So if I want to ever manipulate data directly, and I want another fixture that returns my client. So this one is returning our client, so I want that, but I also want another one that returns just our database object. So what I'm going to do is I'm actually going to create a new fixture. I'll say pytest.fixture. And we can call this whatever you want. You can call it, like DB or session. I'm just going to call it session. And I'm actually going to move the logic of deleting and creating our tables up to here, because this is kind of handling all of the logic for the database. And you see all of this override functionality. What I'm actually going to do is I'm going to just copy this section right here. And paste it into here. All right, so this session fixture is going to yield the database object. So the database object that we used to query things. And what I can do now is I can pass in session, this session fixture, into my client fixture. And so by doing it like this, what's going to happen is any time I go to one of my tests and I pass in the client fixture essentially as a dependency, it's going to call this one. And the client fixture will actually call the session fixture before it runs. So it's intelligent to understand that a requirement for the client fixture is the session fixture. So we're going to run all this code. It's going to return the DB object, which is going to be passed into client as the session. And then here we can perform all the logic that we normally would. And I'm going to once again copy this override DB right here. And we can remove this. And we can remove that. Nope, actually, sorry, I didn't mean to remove that. Just space these out a little bit. So it's part of the override getDB function. And here, instead of yielding DB, since there's no DB, we're going to yield session, which is the DB. So we'll say session. And then session.close. And I'm going to copy this line right here. Do the override right here, and then we return a brand new test client. Okay, and the benefit of this is that not only do we get access to the client, if we wanted to, we can also get access to the database as well. So I could say session, and then I can go in here and I can make queries like session.query, models.post blah, right? So now I have access to the database object as well, and so I can make queries and I have access to the client. But if I call just the client, remember, the session database is an input argument into the client fixture. So the session will always run first, and then client will run because we're calling it right here. And then we just move the override getDB function into here, as well as the override right here. And then as usual, we return the test client. So let's make sure we didn't break anything. Let's test out our code. And something's happening with my terminal, so let me open a new one. So let's try this again. I'm just going to do pytest test / and then test _ users. Nope, not test calculations, users. All right, and 2 passed, so perfect. Looks like we didn't break anything, and we've got a much nicer way of setting up our code. We can actually remove this override that's not within a fixture. We no longer need that, and we no longer need the create all right here outside of any of the fixtures, because we're doing it all within the fixtures now. And once again, I just want to make sure I didn't break anything, so let's test that out. And we can see 2 have passed. Perfect. All right, so right now our test users file is a little bit cluttered with all of this database information, and I would like to move all of our database specific code to another file. So under our test folder, I'm going to create a new file, and we can just call this database.py. And I'm going to essentially move all of my database code to that file. And that includes the fixtures as well. So these 2 fixtures, all of this, actually everything. We don't need any of this in our test users file. And we can just paste it into here. Now, this is going to break things because obviously it has no idea what schema. Okay, well, actually, before we do that, we do need to have schemas in here. So let me find where schemas is, and we'll just cut that out. But the other issue is that we no longer have access to the client fixture. So we have to import that. So I'll do from current directory, database, import. What is it, client? I think it's client. Yep. So now we have client. And remember, we don't need to import Actually, we may need to import session. Let's just double check to see if this causes any issues. So let me save everything. And let's test this out. Let's see if this works. Looks like we got 2 errors. Yep. And if you take a look at the errors, it says the session fixture is not found. So we actually have to import the session fixture from this file. Even though we don't actually call session in here, because client is dependent on session, because client is ultimately calling session, we need to make sure that session is also imported. So we have to do session here as well. And so now I think this should fix our issue. So now if we run this, yep, both tests have successfully passed. And if you actually take a look at our test file, you can see our test file is a lot cleaner. It's really just got our 2 tests and a couple of imports. And before we move on any further, there's one thing I want to point out, and I ran into this issue when I was, doing a dry run through my code. If you actually take a look at your routers, and we'll go to, since we're taking a look at test create user, this is going to be the /users. So if we go to users and then create user, right, you can see that the prefix is /users. So the route you want to go to is /users, and then you can see that we have to append whatever's here. So here it's appending /. Now, the way that Pytest works is that, or actually the way that anything works is that if you actually send a request to /users, it's a little bit different than /users/. And I'm actually going to show you what happens when we do that. So I'm going to, first of all, open up UVcorn. So I've started out my API. And if we go to create user, here I'm going to users and not users/. Right? I'm not doing /, I'm doing /user. I'm just doing users, which is, wait, where did it go? Is it here? Where did I put the things I just typed? Yeah, here. So what we're doing is we're sending a request to this one, not the one above it, because the other one above it has a / at the end. We don't have that trailing /. So if I create a test user without that trailing /, hit send, take a look at what happens in the logs. It says that when we get a request to /users, we're going to send a 307 redirect to /users/, because technically the route's on /users/, and Fast API is intelligent enough to actually send the redirect to here. However, this creates an issue with our testing, because if I just do /, what's going to happen is when I do this res.status code check, it's going to check for 307 and not the final 207, the final 201. And I could show that to you guys. So let me go down here. We'll run our test real quick. And you'll see that it fails. And it fails because, well, there's a couple of issues. It fails. It says it fails because our validation for our schema failed. But I'm going to skip that and comment that out. And I'll comment this line out. I just want to take a look at the status code. Because obviously if there's a redirect, there's no information in there. Right? And you can see that this fails because the response code is 307. So that's why you want to make sure you add that trailing / or then you'll run into some issues. So we've got our create user test pretty much done. You can feel free to customize it however you want. If you want to add a few extra assert statements, feel free to do that. But we're going to move on to login. So let's actually handle setting up the login. So I'm going to do def test underscore login underscore user. All right. And this test is going to be dependent on the client fixture because we need to be able to send a request. So I'm going to pass in client. And I'm actually going to copy this line right here. We'll change it, of course, but all right. And so we're going to, this is going to go to /login. And there's no trailing / on this one, just because if you actually look at our specific route for login, I think it's under auth.py. You can see there's no prefix here. It's just /login. So we don't need the trailing / on this one. You just have to figure out how you set yours up and make sure it matches accordingly. We do /login. But in this case, we don't want to send this data in the body. Instead, remember, if you go to Postman and you go to login user, we don't send it in the, well, we do send it in the body, but instead of using the normal JSON format, we have to send it as form data, remember? And so to change this to be form data, you just change JSON to be data. And we've got the same credentials, so this should work. Let's just quickly just do a assert. And what is a login return? A login returns it should just be a 200. So we'll do a 200. Assert res.status code equals 200. All right, and let's test this out now. And it looks like we got an error. So what happened here? Let's take a look. It looks like we got a 422 as our status code. Why would we get a 422? And if we take a look at our logs, we don't really get much information here. So what I'm going to do is we're just going to print res.json so we can see what's going on. All right, why did we get a 422? Is there any other details it's going to provide us? So I'll do a -s so it prints it out. And we can see in the print statement, it says, oh, look at this. There's some sort of validation issue. Detail, lock, body, username, message, field required, type, value, error missing. So remember, the field for the email when you log in is not actually called email. It's called username. So we have to fix that. So it's going to be username. All right. Now let's test this out once more. All right. We get another failure. So let's see. This time we get a 403. Okay, interesting. So what's happening? Why did we get a 403? Let's see. Detail says invalid credentials. Interesting. So if I go back to my login route, right, you could see that we get a 403 if the user doesn't exist, which means we couldn't find a user with that specific email, or if the password that was provided doesn't match what's in the database. So this is one of the issues. It's either the user doesn't exist, or the email doesn't exist, or the password's incorrect. So let's go into pgadmin, and if you left your database config so that you don't drop it at the end, instead you drop it before a test case starts, you should be able to see all of your test data. So I'm going to refresh this. And if I go to users, view, edit data, all rows, right? Well, there's no users. Well, that's interesting, right? Because if I go to my code, during our test create user, we should have created a brand new user. So why can't we log in as this user? Well, that's easy to explain. So if I actually go to my database.py, we have these fixtures. And the fixtures have a specific scope, which means when do they run? And right now, they're using the default function scope. What that means is they're going to run before every single function that's dependent on them. So that means when we run test users, right, we can see that test root client, right? Since we're passing client into test root, we're going to run our fixtures before we run this function. Then before the next test, we're going to run our fixture again. And then before this test, we're going to run our fixture again as well. So why does that actually cause the user to get deleted? Pretty simple. Because we run this test, right? The test create user. The user's in the database. Then we start to run the test login user. And so since we're dependent on the client fixture, we go to the database.py file. We can see that the client calls session. Session, what does session do? Well, it drops the database. Or it drops all the tables at least. And then it creates all of the new tables. So we get a brand new database every single test that we run. That's why the user isn't there. And if you want to learn more about scopes, I recommend you go here. And then I think, if I go to API reference, and then fixtures, let's go to examples. And go to fixtures right here. And then here I can search for scope. here we can see the different scopes. So the default right now is that our scope is functions, which means that the fixture is destroyed at the end of each test and it's run for every single function. We then have a fixture that's set to a scope of class, which means that it'll run once per class and it'll run all the tests in the class. Then we have a fixture module. So when a fixture is set to a module, that means for all of the tests in a specific module, right? Like in this case, all of the tests here, we're going to run the fixture just once at the beginning, and then we're not going to run it again for that module. So all of the tests will have access to just that first instance run, essentially. And then we also have it for package, where it's going to run once per package. And then we also have session, where it's going to run once at the start of the testing session, and it's going to get destroyed. And you can see how we can set the scope right here. You just do scope equals, and then whichever one you want. So if we go back to here, and we see this fixture, right, we could say, since the default is function, it's the equivalent of doing scope equals function. And the same thing goes for the session, the database one as well. So these are going to run and get destroyed every single function. So at the end of the function, we're going to delete this test client, and then we're going to create a brand new one for the next one, which causes our database to get wiped and destroyed. So if we want our login user to be able to access what was created here, we could theoretically change the scope to be module instead. And I could change this for both. And so now what happens is at the start of this module, when we start running the tests here, we're going to run the fixture, right? Because the test root is calling it. So we'll run the fixture at the beginning, and we're going to just do it once, right? So then we'll call this one, which doesn't really do anything. We'll then create the user. But since we don't ever run the fixture again, we never end up running this session either. So we don't end up dropping our database or our tables. So we'll actually keep that same fixture, and then we'll run through all of our tests, and only at the end will we destroy that fixture. So we have essentially access to all of to our database for the entire module in this case. And so now if I actually run this, right, you can see all of our tests pass because the fixture will last the entirety of the module. I could even use package or session. Both of them would have worked. But this creates a little bit of an issue because this means that this test is dependent on this test completing. So if this test fails, then obviously this test is going to fail. And it actually creates issues because if I move this to the top, right, and I accidentally move my login user to before test create user, then this is going to break our tests once again because we need to create the user before we log in the user. And so in general, what we've done is bad practice. You don't want to make tests be dependent on other tests. Each and every single test needs to operate and run independently. They should not be reliant on other tests. If they are, it is not a valid test and you're doing it wrong. You want to make sure that all tests can run independently of one another. So what we've done so far with this little hack of changing the scope to be module is not a good solution. So in the next video, we'll take a look at what we can do to kind of overcome this limitation, this issue, so that we can make our login test case independent of our create user test case. Okay, guys, I wanted to make sure that we really did understand what scopes are when it comes to fixtures, because I feel like I didn't do that good of a job explaining it. So hopefully this video will help explain it a little bit more. And all I'm going to do is under our session fixture, I'm going to just do a little print statement right here that says my session fixture ran. And this is, I'm recording this video in the future, so I've got all of the other tests that we're going to cover done already, and I've kind of broken it out into test posts. So this is testing all of our post path operations. We've got one for users and one for votes. And I'm going to show you guys what happens when we use the default scope, which is it's scoped per function, right? This is the equivalent of doing scope equals function, which means that we're going to run this fixture for every single function that requests it. And so if I remove this, because once again, it's the default, and I run my tests, I want you to take a look at what happens. for every single test that we run, one dot represents the test, we can see it prints out. And so it's running through all the tests in test_posts, and then it's going to run all the tests in test_users and then votes. So you could see that because this is set to a function, we're going to run this entire session fixture, this function, every single test that we have, or at least every single test that's requesting this specific fixture. That's why we see it run every single time. Now, if we change the scope to module, the behavior is going to be a little bit different. Now, if I change the scope to module, what's going to happen is that for every module that has a test that's requesting this specific session fixture, we're only going to run this fixture one time per module. And so now if I save this, and I'm going to no longer do -v, I'm just going to do just -s, so we can see this get printed out without too much extra data, because we're going to see a lot of tests fail, and that's perfectly okay. I want you to notice what's happening. So notice how the print statement ran here, and then the print statement ran here. And I had to cancel out of that because usually I end up with a ton of errors and then I lose my data. But you could see that the first module, which is tests_py, we could see that my fixture ran because it's because I told it to run because one of the tests is requesting it. Right? It runs, then one of the tests runs, and then the next test runs, and then the next test runs. So you could see that this is not printing out per test. It's only printing out one time per module. So when test_post.py ran for the first time, and the first test required this specific fixture, it ran once. Then it didn't run for any of the other ones. That's why we see them all fail. And then the next module loads up, and we start running tests from there. So we run the fixture just one time. And then we don't run it ever again. So you can see 7 other, I think it's 6 or 7 other tests ran with no other modules, with the fixture not running any other time. And then we can see the same thing for votes. We can see that my fixture ran just one time. So this means that it's going to run only once per module. We also have session. So if I do session, it's going to be even more different. You're going to see it run only one time for my entire testing session. So you can see my fixture ran. It's going to keep going through, which is perfectly fine. And then when we get to the next module, we should see it not run at all, right? And so you can see it didn't print again. So it's going to go through all of the different modules. And I'm going to cancel out of that before I get too many errors, right? But now it only runs once per entire testing session. So that's when the scope comes into play. So keep in mind, depending on what you're trying to accomplish, you may need to tweak the scopes of your fixtures depending on what they're supposed to be doing. But for our database, we want to keep it set to a function, which is the default value, because we want to load up a brand new database by dropping our tables and then creating new ones every single time we run our test. So the default works perfectly fine for us. Now, to make our login user test independent of any other test, so it's not reliant on a specific order or setting the fixtures to be of a specific scope, what we want to do is before our login user test runs, I want to actually go in, define a function that'll get called, that'll actually create a brand new user so that we can actually test the login user out. And so, as soon as I said the words, I want to run a function before a test runs, the first thing that should click in your head is you want to run a fixture, or you want to create a new fixture. So we can actually create a fixture that'll create a test user for us. So up here at the top of this file, let's create a new fixture. And I'm actually going to delete this test. We don't actually need it anymore. It's just taking up space, or I can at least comment it out, I guess. And I'm going to define a fixture here. And we have to import Pytest. So we'll say import Pytest. And we'll say at pytest.fixture. And I'm going to call this test user. So it's going to be responsible for creating a test user. And this is actually going to make a call to our create user route. So we actually need access to client so that we can actually make that request. And there's 2 different ways of doing this, right? We could just have access to the session object, we can have access to the session object, and we can just, session dot, I think, what is it? Well, actually, no, it would be like models dot user, and then pass in the data for a test user, and then create it directly with the database. Or we could just make a call to our API and actually have it run through that. So I'm going to do that because it's a little bit simpler for now. But I'm going to define a dictionary with the data that I'm going to use for my user. So I'm going to have the email. And actually, it's going to be a little bit easier if I just paste this in. So we have the email set to something, and then the password set to something. And I'm going to change this back to client. And now I can say res equals client.post, and we'll send it to users. And then the data for the new user can just be user underscore data. And just kind of like what we've done here, we can, just to make sure that this didn't error out, we can do an assert and just say, res.status code equals 201. If that's good, I think it's safe to assume we didn't run into any errors on the back end. But then what I want to do is, not only do I want to create the test user, I want to actually return the information about the user so that this login user will have the correct data to send when he tries to log in. That way, if we ever change this data, we should automatically update this data. So what are we going to return? Well, we have access to, to res.json. And if I print that out, we can just quickly take a look at what that looks like. And for now, I'm just going to return nothing. I guess that's fine. I'll just return nothing. And here, I'm going to change this to be, I'm going to pass in the test user, so that also runs. And so now this login user is dependent on two different fixtures, client and test user. And before we do anything else, let's make sure we clean up the scope. We don't need these to be set to that anymore. And if we run our tests, all right, the data we get back, we get the username. Oh, sorry, that's not what I want. This print. We get the ID, the email, and the created at. So what we'll do is I'm going to actually take this dictionary and I'm going to pass in the password as well. Because when I actually go to log in the user, I need to make sure that he has access to what my password is. But that doesn't get returned in the response. So what we have to do is we'll have to add a new field. So I'll say new underscore user equals, res.json. So we get that dictionary. And then we'll say new underscore user. We'll add in a new key called password. And I'll pass in user underscore data, which is this dictionary up here. And we'll grab the password from here. And what I'm going to do is then return new underscore user. And so anytime someone calls test user, or anytime we have a test that's dependent on that, it's going to run this function. It's going to return the new user. And so now that we have the new user, what we can do is I can say the username is test underscore user. And then we'll grab the email key. And then the password will be test underscore user. And this will be password. Okay, and so that way, if I ever change the password up here, it's going to automatically get updated down here. So we don't ever have to worry about that. And one thing to note is that technically, if I deleted this and just called test user, right? Test user would technically call client, right? And that would go all the way back here. And then client would technically call session. So it would call all of these functions automatically for us. However, the one issue is that in this test, we still need to make a call with client. So we still have to pass in the client object so that we can make use of it. But I did want to highlight that because this fixture is dependent on client, it will run whatever code is in the client fixture. And because client is dependent on session, it will run whatever code is there within the session. So it's all done automatically for us, right? So the order, once again, is going to be, we'll run session first, we'll then run client, and then we'll run this test user. So let's test this out now. Hopefully this works. And it passed. Perfect. Look at that, guys. We were now successfully able to log in a user. So that's cool and all, but I want to do a little bit more validation for the login user route, just to make sure that, we got a token, the token is valid, and just do a few extra checks. So just like we did with the test create user, we can make use of the Pydantic model that we use for the response. So if I go into my auth.py under routers, and we can see for the login, the response model is set to a schema token. So let's import token inside our test users.py. So here, schemas, we already have access to schemas. And so I can say token, or what should I call this? I'll just call this login res, which equals, and then we'll call in schemas dot, I think it was a token. Was it token or token data? I think it was token. Well, let's just double check. It's token. Perfect. Okay, so token, and then what we're going to do is we're going to spread res.json. All right, so that's going to perform a little bit of validation. All right, and then when we get a token, I want to actually validate it. So how exactly do we validate it? Well, we want to decode the token. And so all of the logic that I'm going to implement here is essentially the logic that we use within our OAuth2py file. So when we want to get the user, we want to verify the access token is valid. So how do we do that? All of the logic is right here. So we're going to decode the token, and we're going to make sure that the user ID is within that token. And that's all I'm really going to do at that point. So I will copy this. And we have to import JWT from, I don't know if it's Jose or Josie, who knows. So we'll import JWT. And what we'll decode is going to be in the login underscore res under the access token property. And then we have to pass in the secret key as well as the algorithm. So the secret key can be accessed with settings dot. Well, I have to import my config. So I'll say from app.config import settings. So now we have access to our environment variable. So I'll do settings dot secret key. And then the same thing goes for the algorithm. So I'll set this to settings dot algorithm. So we're able to decode it. And then I'll remove this check. I'll just say ID equals payload.getUserID. All right, and so once we get the user ID from the token, what we can do now is I can just assert does ID equal, and then is it going to match the ID of test user? So if we take a look at what test user was, that's coming from this fixture. And so it's going to return, oh, it looks like I did not, no, it should be in there. So since we grabbed the response, the ID should be there. So we can just call this test underscore user, and then we can just call ID. So I think that's a little bit more of a valid check because it's actually decoding the token just to make sure we didn't break anything there. And one more thing, we can assert login underscore res dot token type. So this should be set to bearer. All right, so let's test that out now. And everything worked. I think I've got one random print statement that I don't want, so I'll just remove that. And we have now successfully completed our login user test. Okay, guys, so before we actually create any more new tests, what I want to do is I want to create a special file under our test directory called conftest.py. So this is a special file that Pytest uses, and it allows us to define fixtures in here, and any fixtures you define in this file will automatically be accessible to any of our tests within this package. So it's package specific. So anything within the test package, even sub packages, will automatically have access to any of these fixtures. And the reason I want to do this is I want to take all of our database code, essentially, or well, our database fixtures, and I want to copy all of it. And I want to move it to conf.test. And so by moving it to conf.test, this fixture, the session fixture, as well as the client fixture, will all be accessible to test calculations, test users, any other test files within the test folder automatically. And so now I don't actually have to import anything. So I don't need to import from conf.test. It'll automatically do that. It'll automatically have access to client, and it'll automatically have access to session. And what I'm actually going to do is I'm going to move this test user to conf.test as well. Right? And so that way, because I've imagined that even for other modules that I create, especially like for voting and creating posts, they're going to need test users as well. So it makes sense to put this in this conf.test so everyone has access to it, and I don't have to go around constantly importing things around like that. And now within our test users, I should be able to leave everything else, and you'll see that we're not importing client or test user anywhere here. But when I run this, we should see no issues. So let's give this a try. And you can see all of our tests passed with absolutely no issues because we are importing those from the conf.test file. And keep in mind, let's say I created a new package. I'll call this whatever. How about API or something? It doesn't really matter what I call it. And I've got a whole bunch of tests in here, test underscore something.py. Because this package is still within the test package, it'll have access to all of the fixtures in the conf.test py. But within a package, I can also create a new conf.test. So I can make a new conf.test.py down here as well. And when I do it within this package, then test users doesn't have access to that one, but anything within the API package will have access to the fixtures in the API folder as well. So conf.test is package specific. So every directory you create, you can create a separate conf.test file so that you can essentially scope fixtures, or you can make it so that fixtures are automatically imported into certain parts of your tests and not others. But we'll delete that because I don't actually need that. All right, so we've finished our successful login user test. The next thing we want to test is for a failed login. So I'll do the same thing. I'll call this about test incorrect login. And once again, a few things need to happen. We want the test user so that a test user gets created so we can try to log in with his credentials, or at least with the wrong credentials this time. And we do need access to client just because we're going to be making a request. And here I'll say res equals client.post. And we'll say login. And for the login data, we'll say data equals, and then we'll do a dictionary. Here, the username, we can use, in this case, test underscore user email. And then for the password, we could just give it any arbitrary password. It'll just say wrong password because we know that's the wrong password. And so when a user enters in their wrong credentials, we should get a 403. So we'll say assert res.statuscode equals 403. And in the response, it should tell us that we have invalid credentials. So I'll say assert response.json. So we'll convert it to JSON. We will get the detail property, and that should equal invalid credentials. Make sure you get the capitalization correct because it's going to do an exact comparison. And just to confirm if that's what the capitalization looks like, it should be invalid credentials. So just copy it directly from here. And this should be res, not response. Let's try this out. All right, and the incorrect login worked. Perfect. So that means we did get a receive. We did receive a 403, and we did receive the message invalid credentials. But not only do I want to test the wrong password, I also want to test wrong email as well. And I also want to test wrong email and wrong password and a few different things. So how do we do that? Well, we can use parameterize, right? So let's import Pytest, which we already have. And we'll define our decorator. So pytest.mark.parameterize. So what are the properties that we want to pass? We're going to give it the attempted email, the attempted password, and then we could also get the status code. And we could also, match on a specific detailed message if you have a different detailed message for wrong password, wrong email, but we don't. So I'm not going to include that. And then now we'll just give an array with all of our, why does it do that? And so here we'll define our tuples. And I'm going to copy and paste this part just because I don't want to have to make you guys sit through this, but I've got a couple of different test scenarios. So here I've got the email being wrong email at gmail.com with the correct password. We expect a 403. I've got the right email, wrong password. I've got the wrong email, wrong password. I've also got no email. So if you put none, this is essentially leaving it blank. So with this set to none, you'll see that our API actually will send a 422 because the schema validation fails because it expects a username or a password. And then we'll try sending it with the correct email, but no password at all. We should get a 422 in this case because Pydantic performed its validation and found that it was missing fields. So that's what I'm doing here. And then we're just going to update all of this. So the email, the email is no longer going to be test user. It's going to be, well, actually, first of all, we have to pass it into our function. So email, password, and status code. So we'll say email, password is going to be password, and status code is going to be status code. And we'll get rid of this check just because the invalid credentials won't apply when we get the 422. So let's try this out now. Yep, and we can see all of our tests have successfully passed. So we have now finally set up a test for making sure that when a user does not provide the proper credentials, we get the right response code and the right data back. And keep in mind, guys, right, in this case, I just set this up to be a very simple test just to check on the status code, but you could check any single field that you want. It's up to you. You can make your tests as specific as possible. You can make them a little bit more generic. It's up to you to decide on what you want to validate yourself. And like I said, I'm trying to keep this as basic as possible. Try to just make sure that we focus on how to actually create tests and less on the actual specific tests. If that's all of the things that I want to do for all of the user tests, let's move on to all of the post tests. So tests when it comes to creating, reading, updating, and deleting posts. So I'm going to store this in a separate module just to keep things nice and organized. However, you can keep everything in one file if you really wanted to, but no reason to do that. So I'll call this test_post.py. Now, when it comes to working with posts, we do have to deal with a little bit of an extra challenge. And that is, if you take a look at all of our posts path operations, they all require authentication. So how exactly do we deal with authentication when it comes to testing? Well, you're probably thinking, we could, define a post, define a test, and we can call this, get all posts or something, right? And then here we can pass in client, and then maybe test user. So we have access to that. And then we would just do, client dot post login. So we log in, we get a token, and then after we get the token, then we can make a request to posts. And that is technically valid, but what I would like to do is I'd rather set up a fixture that automatically does this for us. But instead of actually making a request to our API, I want to just import the method, the OAuth2 method for creating an access token. So we could just import this into our test so that we can actually fake our own token or create our own token without having to use the entire API and go all the way through back into this same exact method to get a token, because that seems like a waste. And we're testing a whole bunch of other things that we don't want to test in this specific test. So what we're going to do is we're going to go to conf test, and I'm going to create a new fixture. I'm going to grab this, and I'm going to call this token. So we'll say token, and this is going to be dependent on test user. So we need a user to get created first before we run this fixture. And what we're going to do is we're going to import this specific function right here, create access token from OAuth2. And so I'll go from app.oauth2 import create access token. And just to quickly recap on how that function works, we pass in a dictionary, but I don't actually know what is in the dictionary. So let's go to, where is this? Who calls this? I think it's, no, it should be under users. Yeah. So create user. No, it should be under login. So under login, this is where we create the token. So we pass in data, which is just a property called user ID, and then we pass in the ID. That's all. Pretty straightforward. So we can do that. So I'll call create access token. And it's going to be a dictionary, and we call this, what is it, user underscore ID. And we're going to pass in, and we can get the ID of the user from test underscore user, which is being passed in, and we'll grab the ID property. And we'll just return this. So this is going to return a token, and that's why we call this function token. Then what I'm going to do is I'm going to create another fixture. I know there's a lot of fixtures here, but you'll understand why I want to do this. So I'll do def. And here I'm going to call this authorized underscore client. The reason I'm calling that is if we take a look at our current client, this just gives us an unauthenticated client. This new fixture will give us a authenticated client. So anytime we want to deal with any path operations that require authentication, we can just call this client the authorized client instead of the regular client. So that's going to save us a lot of time. And this is going to require the regular client and token, because we need to get a token. All right, so we have access to the original client. And what we can do is we can update the headers because we need to pass the token inside the header. So we do client.headers. And then we have to pass in a dictionary. And what we want to do is we want to spread out all of the current headers. So we do client.headers. And then we want to add one more, which is going to be the authorization. And this is going to be an F string because we need to add the word bearer before it. And then we can pass in token. And then we'll return this client. So it's basically taking the original client and then just adding this specific header that we get from the token fixture. That's all. And so now when we go into get all posts, and I forgot to put the word test before it, instead of client, we want to import authorized client. We don't necessarily need test user at this point. It'll automatically get called because, this calls token, token calls test user. We only need to pass in test user if we want access to specific user data, but we're not using any of that information at the moment. So I'll do authorized client.get, and it's going to be /posts. We'll set the response equal to that. And we'll just do a print res.json just to see what that looks like. And I believe the status code should be a 200 because we're retrieving data. So I'll do res.statuscode equals 200. So let's just take a look and see what exactly is happening here. And now it's going to be test posts. And we get an error, so let's see what happened. Authorized client not found. So I think I forgot to save. Let's try this again. And I forgot to turn this into a fixture. So right now it's just a regular function. So let's make sure I add the fixture there so it's accessible to everyone. And now if I run this, okay, so one passed. Let's take a look at the data that we got back. So when I did a print of res.json to see the data, I got an empty array. And the reason we got an empty array is that there's no test data in our database. There's no test posts. So we're going to have to actually create some test posts before we run this test so that we can actually verify that we got what we expected to get. So just like we did with the login user where we created a test user before, we're going to have to do this with our posts. We need to create a whole bunch of posts and then verify that we are able to retrieve those posts. So we'll tackle that in the next video. So let's create a fixture that will create a few initial posts so that we can actually test retrieving all posts. And we can use that same fixture for performing a few other tests. So things like updating a post, right? We would need to have a post in our database to update a post. Same thing with deleting. Same thing with getting an individual post. So this fixture is definitely going to be very reusable across a lot of our tests. So let's figure out where we want to store our fixture. We could keep it in our test.posts, test_post file, because all of our posts, all of our test posts, our tests for post data, I guess, if you want to call it that, will require that fixture probably. However, there are going to be other tests in our application that will need posts initially. So when you want to vote, we need a post already in our database. So I'm actually going to put it in our conf test file so that everyone has access to it. Well, technically anyone can access any fixture if they import it, but having it in the conf test file makes it simpler because we don't have to import it. So I'm going to put it in here. And this fixture is going to be a little bit different just because we're actually going to create the posts in the database ourselves. So here I'm going to call this test_posts. And so what we need is a couple things. So first of all, we need a test user because if we don't have a user, we can't create posts because all posts need to be associated with the user. Since we're going to work with the database, we're going to pass in session also. All right, and let's define some post data. So I'm going to create an array of dictionaries. And I'm actually going to copy and paste some data just because I don't want you guys to sit and watch as usual. All right, so what we're doing here now is we're creating 3 posts. So in this post data, I have an array, in a list, and then a dictionary, and then here we're providing the title and the content and the owner ID. All right, so that's going to create a post, and we're grabbing the owner ID from the test user fixture, and we're just going to grab the ID from that. So we're setting the owner ID, and then I'm just going to create another post here and another post here. So the same user is essentially creating 3 posts. And so now, since we have access to session, we can actually just directly tap into our database and create that information for us, or those posts. So we can do, when it comes to SQL Alchemy, if you want to add multiple entries into a database, we have access to the add all method. So we can call session.add_all. And then here we have to pass in a list of user models. So this would be, schemas. Sorry, not schemas. We'd actually have to import models. So I'm going to import. Do I have models already in here? Doesn't look like it. So I'll import that as well. So we'll say from app import models. And I can say models.user. So we'll create a new user model, and then we have to pass in all of this data. So, right, we would need to be title equals, blah, and then content equals blah. And then we'd have to do another one. So I'd copy this, paste this in here, and so on. And then this would add it all at once. Now I can manually hard code this value into here just to kind of keep things simple. And I could do that. And actually I will show you how to do that just to in case, but I'll show you what I did when I was doing a dry run. So I'll copy the title. This is going to be set to first title. The second title is going to be here. Content. And second content. And then the owner ID is going to be the same for both, luckily. Well, all three, actually. And that's not in the right format. Oh, don't do that. It should be equals. And the same thing here. And if we wanted to, we can copy this last one and then put the third one in. This will be called third title, third content. All right, let's save this. The auto formatter did not do much to help me out here. It still looks pretty ugly, but that's okay. And so that's one way of doing this. So it'll add it all. And then all we have to do is just do a session.commit. And then to get all the data back, I can just do a session.query. And we'll just say models.post. Oh, this should be user, by the way, not, this should be post, not user, because we're creating a post and not a user. We'll say models.post. And we can just grab all of them. Now, if you wanted to be able to take this dictionary and convert it easily to this format, there's a couple things you have to do. But technically, you could just leave it like this and it'll work fine. But this is a little bit more of Python than anything else. If you didn't want to hard code it in like this, because at this point, we don't even need this dictionary. But if you wanted to take this dictionary and convert it into a list of user models, post models, what we can do is we can use the map function. And so the map function works like this. You call map, then you call some function that you define yourself, and then you call the posts underscore data list that we have up here. And so this function, what it's going to do is it's going to iterate through this list, and it's going to take each item in the list, which is a dictionary, and it's going to convert it into a models.post. So how exactly does that look? Well, first of all, let's rename this. And I'm just going to call this maybe create user model. And I'll define a function up here. And I don't know why I keep saying user. It's a post. We're creating posts, not users. Create post underscore model. And this is going to get passed in some object, but technically what's going to get passed into this function is each dictionary. So I'll call this post underscore data. Well, actually, don't call it post data. I'll just call this post. And so we have to put the logic of converting a dictionary into a post model. And that's pretty easy. All we have to do is just say models.post. And then we take post and then we spread it. That's it. All right. So what's happening here is we're taking a dictionary, which is what it's going to get passed into here. And then we're taking it and spreading it so it looks like title equals blah, content equals blah. And then we can just return that. And then this map, we just set it equal to some variable. I'll call this maybe post map. And I'm forgetting an E. Okay, so that's going to return. So that's going to essentially convert all of those to user models, but it doesn't return a list. It returns a map, which isn't quite the same thing. So to convert it to a list, all we have to do is then say posts equals, and we just say list, and then post underscore map. So that'll convert it to a list. And then under session.addAll, instead of hard coding those values, I could just say session.add underscore all, and I just pass in posts. And we can just comment out this line right here. Either one works. Choose whichever one you like. I don't really care. But this is all we need to do. We just have to return this. So I'll save this as posts. And we'll return posts. And that should create 3 posts in our database. And so now if I go to test posts and make this reliant on, what did I call it? Get test posts. If I then run this, right, you can see that we did in fact get multiple test posts. And it's up to you to decide what checks you want to perform. If we go to our post route and we take a look at the schemas, you can see that it's going to be of type list of schemas.postout. List comes from the typing library. So let's see if we can actually do this. I never actually tried this with this, but I think it should work. So I will import that. And then we'll also import from app, import schemas. And I'll just say posts equals res.json. And I'll say actually schemas dot, what is it? Post out. Yep, it's going to be post out. I don't think that'll work because, this is expecting one individual post, but this is going to be a list of posts. So I wonder if I can do, we'd have to do this manually. Like we'd have to iterate through it and then basically copy it out. And I think that would just take too much work. So we'll leave this section out. If you guys want to take that as a challenge, you can essentially create a post Pydantic model for each entry within the response and then try to validate each single one. So instead, I'm just going to do a simple check. I'm just going to say assert, and we'll just grab the length of response.json. And I'm going to set this equal to length of test_posts, just to make sure that we get 3 exact posts. And if we ever change the number of posts that we have, this should automatically get updated. I think that's a good enough check for this test. So let's try this again. And we shouldn't get any errors. And it looks like it passed just fine. All right, guys. So I figured, you know what? Let me go ahead and just show you how we can actually do the validation using our schemas. We're going to use the same exact logic that we use here when it comes to performing the map, because we're essentially going to take a list of dictionaries and convert it to a list of schema models. So we're going to go back to our test. And what we're going to do is we're going to first define a function that's called, we can call it validate. And this is going to receive a post. And that's going to be a post, that's going to be a dictionary that we get back. And all we're going to do is we're going to return schemas.postout. And here we're going to pass in the data. We're just going to unpack it with post. So that's all we have to do. And then we can call the map function like we did before. And I'll store this in a variable called posts_map, which equals map. We're going to call the validate function, and we're going to pass in res.json. And so we have a map. If you wanted to, you could technically convert it to a list by calling list post.map, but we're not doing anything with that data. However, just to show you, we can just print this out real quick. And so now if I run this, and if we take a look at the print statement, you can see we've got a post out model, and it does all the validation. So it's going to make sure all of the properties are set and are there. And because we have it set as a post out Pydantic model, you'll see that it's very easy to perform extra checks with the cert statement. So now I can do other checks like maybe I want to say, actually, let me first save this as a variable. I'll say posts list equals list of posts map. Ooh, and that's supposed to be post map. So we have access to this list. And now what I can do is I can just say assert. And here we can grab posts underscore list, grab the first post. And we can check certain fields. I could say like, hey, does the ID, it's going to be the post.id. Does that equal test underscore posts? We'll grab the first object and then grab the ID. Well, actually, it's going to be, I think I could do just .id. Yeah, because test post, keep in mind, when we do test post, this is going to return, not a Pydantic model or a dictionary, but this is going to return a SQL Alchemy model. So a little bit different, but we just call it .id, and I think this should work. So let's test this out. It did not work. What happened here? Yep, so I accidentally grabbed, I see, yeah. So this is expected just because I don't know the order that we're going to retrieve the posts in. I didn't provide a order by filter criteria when it comes to my my get post functionality. So it could be returning any post. So right now it's saying that, hey, this ID happens to be 2. This one happens to be 1. So the order doesn't matter. So this isn't exactly the best way to do it. But if you want to figure out a way to set up the order so that you always receive maybe the post with the lowest ID and then you compare the two, that would be perfectly fine. And then you can check other properties like what's the title? Does it match up with what we should expect it to be? Does the content match up with the content? You can put as many asserts as you can. But by doing this, we are able to perform a validation to ensure that at least we get what we expect. All the fields are there, and then it's just up to us to set up the necessary asserts to verify that the values are correct. But I'll remove that, and I think it's okay just to keep it like this for now. All right, so we set up a test for getting all posts, and what I want to do now is I want to test to make sure that a unauthenticated user is not able to retrieve all the posts. So I'll create a new test, and I'll call this test, how about unauthorized user underscore get underscore all underscore posts. And instead of using authorized client, because we want to test if a unauthenticated user tries to access it, they get a 401, we'll just use the regular client, which is going to be a non-logged in user. And we want to make sure that test posts are here as well. And remember, because we're calling test posts, that's going to ensure that because test post is reliant on test user, it will in fact create a test user as well. So just to give you a heads up, we don't actually have to pass in test user into here because this should handle that automatically. And here I'll just say res equals client.get, and we'll just go to posts again. And I'm just going to assert a simple 401. So res.statuscode equals 401. That's really the only check I want to do. If they're unauthorized or unauthorized, there's no other things to check really. And we can see that it did successfully pass. Okay, so we've tested the get all posts. We're going to now move on to getting an individual post by an ID. But before we do that, I think it's best to actually test getting an individual post by ID when you're an unauthenticated user, because we can essentially just copy this code. And I can just paste it here. Instead of doing a user get all post, this will be user underscore get one post. And so everything else can be the same. We just have to change the specific URL. And so in this case, we're just going to grab the ID of one of the posts. So here, I'm going to change this to an F string. And I'm going to say test underscore posts. We'll grab the first one. And then remember, this is a SQL Alchemy model. And so we actually have to convert it to a dictionary. So we have to do dot underscore underscore dict underscore underscore. Sorry, the test post is not a SQL. Is it a SQL? I think I could do ID. I think that should work, actually. Never mind. I think we should be able to do that. That should be fine. And this should be a 401. So let's test this out. Let's make sure that this works. And that works. And what I also want to do is I want to test for a post, to retrieve a post with an ID that doesn't exist, I guess. So I'll call this a def test. get one post. How about not exist? So this one, we're going to need an authorized client. And then test_posts as well. And I'm going to copy this, but we're going to change this, and I'm going to hard code some random number like 88888. And then we'll just assert res.status _code equals 404. All right, so now we're going to try to retrieve a post that doesn't exist, and it looks like it passed perfect. So now let's actually try to retrieve a valid post. This one's going to be a little bit more work, so we'll say def test get one post. And we're going to copy these two. And I'm going to copy this one right here. So we're going to retrieve the first post from test posts with an ID of 0, I think. And I'm just going to rename this to authorized client. And let's just do a print. Let's see what this looks like. So we'll say res.json. All right, and that's going to run. And it printed out the post, so we can see what that looks like. And just like we did before, we can also do a validation. So I can say post equals schemas dot, what is it? I think it's post out. Yeah, post out. And we're going to pass in res.json. And do we need to unpack it? I think we have to unpack it. Let me print out post just to see what that looks like. Actually, I could just take a look at what we did up here. Yeah, we have to unpack it. Or spread it, whatever it's called. Yep, so now we've got our post model. Well, it's our Pydantic model. And so that does some level of validation. And then at this point, what we can do is I can say assert, and I could say does post dot, and then take a look at the format. We have to grab the post property. Actually, it's this first one. Yeah. So we'll grab post.post.id equals. Then we're going to compare it to the ID from test_posts. So it's a test_posts 0.id. And I think that should still work. All right, that works. And we can check a few other things. So we can say post.post.content. And if you're wondering why it's post.post, remember, if you actually take a look at our schemas, our post out, you can see that we have to grab the information about the post, we have to go into the post property. And then from in there, we can then take a look at all of these fields. So that's why we have to do it like that. And we'll say test_posts 0. And then let's see if we can do content. I believe this will actually throw an error because this is a SQL Alchemy model. So it's going to, oh, that actually did work. I'm surprised. Okay. All right, that worked. So if you guys want to, you can also essentially copy this line and then check to see if the titles match. You can essentially check every property if you really want to. So we'll just run that one last time. Perfect. And I'm just going to remove this print statement. And so those are all of the tests that I want to do when it comes to retrieving an individual post. I think I'm sure there's a couple of tests you guys might be able to think of, so feel free to implement that, but I think that's a good starting point on this. But in the next video, we'll take a look at creating a post. Okay, so let's move on to creating a post. I'll create a function. We'll call this test create post. And we're going to need an authorized client. We're going to need a test user for sure. And lastly, this is purely optional. If you want to, we could also set up all of our test posts if you wanted some posts in the database before you created one, just to potentially see if you run into any issues when it comes to creating posts when there's already posts. But it's optional. And we're going to set the res, and we'll set this to authorized client.post. And the URL is going to be /posts. And then let's give all of the data for our new post. So we'll say JSON equals title. And you know what? Instead of doing this, let's go ahead and set up a Pytest. What was it called? I already forgot what did we call it? A parameterize. So mark parameterize so that we can test multiple different values. Mark dot. Why is that not working? Okay, I have to import Pytest. And we don't need this line right here. So we'll say import Pytest. And so what are the values that we need? How about title? We need title for sure. We need content. And then we can also give a published value if we wanted to. And then let's give all of our, come on, VS Code, don't do that. All right. First tuple, what do we want the title? How about awesome new title? Ooh, awesome new title. What's the content? Awesome new content. And what do we want published to be? How about true? And we're going to copy this, and I'm just going to put in some new values. Favorite pizza. And we'll say, I love pepperoni. Ooh. Published. Let's say that's still a work in progress. Tallest skyscrapers. All right, so we've got some test data. Let's pass those values in. So title is going to be set to title. Content is going to be set to content. And then finally, published will be set to published. All right, we get a response back. Let's do a little bit of validation with our Pydantic model. So I can say schemas.post. And we'll just take the response, convert it to JSON, of course, and set that to created_post. And then we can just run a couple of checks. So let's assert the status code. So for creating a new post, it should be a 201. And then for, we could just assert a few extra values. So I could say like res dot, actually I can grab created_post dot title should equal title. And I can just do that. Whoops. I need 2 equals. And then I can just copy this a few times. We'll change this to content. Content. And then published. And while we're at it, we could also verify that the owner ID gets set. So I can say created _post dot owner _ ID equals. And then we can grab test user ID. So I think that's a good number of things to check. So at this point, I think it's safe to say that all of these should work. All right. And all of those passed. Awesome. So we've got the create post done. There's one other thing that I want to test with create post because if you go back to our, what is it? Our schemas. Where's our schema? I don't know if we have a create post create. So that's just going to be from post base. We can see published is set to a default value of true. So let's test to see if the default value of true gets set. And we theoretically could have put this test in here just by doing a none here, but I like to separate this out into a different test because we are testing a different functionality in this case. So we'll say test create post default published true. I'll do authorized underscore client and test user. Once again, we don't need test post, but if you want to have it in the database just to make sure that everything's not broken when you already have posts already in there, we can keep that in. And I'm just going to copy this. Actually, I could essentially copy all of this. And we could just give it arbitrary titles. And then published, we'll leave out published. We don't want that anymore. And I'll just copy these values here. And published should be set to true by default. So even though we're not passing it, it should get set. And everything else should still be just fine. So let's test that out. Oh, it looks like it failed. So what happened here? Oh, I just pasted in the wrong values. All right. And then one last thing, just like we did for all the other routes within the post, we also want to test if we're not logged in. So I'm going to copy this one and just rename it. So test unauthorized user create post. We don't need to have test user in there, but why not? And I'm going to just copy this right here. And then just change this to a plain client. All right. And this should work. All right. And that passed as well. So we have got all of the create post tests done. I think in the next video, we will tackle either deleting or updating a post. Okay, so let's move on to deleting posts. And the first thing that we're going to do is we're going to test a unauthorized user trying to delete a post. So we'll say test unauthorized, delete post. And we'll have client test underscore user. And we'll definitely need test post in this case. And then we can essentially copy, well, I'll copy this one right up here. And we'll change this to, we don't need the body anymore. And the route is going to be, we're going to pass test underscore posts 0.id. All right, let's test that out. Yep, and I realized this should be a delete actually, not a post. That's why I got some other status code. Perfect. All right, so we got that one to pass. And so now let's test a valid deletion. So I'll say test delete post. And ideally, I guess we should be calling it like success, like we successfully deleted it. And this time we'll get the authorized underscore client. We'll get the test user and the test underscore posts. All right, we'll call this same request here. And just change this to authorized client. And this should give us a 204. I mean, you theoretically could also, then fetch all posts again just to verify that the total number of posts is one less, but we're not going to do that in this case. You could, however, do that. And that failed. So what happened here? A 422. And two things. So I don't even know how this one ran with the same issue. We need to make that an F string. So I genuinely don't know why that actually worked. Little alarming, but let's test both of those out. All right, all of them passed. So we've got that done. Let's test deleting a non-existent post, so an ID that doesn't exist in our database. I'll say test delete post non-exist. And I'll just copy these. And I'll copy this. Actually, I'll just copy all of this. And I'll just change this to be some ridiculously high number. And this should be a 404. All right, that one looks good. All right, so the next one's going to be a little bit trickier. We're going to create a test where a user tries to delete a post that isn't theirs. So they try to delete a post that's owned by someone else. So we'll say test delete other user post. Now, there's a couple of issues here. So first of all, we need to actually have more than one user in the database, and we need to have posts owned by multiple users now. So this creates a couple of challenges. So how exactly are we going to set up more than one user? Well, I think it's best to use fixtures like we always have. And ideally, I would have set up a test user. Where is it? My test user. I would have set up a test user to actually create multiple users in our database, but I didn't. So I just have one. If we had set it up so that multiple users are in the database, then this test would be a little bit easier. Since I didn't, what I'm going to do is I'm essentially going to copy this. I'm going to copy this. And right above it, I'm going to create just a second one. I know it's not very original. Probably not the most efficient way of doing things. And it's going to be dependent on client. And we're just going to put a 1 or something. It doesn't really matter. Just so that we have another user. I'll make this 1, 2, 3. And so now we have 2 users, which is perfect. And down here in my posts data, what I'm actually going to do is I'm going to create one extra post. And we could just copy this data right here. And here, I'm actually going to pass in an extra fixture, which is going to be test underscore user 2. So before test post gets created, we're going to create the second user. And here I could just grab the ID of test user 2. And actually, I don't even need to do that. I don't know why I did that. We don't even need to create a post owned by that user. We'll leave it like this for now. Nope, I was right. Actually, we do. I don't know why I'm flip-flopping like this. So the fourth post, 1, 2, 3, 4, is going to be owned by test user 2. And so now if I go back to test posts, here we're going to be logged in. Remember, authorized client is always going to be logged in as user 1. So we're going to try to delete that fourth post. And so we can do that by grabbing the ID of the fourth post. So we'll say test underscore, need curly braces. test underscore posts. We'll grab the fourth one, which is an index of 3. And then we'll grab ID. And this should, I forget what kind of error it should get or what status code. I think it's 403. So we'll do assert res.status underscore code equals 403. And it looks like that successfully passed. And so that one's good. And that pretty much wraps up all of the delete tests that I want. And then in the next video, we'll take a look at updating posts. All right, so let's update a post. I'll say def test underscore update post. Here, we need an authorized client. And we'll need a test user. And we'll need test underscore posts. All right, and I'm going to define a dictionary with the values that I want to update. And so here I've got the title, the content, and then the ID, which I'm grabbing from test posts. And I'm just going to use the first test post in there. And I'll say res equals authorized client dot, I think it's put. And then we're going to do an F string. And we'll say slash posts. And this one will be test underscore posts 0.id. And then we have to pass in the data. So we'll do JSON equals data. So we're passing in this dictionary. Right. And just like we do with the other routes, if we go to the update post, technically we're sending it out with the schema of posts, so we can just quickly validate it on our end on the test as well. So I can say updated post equals schemas.post, and we'll pass in res.json. And then we can assert a couple things. So we'll say res.statuscode is going to equal, what's an update? I guess we use 200 in that case. And then we can assert a few things. So we want to make sure that the new title, we can do updated underscore post dot title equals data dot updated. Data dot, this is a dictionary, so title. And we can do the same thing for the content. And I think that should be everything that we need. And just to, just to make sure that my tests don't take too long, I'm going to start commenting out all of my other code, all of my other tests in this file, just to make things a little bit quicker. But you can see how it starts to slow down just with just a couple of tests, really. So we can see that it did successfully pass, so that's good. We've got the first update post test. The next thing I want to do is I want to try to update another user's post. So we'll say update other user post. So this, we need authorized client. We need test user. And we need test user 2. And test underscore posts. So we're going to try to update that last post. And so I'm going to define a dictionary with the values I want to update it with. So same thing, title, content. The only difference is the ID is going to be, I think it's actually 3. So the ID is going to be of the fourth item in that list. And I just want to make sure it's the fourth one. So 1, 2, 3, 4. So yeah, we need a value of 3. And I'm going to copy this. And just change this to 3. And we should get a status code of 403. And let's test that out. Perfect. And the last thing we need to do is a unauthenticated user trying to update a post. Actually, there's 2 more tests. So let me grab unauthorized user, this one right here. And this is going to be a put. And that should return a 401. And the last thing that we need is, and actually I need to update this name. So unauthorized test update post. We can also set up a test to update a post that doesn't exist. And I believe we can just copy the deleting the post that doesn't exist. Delete post non-exist. So I could just copy this one. And change this to a put. And we'll change the name to be update. And let's test this out. Hopefully everything works. Oh, one failed. What happened here? Okay, so it tries to validate it because I didn't provide any data. So I can just copy this data right here just so we can give it something. And so we can say JSON equals data. That's going to prevent us from getting validation errors. And that passed. Perfect. So let's take all that. And I'm just going to uncomment everything else so we can get all of our tests back. And that's going to wrap up updating posts. And that's actually going to wrap up all of my post cases. And so I guess the last thing that we got to do is set up all of the voting tests. And there's only going to be a couple of voting tests, but it should be fairly quick. All right, so let's move on to setting up our tests for voting. I'm going to create a new file. We'll call this test_votes.py. And let's define our first function. So I'll call this test vote on post. So this is going to be a successful vote on a post. What do we need? We need an authorized client, of course. And we need to make sure that there's some posts already in our database. All right, and now I can do a authorized client post. And here, this is going to be to the vote endpoint. And let's just give it some data. So here, we're going to pass the post ID. So this will be post_ID. And we'll grab the first item in our list, testpost.id. And I forgot my curly braces. That's why it's giving me an error right now. And we'll say, what is the direction. So we're going to be voting. So this is going to be dir set to 1. All right. And now technically, if you look at what's happening, right, we're logged in as user 1. And test posts, and if we go back to that fixture, where is this guy? That's owned by user 1 as well. So technically, we're voting on our own post. But if you look at our code, we didn't actually put any checks to stop us from liking one of our own posts. So it's perfectly fine in our test to do that just because our code is right now allowing it. If you didn't want to do it, then first of all, we'd have to update this code to make sure that we perform a check to verify that, hey, are we voting on our own code? If so, voting on our own post, then we should reject it, but we don't have that implemented. So for our test, it's perfectly fine because that's how our application works. But obviously, if you wanted to make sure that you're testing someone else's post, then you could just obviously pick the last item, so the third item in the array, because that's owned by test user 2. You just would have to make sure that you pass in test user 2 in this case, just to make sure that he gets initialized. But that's a good assignment for you guys. I would see if you guys can implement logic to make sure that you can't vote on your own post, and then go ahead and create your very own test to make sure that if a user tries to vote on his own post, he gets an error of some kind. But for us, this is good enough. I'll leave it as 3 just so we're voting on someone else's post. I'm okay with that. And we can just assert res.statuscode equals 201. Don't really need to check anything else. And now I can just change this to test votes. Okay, so that one successfully passed. All right, the next thing I want to test on is what happens when a user tries to vote or like a post that he's already liked. So we'll call this a def test underscore vote underscore twice underscore post. And so we'll need an authorized client. We'll definitely need test posts. But there's one little issue with this one, right? We need to have a post that's already been voted on. And we don't have that right now. So how do we do that? Well, I mean, theoretically, we could initialize our test post fixture with some votes. But instead of doing that, I'm going to actually create a new fixture. And I'm going to keep it in this file because all this fixture will do is it will set up one of our posts to have a vote on it already. And I don't think really anybody else in any other test in our application is going to need that outside of the voting file because that's the only one that's concerned with voting. So let's test that out. So we'll import Pytest. And we'll set up our fixture. So Pytest.fixture. And I'll call this test vote maybe. And so for this fixture to work, we definitely need an authorized client. Actually, we don't need an authorized client. We'll need test posts. We'll need a session because we're going to just change it in the database directly. And then we'll need our test user. And so let's, we're going to have to import our models. So I'm going to say import, not import, it's from app, import models. And I'm going to say models.vote. So let's create a new vote. So we're going to have to pass in the post underscore ID, which is going to equal test underscore user. We'll grab the third one, .id. And then we need to pass in the user ID, which equals, it looks like we actually, we already have the test user. So I can say test underscore user ID. And then I can just do session.add new vote. And I need to create a variable or store this in a variable. So new vote. And then we can do session.commit. And so down here, I can pass in test underscore vote. And I'll say res equals authorized client dot post. And then JSON equals, what is the post ID? We'll grab this from test underscore posts. Grab the third. And we'll grab the ID. And then we'll set the dir to be a 1. So we're trying to revote on that vote. And we should get a 409. So we'll do assert res.statuscode equals 409. All right, let's test that out. One error. Oh man, what happened here? That's a key error, so something very simple happened. Yep, and I see my mistake. This should be test posts. All right, let's try that out now. And that worked. Perfect. All right, now let's try successfully deleting a vote. And so we will need all of these. We'll also need a test vote. And so we do res equals authorize client.post once again. I'm just going to copy all of this. So we got that. And then the direction is going to be 0 for deletion. And then we just need to assert res.statuscode. This is going to equal, I think we just left it as a 201. Okay, so that worked. And then now we want to delete a vote that doesn't exist. So unlike a post that we never liked. So we'll say def test underscore delete vote non-exist. So we'll need the same exact stuff right here. Okay, I'm just going to copy all of this for now, and then we'll change up the few details. Direction 0, same post. But I'll just grab, actually, we don't want the test vote because we want to make sure that there isn't a vote. So we're going to remove that fixture. And this should be a 404. Let's try that. That worked. And then finally, let's try voting on a post that doesn't exist. So we'll say, liking a post that doesn't exist. So we'll say def toast test vote post non-exist. And copy all of these. I copy this. Set the direction to 1, and the ID is going to be 8,000. And we expect the status code to be 404 as well. All right, it looks like everything's good. The last thing that we just want to check is make sure that a user who isn't authenticated can't vote. So I will copy this. Test vote unauthorized user. And then we want just the regular client in this case. We'll do test posts 3.id. And this should be, what is it, a 401? I can't remember. Let me go to the other one. It should be 401. Okay. All right, guys. So I think we've covered all of the tests that I wanted to cover. We don't need this test calculations py file, but I'll keep it in there in the repo just so you can take a look at it. The database.py file is absolutely useless now, so I'm actually going to just delete. I'll keep it in there just in case you want to see it, but most of it's moved to conf.test.py. But just to make sure that everything's still working, I'm going to run my tests for all. Ooh, what happened here? Nope. Oh. Okay, yeah, that was wild. All right, remove this. Let's see what happens. Hopefully everything passes. And all 46 tests have successfully passed. So that pretty much wraps up all of the testing section. I recommend you guys think of different scenarios that could potentially break our application and set up tests for each and every individual scenario, because that's how you successfully set up tests, because you want to make sure you cover every individual corner case that you can possibly think of. Currently, when it comes to adding in new features and making changes to our code, we have to go through a very manual and cumbersome process before we can get those changes pushed out to our production environment. And so what I think would be good is for us to set up a CI/CD pipeline so that we can do all of this in an automated fashion. So I've created a couple slides just to kind of go over what our CI/CD pipeline is going to do. And I've got the generic definition of CI/CD, and it's probably not a very good definition. And I was thinking about just leaving out the slide because it doesn't really provide much, but I figured I'd just add it just in case. So CI/CD stands for continuous integration and continuous delivery. So continuous integration is the automated process to build, package, and test your application. And then the continuous delivery picks up where your continuous integration ends and automates the whole delivery of the application. So continuous delivery is responsible for actually pushing out those changes to your production network. So those two things make up our CI/CD pipeline. But let's actually take a look at what our whole manual process looks like right now so that we can see where a lot of the extraneous time consumption and manual process takes place. So our current manual process is that, we're going to make some changes to our code, and then we're going to commit those changes to Git, right? Because, we don't want to lose those changes. And then after that, we want to go ahead and run Pytest so that we can verify that our changes didn't actually break any known functionality to our code. And if our tests pass, we have an optional step of building any images. So things like Docker images, if we happen to be running Docker in our development and production environment. If we're not, then this is an optional step. However, when it comes to the build phase, in this case, that some people refer to, other programming languages might require you to kind of build the application at the end to actually be able to deploy it. Python, you don't really need to do that. So that's why it's kind of an optional step here if you're not using Docker. But after we do that, we then move on to deploying our application. So I just have one row called deploy here, but keep in mind this one little block could represent multiple steps because depending on how you actually deploy your application, making any changes or updating the code in your production environment could actually involve a very complex process. So with with Heroku, right, it's obviously a very simple process because all we do is we just do a git push to Heroku, and that's going to automatically cause Heroku to kind of handle all of the updating of the processes. So that's a feature that's built into Heroku, but we only get that if we use Heroku. There's obviously a number of different ways that we can deploy our application. If we decide to go the route of deploying our application on an Ubuntu server, then the deployment process in this case would be us logging into our server, us pulling in the new code with the changes, and then restarting the service so that our application actually uses the new code. But if you're using, some other production environment or you use some other method to deploy your application, this could be an even more complex process, something to keep in mind. So even though it's just one block listed here, it could actually be, numerous steps. All right, and so now I want to show you guys what our automated CI/CD pipeline is going to look like after we set it up. And so just like we did in the manual process, we're going to make changes to our code. Obviously, that's a manual step because we have to implement the changes to our code. And then we're going to commit those changes. And with a CI/CD pipeline, or specifically with the one we're building, that's all the manual steps that we have to do. We are done. We don't have to touch our keyboard or our mouse. It's basically hands-off at this point, and we're going to let automation take over. And so usually when you commit changes to your code, that's going to trigger our CI/CD pipeline to run. And so what happens is our continuous integration phase starts at this point, as soon as we commit those changes. So in the CI phase, we do the first thing that we do is we pull our source code. So we pull our source code so that we can actually work with it. We then install any dependencies. So this is the equivalent of installing all of the dependencies listed in our requirements.txt file. We then run our automated tests. So that's running Pytest. And then, assuming the tests pass, we then build any images. This is once again an optional step for us. That's only needed if we use Docker. But that wraps up the continuous integration phase. So once that's done, the continuous delivery phase is going to take over. And so the continuous delivery phase, what it's going to do is it's either going to grab the latest code or the new build image, depending on what our deployment model actually is. And with the new image or code, it's going to then have all of the logic needed to push that new image or the new code into our production and make sure that our production is actually using our brand new code. And so these two steps are really the only manual steps. The continuous integration and the continuous delivery phase is all done in an automated fashion through code, essentially. And so some of the more common CI/CD tools include Jenkins, Travis CI, CircleCI, and GitHub Actions. Now, for our course, we're actually going to use GitHub Actions just because it's already integrated into GitHub. It's free. We don't need to install anything on our local machine. There's no software that we have to set up because it's all hosted on GitHub. So it's like a hosted service, and it's just going to make things very clean, very simple, and it's free. So it's going to make, and so everyone will be able to have access to it. So what exactly is a CI/CD tool? What does it provide? And so every time I heard CI/CD before I learned what it is, I always thought it was like a very complex thing. And then when you find out what it actually is, it's actually this stupidly simple. Right? There's no magic behind CI/CD. It's all very manual, even though it's an automated process. You'll see that when we actually go to configure it, it's not really doing anything special. It's doing everything that we already do, but we're just providing instructions to a machine. So a CI/CD tool, what it does is it provides us a runner. And so a runner is just a fancy term for a computer or a virtual machine. It doesn't really matter, what is the underlying infrastructure. They give you a little machine that we can provide a bunch of commands for it to run. Right? So just like in our terminal where we run commands like Pytest or pip install, right? We provide these commands to a computer. And these commands are usually configured or provided in a YAML or JSON file, or even through a GUI, depending on what your CI/CD tool is. But the different commands that we provide that little mini computer to run make up all of the actions that our pipeline will perform. And this pipeline or this virtual machine that we have is going to run based off of some event getting triggered. And so, like I mentioned, this is usually us either doing a git push or performing like a merge request. It doesn't really matter. There's a lot of different events that you can configure depending on your CI/CD tool. You can also set it up to run every single night at 2 in.the.morning. There's a lot of different options, but mostly it's going to be based off of a git push. And I wanted to provide just a quick example config of what our CI/CD pipeline is going to look like when we're done. So this is just a little snapshot of it. It's not all of it, but I wanted to show you just how simple setting up a CI/CD pipeline is. So this is the YAML file that we use to kind of tell the machine what are the steps that we want it to perform. And so you can see here, we've got this section called steps. So already you can tell we're just providing it a list of steps. Now, the syntax may be a little foreign, but you'll see that it's pretty easy to learn. You'll see that the first step that we have is there's this thing called action/checkout. So what this is actually doing is it's telling our machine to pull our code. So after we do a git push, it's going to pull our brand new code so that we can actually do something with the code. And then the next step is here we're setting up Python 3.9. So all it's doing is it's installing Python 3.9 for us. And then afterwards we have to update pip. So it's going to run python-m pip install --upgrade pip. So that's going to upgrade pip so we have the latest version. Then we're going to install the dependencies. So that's pip install -r requirements.txt. So you can see all the things that we do on our local machine, we're just telling this little machine to do the same thing. And then afterwards, we then run Pytest. So that's going to first install Pytest, and then we just run Pytest, right? Just like we did on our local machine, we're just telling the machine to do the same exact thing. So we're just telling the machine a list of instructions that we have done by ourselves manually. We're just giving that list to it so it can run automatically. Right? And so hopefully you guys see just how simple a CI/CD pipeline is. There's nothing magical to it. It's just like telling a machine, this is what we want to do. I want you to run this every single time we do a git push. All right. So hopefully you guys understand this. In the next video, we'll get started on setting up GitHub Actions so that we can actually build out our CI/CD pipeline. All right. Before we get started with working with GitHub Actions, I want you to open up a couple of web pages. So if you go to the GitHub Actions documents page, I definitely recommend you pull this up. Take a look at the quick start page and the reference page just to get an idea of how to work with GitHub Actions. I will cover everything, but you are going to forget some things I cover. So definitely know where the documentation is. Pull up the GitHub Marketplace as well. So this is where we can look up built-in actions that we can use in our CI/CD pipeline that have kind of handled a lot of the more complex logic. And then on top of that, you'll see that GitHub has this example tutorial on how to set up a CI/CD pipeline for a Python application. So this is what I kind of looked at to get started with building out a CI/CD pipeline for our fast API, and it kind of covers most of the things we do that we need. So if you want to, you could just follow this, and I think at that point you'll have a good idea as to how to work with this. But once again, like I said, we're going to cover everything from scratch. But if we go to the documentation, you go to Quick Start right here, right? It tells you that we want to create a folder called GitHub, and then in that folder we want to create a folder called Workflows. So let's go ahead and do that. So in our main project directory, let me just minimize everything. I'm going to create a brand new folder, and I'll call this .github. And then we want a new folder within here called Workflows. All right, and so here we can define all of our workflows, which kind of make up our CI/CD pipeline. You can have more than one. You don't need to just have one in this case, but we're just going to use one because we're keeping things simple. And so here, this is where we're going to create a YAML file. So if you aren't familiar with a YAML, it's just a certain type of markup language that's commonly used for like config files and things like that because it's very easy to read. But the most important thing to keep in mind is that spacing matters in YAML. So you definitely want to make sure that all the things are lined up very carefully, just like it was when it comes to like the Docker compose file. So we'll go here and I'm going to create a brand new file and I'm going to call this build-deploy.yaml. All right, and so we're going to give this workflow a name. So even though we gave it the file a name, we actually have to provide a name here. So we just do name and feel free to call it whatever you want. I'm just going to call this build and deploy code. Okay, and then we have to define when should our workflow, or in this case, which is our CI/CD pipeline, when should it run? When should it trigger? What triggers our code to run? And so, like I mentioned, it's usually either a pull request or a git push. So to specify when we trigger this, you pass in the on field, and then you specify, should this be a push or a pull request, or should it run for both? And so if you want this to run only on git pushes, you would just do on push. If you wanted to run on pull request, you would do pull request here. But if you wanted to run for both git push and pull request, then you would do push and pull request. And there's a lot of flexibility too. So the way we have it set up right here, this would happen on every push on every single branch and every pull request on every single branch. But there's a possibility that maybe you don't want this to run for all of your branches, right? Maybe you only want this to run on the main branch and a couple of other branches, and then the rest of the branches you don't really care about. So what you can do is we can go down a level and then hit tab in this case. And remember, like I said, spacing matters. So we'll say push. And then here you can define all of the branches that should run whenever you do a push. So if I pass in main, what's going to happen is that this workflow is going to trigger every time we do a push, specifically only to the main branch and no other branches. And so you can provide a list of all the branches. So this is, another branch. This is, maybe some feature branch. All the names of the branches that you want your workflow to run on, you can specify that. And this is one way of providing a list in YAML. The other way is to actually go down here and then do a dash and then provide the name. So I would do main and then, some other branch and so on. And then if we wanted to, we could also customize all of the branches that should trigger this workflow on a pull request as well. So if I do pull request, and then I do branches, and this should be moved back here. And then here I do branches. And then I can do a list here as well. And I'll just call this, we'll give an example branch. I'll say test branch. Right. And so just to kind of read this through, anytime we do a push to either one of these branches, it's going to run our code. And anytime we do a pull request to this specific branch, it's going to run our code as well. So that's just how to set this up. We're not going to do any of that because we just have one branch in this case. So I'm just going to say we're going to run this on push and pull requests for all branches. And if we actually go to the documentation, I think, the reference page, You can go to the reference page and then select events that trigger workflows. And that's going to cover everything that we just covered. So it's going to go over all of that. And you'll even see that there's a scheduled event. So you can tell it to run kind of like a cron job, like, hey, I want this to run every single hour. And there's a few other like manual events that you can trigger and a couple of like webhook integrations as well. But we're not going to do any of that. We're just going to keep things simple for now. All right. So once we've defined what's going to trigger our workflow, we have to then create a job. And so if you go to the documentation, the GitHub Actions documentation says that a job is just a set of steps that execute on the same runner. So our runner is just a virtual machine. So when our workflow runs, right, we have to provide it a job, which is just a list of steps that's going to run on that specific runner in that case. And so here I'll go to jobs. This is where we provide a list of jobs. We're going to start out with just one in this case, and we can give this whatever name we want. I'm going to call this job 1. Not a very good name. We're going to rename it in the future, but I want to just keep it simple for now. And what we want to do is we want to specify what type of machine do we want to run this on. And so like I said, a CI/CD tool like GitHub Actions is going to provide us a machine, a computer. And we have to specify what operating system do we want to run it on. So we're going to just use it on Linux, but keep in mind, you can run this on Windows, you can run this on Mac, you can even run it on all three if you want to test all of them. But since our production environment is running on a Linux machine, I think it makes sense that we do all of the testing and all of this on a Linux machine. So you pass in the runs on field, and then here we say Ubuntu latest. So this is going to be the latest Ubuntu version. And if we go to the reference page here and go to the workflow syntax, I think, and we go to jobs, that's going to provide us all of the information when it comes to what we can run this on. So you can see here, we can provide Windows 2022, or you can just grab Windows latest. We've also got, and I realize the text is probably small for you guys. We got different versions of Windows. We've got Ubuntu latest, which in this case at the moment is just going to be the same thing as writing Ubuntu 20.0.4. But you can grab any one of these specific Ubuntu versions, as well as Mac OS 11 and some of the other previous Mac versions. But like I said, we're going to stick to just running on Ubuntu, and we might as well just grab the latest version. And so once we specify the operating system, the next thing that we have to do is provide a list of steps. So we kind of went over what the steps would look like when we did the little PowerPoint demonstration. So here we say steps, and then we provide a list of steps. So when it comes to lists in YAML, you just do the dash, and then you provide the lists. And usually when it comes to a specific step, we give it the specific command that we want to run, as well as a name, right? A human readable name, so that when we look through the logs, we know which step is doing what. So we can say like, hey, this step is installing Python, or this step is running Pytest. And so here, if we say name, this is where we provide a description for what we're about to do. So the first thing that we always want to do is we want to check out our code. And so I'm going to say, hey, this is checking, or I'll just say this is pulling Git repo, right? It's going to pull our code, and then we have to provide the uses. So this is the actual command that needs to run on our machine to pull our repo. And with GitHub Actions, like I said, there's a marketplace of pre-built actions that we can use to, essentially perform various tasks. So pulling your code is a very common task. So they've definitely got an action for this. And so if I just search for checkout, because I know that's what it's called, you can see this is the one we want. And so this is what's going to be responsible for pulling your code. And so here you just say uses, you do actions/checkout v2. And you could specify a specific repository that you want to pull. However, GitHub already knows what repository we're working on because we did a git push. And since all of this is integrated together, we don't actually have to pass in any other field. However, if you look at the documentation, you can specify what specific repository you want, as well as any SSH keys that you may need and things like that. But this is GitHub Actions, so it's all already hosted on GitHub. So it's a pretty simplified process. So all we have to do is just copy this right here. And we can just kind of continue down and just provide as many extra steps as we want. I'm just going to provide a very simple step after this just to show you, a step is just nothing more than us giving a command. So I'm going to name this one, say hi to Sanjeev. And what we can do is this is a special action that we grab from the marketplace. But if you just want to run a command on the machine, which is just a Linux machine, we can run any specific Linux command that we want because we have access to the CLI. All we have to do is just use the run keyword, and then we specify the command we want. So if you wanted to install a package, we could do, sudo apt install whatever. Or if you want to reload the machine, you could do a reboot. I'm not sure why you would do that. So all I'm just going to do is I'm going to just make it say echo, which is just going to echo out exactly what I type in here. I'm going to say, hello, Sanjeev. And so it's just going to run this command on our Linux machine. And so this is a very simple example so far, but I think that's a good starting point so that we can actually understand what's happening. And what we want to do is we now want to actually push this changes to our Git repository. So let me open up my terminal. Make sure you do save all. And so once we push this, this will actually be part of our repository, and it's going to actually trigger GitHub Actions to actually trigger this workflow, because we said that on every push, we should run this workflow. So I'll do git add all. I'll do a git push. Sorry, git commit -m adding first GitHub action. And then we'll do a git push. And we can do an origin main if you want to be specific. All right, so it's been pushed. And so now if we go to our GitHub repository, there's a Actions tab right here. And so you'll see that I had a couple of other actions that ran because I was doing a dry run. But you'll see that the most recent one, which is the one we had, which is called adding first GitHub action. So this actually comes from the commit name. And we could select this, and we can see exactly what happened. So this gives us a little summary. We can see that we have one job called job 1. And then we can see that the job ran, and it successfully ran, and it took 4 seconds. And if you click on the job, you'll see all of the steps. So the first thing is it sets up the job. And so you can see that it's creating a runner, which is, once again, just a virtual machine. And then it's going to provide us Ubuntu because we specified that as our operating system. It's going to set up a virtual environment. Don't worry too much about that. It's going to handle all of the GitHub permissions because it's all integrated with GitHub. Then we go down to the first action, which was pulling the Git repo, because we did say action/checkout v2. So then it's going to pull the GitHub repo. And then we could see the second option. The second action, which was say hi to Sanjeev. So all it's doing is just running this command on our Linux machine. So it's just saying echo hello Sanjeev, and then it just prints out hello Sanjeev. So this is all a CI/CD pipeline is. It's just providing a bunch of instructions for a little machine on the internet to run for us. Now, technically, the machine doesn't have to be on the internet. It doesn't have to be hosted. There's some CI/CD tools that you host yourselves on your own machine or your own server, so that they actually handle running all of this, because even though GitHub Actions is free, they only give you a certain number of build minutes for free. And then after that, they'll start charging for it. So depending on how many times you build, it may actually be more cost effective to just set it up yourself. And then it looks like, GitHub Actions, there's a post pulling Git repo. So it's going to perform a few other like cleanup actions, and then it's going to then clean up the job. So we have successfully created our first simple example CI/CD pipeline, or GitHub Actions workflow in this case. So let's take our GitHub Actions to the next step. And I'm going to actually remove this example. I just wanted to show you guys how to do that. But after we pull our GitHub repo, the next thing that I want to do is I want to set up Python. And so to set up Python, once again, we can go back to the marketplace, if I can find it, because setting up Python seems like a very common task. So we can just search for Python. And keep in mind, when it comes to setting up Python, you could technically just do the same thing where we can say uses, and then we can run the command on a Linux machine to install Python, which would be something like sudo apt install Python, right? We could 100% do that, and that would 100% work. But because this is such a common task, there's already a pre-built action, so we don't even have to do that. And I think I searched for Python. Did that work? It didn't look like it worked. Here we go. Set up Python down here. So this is going to be responsible for setting up and installing Python on our machine. And you'll see an example of how to do this. You just say uses action/setup Python at v2, and then you say with, and then you specify the version, and then you can also provide the architecture as well. And what's really cool about this is that, let's say we wanted to test our code on multiple different versions of Python. Well, we can go under the strategy section. So right under where it says runs on, we can do strategy. And then we could provide a matrix and then a list of versions. So if we wanted to test version 3.7, version 3.8, 3.9, 3.6, and make sure that our code works on all of them, we can then create this matrix here. And then when we go to set up our Python, right, we would say with, and then for Python version, instead of providing one specific version, we actually pass, this is essentially a variable syntax in YAML, and then we just call matrix.python version, which is referencing this list right here. And so it'll just run our actions for all of these versions just to verify that everything works in all of the versions. But we're going to keep it simple. We're just going to do version 3.9. If you want to play around with it, I definitely recommend you try testing this out. But for us, it doesn't really matter. But keep in mind, it looks like you can even do the same thing for different operating systems. So if you want to test on Ubuntu, Mac, and Windows, you can do the same thing as well. But like I said, we're going to keep things very simple. And I'm actually going to change this to name, give this a name. I'm going to say install Python version 3.9. And then we'll say uses, and then we'll call that action now. So we'll do action/setup-python at v2. And then we pass in with tab, and we'll say python-version. And we'll say 3.9. And I think that's all we have to do. Let me see the example. Python version 3.9. Yep, that's all. We can leave the architecture. I'm going to use the default, which looks like it defaults to x64, so not a problem in our case. All right, and then after installing Python, the next thing that I want to do is I want to upgrade pip. So I'll create a description of update pip. And then we'll say uses. Actually, instead of uses, we're just going to run a command on the Linux shell. So we'll say run. And we just run python-m pip install --upgrade pip. So this is the command that you would run on any Linux operating system or even on a Windows machine to upgrade pip. And then the next thing that I want to do is we're going to install all of our dependencies. So since we pulled our Git repo, right, with the actions checkout, we're going to have access to all of this code, and we're going to have access to our requirements.txt. So we have to make sure that we install all of these packages there as well. And so here I'll just say this is install all dependencies. And the command that we're going to run for this is going to be and you guys should know this is just pip install -r requirements.txt. All right, so I think this is a good starting point. Let's try committing our code again. So I'll just do git add --all. We'll do a git commit -m, added more steps. And then we'll do a git push origin main. All right, and then we'll go back to actions. Right? And we can see that our workflow is starting to run. That's why it's yellow. And we can take a look at its current status. So it's still running job 1, which is the name we gave it. And we can just kind of follow along. So it looks like it pulled our repo, installed Python version 3.9. It's then updated pip, and that's already completed. And now it's installing all the dependencies. So obviously installing all the dependencies takes a certain amount of time. That's probably going to be the longest specific step in our GitHub workflow at this point. All right, and it looks like that ran, and then it's essentially cleaning things up, and then it's completed, and we get the beautiful green check mark. So we can just close out of this, go back. And you can even see the list of all of our workflows that GitHub Actions is detected. So we have build-in deploy code, so that's the only workflow that we have, but keep in mind I can create essentially as many different YAML files inside this workflow folders to have different workflows. So I might have one specific set of, I might have a workflow specifically for one branch and a completely separate workflow for another branch. It just gives you a lot of customizability, but we're just going to have one workflow that works across all of our branches. Now, the next thing that I want to do is I want to run Pytest. So to run Pytest, right, it's a pretty simple process. So let me set up the name first. I will say, test with Pytest. And then we'll say run. All right, and I need to run 2 commands. So if you ever want to provide a list of commands to run, instead of having to create multiple different steps, I can do a pipe, go down a line, and just provide the list of commands. So we'll do pip install Pytest, and then we can go down a line and provide the second command. So then we just run Pytest. And you can, pass in whatever flags if you want the -v and the -s. But I'm going to keep it simple, and we're just going to keep it blank for now. Let's save this. And I'm going to then do the same thing. We'll do a git add --all. We'll do a git commit -m. And I'll say added Pytest step. And then we'll do a git push origin main again. And so from a learning perspective, right, this is kind of a slow process because we have to push all of our changes, and then now we have to wait for this whole thing to run. But once you understand how all of this works and how easy it is to set up, you won't have to keep doing this every single time or every single project. You can just essentially copy and paste most of your workflow. All right, so it looks like it's completed and we get a red X. So it looks like something broke, and that's to be expected. And it's going to highlight what specific test failed, or sorry, what specific step failed. But we can see that it was the running Pytest. So if I just open this up a bit and then expand it, we can take a look at what the error was. So it looks like it installed Pytest, and that seems to have worked fine. And then down here, you can see that there's a couple of validation errors. And so it says that, we didn't provide a database, hostname, port. So it looks like there's issues with environment variables. And that makes sense because this is a brand new computer that we haven't touched. So none of the environment variables have been set up. So obviously it has no environment variables, and our Pydantic validation of environment variables should have failed, and it did absolutely fail. So this is all to be expected. And so in the next video, we'll figure out how we can set environment variables in our workflows so that we can provide the information for reaching our specific database. So there's a couple of different ways that we can set up environment variables, and there's a couple of different places where we can define them. So I'm going to show you how to set a job-specific environment variable. That means this is an environment variable that will only be accessible from within one job. So in this case, our job that we've been working on is called job1. And so if you want to set an environment variable, you just set it right here. So we say env, and then you provide all of your environment variables. So in this case, let's say we want database hostname. And in this case, it's going to be localhost. We've now successfully set up one environment variable, and I'm just going to copy and paste all the others. And so now we've defined all of our environment variables in this case. And that should fix the issue. But I want to show you guys what other environment variables that we have as well. And if you want to know where I'm kind of getting all this information, like I said, we have the documentation, and there should be a section for environment variables here. And so I think we should see the same thing, right? Yep, we see the same thing. So env under the specific job, and you just provide the list of all of your environment variables. And then there's some built-in ones. So these are default environment variables that get set for you. So here you can see what's the run number, what's the GitHub job, what's the action path. We can even see what's a repository. So if you want to get the name of your repository, you can reference this specific environment variable, but we don't need to do any of that. But what I do want to show you is, if I had gone in and then created a second job called job2, right? This environment variable that we defined here is not available because this is defined under job1. So if you want to have an environment variable that's shared across all of your jobs, I can specify an environment variable here. So I can say env, and then I just provide my environment variable. So I can just copy this one as an example, and we can provide this. So then database hostname is going to be available for job1 and job2. But for now, we're just going to remove that because we don't really need that right now. And I'm going to keep everything as default in this case. And we're going to check this into Git. So I'm going to do a git add --all. We'll do a git commit -m, added env variables. And we'll do a git push origin main. Okay, and then back to our actions page. If I see the added environment variable section, we can see that failed. Once again, this is going to be expected. So if we go under, it looks like there's a weird failure. No steps defined. Okay, so we got an error because I accidentally left job 2, so it doesn't like the fact that I have jobs 2 with no steps. So we're going to save this again, and we're going to do another commit. And I'll just call this committing again because I'm getting lazy. All right, and let's just make sure that we've kicked this off. All right, so it looks like we kicked it off and there's no like major show-stopping errors at the beginning, but we should still see this fail, and that's to be expected. But I just want to make sure that we no longer have issues with environment variables, and I want to make sure that the environment variables that we set did successfully get applied to our runner. Okay, guys, so a couple of things to point out. So there's a whole bunch of errors, and that's to be expected, and that's okay. But we can see that it did process all of our environment variables, so that's great. So we did fix that issue. But you'll notice that, when we're running our test, we get a whole bunch of errors, and then eventually you'll see a whole bunch of SQL Alchemy errors. And the reason we see a whole bunch of SQL Alchemy errors is because if you look at the environment variables, we're pointing to localhost for our database. There's no database on this runner. This is a brand new computer. Why would there be a database installed? So we do eventually have to set up a database for testing on the runner itself, or we would have to point it to a remote database, whether that's hosted on Heroku or AWS, it doesn't matter. But for testing purposes in your CI/CD pipeline, I'd rather create one on our runner that we can just quickly spin up for testing. So once again, I just wanted to point out how to set up environment variables. The one thing I don't like, and I want to make sure I want to teach you guys, is that in this case, we're hard coding these values in here. And so this is all stored in our repository. Anyone can have access to it. This is our test database, so it's not a big deal. But I do want to show you how we can store these as secrets so that the runner has access to them, but no one else can see them, because storing it in here could potentially cause issues. If you didn't want this, the password and the username for your test database to get out. In my case, I don't really care, but it is important for you guys to understand how to actually do that. So as I mentioned in the last video, our environment variables are hard-coded into our workflow. So technically, when we check this into Git, anyone can see it, which may or may not be a problem. But if it is a problem, I'm going to show you guys how we can work with GitHub secrets. So if we go to our GitHub page and go to settings, here there's a section called secrets. So we can define secrets that we can use and access in our workflows. And so this is a repository secret. That means it's globally accessible across the entire repository, across all branches. There's no, any kind of environments or anything like that. So we'll select new repository secret. And here we just give it a name. So if you take a look at our environment variables, I figured since that's what it's going to represent, we might as well use the same one. So I'll say database host name in this case, and then just give it a value. So localhost. That's it, right? It's just a key value pair. We do add secret, and then you'll see it's stored in here. And so now in our code, if we want to reference this secret, which I happen to call database hostname, we just copy the name of the secret. And then what we do is we use $ curly brace, so 2 sets of curly braces. And we say secrets dot, and then the name of the secret. So this will allow the runner to access the secret from our GitHub repo so that our workflow code doesn't actually expose all of this information. And so this is what you want to do for your passwords and things like that, especially when it comes to storing the information for connecting to your production database, which we will do in one of the later lessons. But before we proceed any further, I want to actually show you another option. So I'm actually going to remove this repository secret in this case, which is, once again, a global secret that our entire repo can access. Instead, what I like to do is I like to set up environments. So you can set up a whole bunch of secrets that are available depending on what the environment is. So I can create one for testing, one for development, one for production. It gives us a lot of flexibility. So I'm going to create a new environment, and I'm going to call this testing. And within the environment, we're under the testing environment, we can add a secret here. And so we're going to do the same thing. I'm going to call it database hostname. And in this case, we'll say localhost. We'll add the secret. And we can provide as many secrets as we want. And then what we can do is, in our job, we can specify what the environment is for the job. So I can say environment, and then we provide the name, which is going to be testing, right? This is going to match up with whatever name we gave here. So I called it testing. So we give this the name testing, and it's going to have access to all of the environment variables that we defined here. And the way to access them is exactly the same way. You just do $, 2 curly braces, secrets, and then the name of the environment variable. Now, if there's an overlap with the name of your environment variables when it comes to the ones that you set in your environment, as well as the one you set globally for the repository, I don't actually know who takes precedence. I suspect it's probably the environment, but you should check the documentation to verify. But we don't have any global secrets. I'm going to be using environments for everything, so this keeps things nice and simple. And so now that we've set up this one, let's go ahead and just set up all of these while we have the option. And so we're going to set the port as well. Here we'll set the password. We've got the database name, which we'll just say fast API. Then the database username, it autofills because I ran through this all in a quick trial run before I started recording, so it's kind of cached in there. All right, and so now that we have all of our environment variables or our environment secrets set, we could just change all of these to reference those secrets. We just do the same process, and in this case, it's just going to be the same exact name as the key in this case. All right, and so now that we got all of these set, let's just save this, and I'm going to check this into Git now, just to make sure that everything is kind of working so far. And we'll take a look at the job real quick, and hopefully there's no errors or only errors that we expect to see. And what did I call this one? ASDF. Oh, okay. So it looks like it failed already. So we clearly did something wrong. This workflow is not valid. Unrecognized name database _ port. Well, what happened there? And it even tells me the position. So if I select show more, database _ password. So let's see. What did we mess up? Yeah, simple mistake. I forgot the secrets dot before all of my variables. So that's why it had no idea what that was. We have to reference secrets to actually get access to them. And now let's try this one more time. All right, this looks a little better. All right, and so now if we look at the test with Pytest, you can see that the environment variables were passed in, and GitHub will automatically hide what all of the secrets are, because once again they're secrets, so you shouldn't see them. But it does show that we were successfully able to retrieve them, and we got the same error down here. This is just an issue with accessing the database because there is no database on localhost. So it's trying to connect to a database that doesn't exist, which is going to create all sorts of issues. So in the next video, we'll figure out what we can do to set up a test database on our runner so that we can actually run our tests. So when it comes to setting up a database on our runner, the easiest way to do that is to create a service container. So what's going to happen is GitHub Actions is actually going to allow us to spin up a Docker container, which really is the easiest way to set up to set up Postgres on a remote machine. That way we don't have to worry about any issues with potential installation of a Postgres database. And so I recommend you take a look at this tutorial, which kind of walks you through how to set up a Postgres service container. And it just gives you an example in this case, which we are essentially just going to copy in this case. But here we just, under jobs, we specify a service. We give this service a specific name or label, and then we just tell the image that we want to use. And in this case, we're just using the default Postgres image. This is the one that comes from Docker Hub, by the way. but you could technically use any image that you wanted to, but it's Postgres, so we might as well just use the default one. And then we can pass environment variables into the Docker container as well. So one of the things that we want to do is set up the password for Postgres, as well as even potentially the database name. And then what we want to do is we want to set up some health checks to wait until Postgres has started, because until Postgres starts, we should not run any tests because the tests are going to fail because the database is down. So we want to make sure that Postgres is up and ready before we actually start running our tests. So we're essentially just going to copy this line here. But let's go back to our code and we'll take a look at how to do this step by step. And so I'll just go under the environment variable section here, and we'll create a section called services. And I'm going to create a service called Postgres. And we're going to provide the image just like we saw in that example, and that's going to be Postgres. And let's pass some environment variables. So the first thing is going to be the Postgres password. So we're going to do Postgres _ password. And here for the password, we can literally reference the same exact secret because they're going to be using the same password. And then we also want to give it a custom database name. So we want to automatically create the fastAPI _ test database so that we don't have to do it in code. So I'll do Postgres _ DB. And we'll do $, and then here I can pass in, where's my database name? So this is just going to be fastAPI at this point, but we want fastAPI _ test because that's what our code has been set up to run. So we'll do _ test, right? So this is kind of like string interpolation. So same thing. And then at that point, I think our Docker container is pretty much set up. We do have to specify the ports that we want to open up. So we'll say ports. And we want to do 5432 and then 5432. So this is what we want. And you're probably thinking, well, can we use the variables here? And I tried to do this. I tried to paste this here and then paste this here. And I actually got errors. I don't know why it didn't work, but for some reason this wasn't allowed. So you have to hard code these values, unfortunately. And then lastly, let's set up the options. So I'm going to just copy these options right here because we want those health checks for sure. Let's save this and make sure that all the spacing lines up because a lot of times the spacings can mess up things. I have a auto formatter, so for YAML syntax, it'll automatically format it so that all the spacing is set up properly. You want to make sure that you do it manually or set up or install a extension in VS Code if that's an option for you. Okay, so we've got our Postgres database, and I think we should be good to go. So let's try this: git add all, git commit. All right, and so we can see that our most recent test, in this case, happened to succeed. And if you actually go to the test with Pytest and just see the results, we could see that 46 tests pass with no issues. And so that means it did successfully connect to our database. And after that, it essentially completed the job. So now we've successfully added a database and we've successfully set up our CI pipeline. This is the CI portion of things to pull our code, install Python, set up, install all the dependencies, and to run our tests. So all of this happens in an automated fashion now just by doing a git push. So you could see how easy it is to get things started. And so I think from the CI perspective, the last thing I want to show you guys is how to essentially create a Docker image in our runner and push that out to Docker Hub so that our production network can then pull that brand new image. So there's a couple things that we have to do to get Docker working in our GitHub workflow. The first thing is we need to have a repository set up on Docker Hub to store our images. And if you did not create one during the Docker section, go ahead and create a new one. So log into Docker Hub, select create repository, and just give this a name that you can remember. In this case, this is going to be fast API. I'm going to call it that, and then make it public just to keep it simple. And so this is our repo, and then it's going to tell us how to actually push an image to it. And then if you go to this page right here, so docs.docker.com /CICD/GitHub Actions, it's got an excellent tutorial that we can follow for setting up Docker with our GitHub Actions. And so if we go back to our Docker Hub, the first thing that we want to do is we want to get an access token. So let's go here. And I think we go under settings, or, well, it doesn't look like it's here. Maybe account settings. Yep, and then security, and then we can select new access token. And maybe we can call this GitHub Actions. And we're going to give it, whatever permissions that you want. Does the Docker give us information on what permissions? It doesn't look like it in this case. So just go ahead and select all of them for now. All right, and so it's going to give you your access token. Make sure that you don't share this with anyone else, and it's only going to be displayed once. So go ahead and copy it and make sure that you have this. Then what it's telling us to do is we want to create a secret for both our username as well as the Docker Hub access token. So let's create these two secrets in GitHub for Docker Hub access token and Docker Hub username. And I actually forgot what my username was. Okay, so it's sloppy networks. And so here we'll go into settings. And feel free to use either the global repository secrets or environment secrets. I'm going to just put this in the testing environment for now, but you can use either one in this case. And so we got Docker_hub_username. So this is going to be sloppy networks for me, but it's going to be something else for you guys. And the last one is going to be Docker Hub. What is it? Docker Hub access token. All right, and so once we've got that set up, you'll see that they're going to give us the steps on how to actually set this up in our YAML file. You can ignore the original, the setup process. And what we want to do is we want to go down to this section right here, which shows us how to log into Docker Hub. So we can literally just copy this straight up and just paste it in here. So we can just say, we'll do it at the, what step should we do this at? We'll do it at the end, just because why not? Because some of you guys might not be interested in setting up Docker. So it's going to be an optional step at the end. So we'll log into Docker Hub using this built-in action from the marketplace. And then here it's just going to provide two properties, username and password, which is going to reference the two secrets that we created. All right. And then we want to set up Docker buildx. So we'll copy this one as well. Right, and then we have the build and push step right here, which in this case, it's once again a built-in action. And all it's going to do is we're going to provide a path to the context. So this is essentially where is the Docker file located. And this is technically optional, but if you want to, you can hard code the specific Docker file. I think it should default to this one because that's the default Docker file, but we'll just put it in just in case. And then the push means not only are we going to build the Docker image, we're also going to push it up to Docker Hub, and then we have to give it a specific tag. And if we go back to Docker Hub and I go to my repositories and I go to my fast API, it's going to show me the format of the tag that I need so that I can actually push it up properly. So it's going to be the username / and then the name of the repository, which is fast API, and then we can also give it an optional tag name as well. So once again, we're going to copy this and just update a few fields. Everything else should be just fine. The only thing that we have to change is this is going to be fast API, and it's going to reference the username. So it's going to be in the exact format. And if you want to give it a very specific tag, you can give that as well, but I'm going to just give it the default latest. And then here it's just printing out the image digest, which is for us is optional. you'll see that it does provide us some optional things that we can do for optimization. So we can use um, the build cache so that we don't have to re-download all of our images every time we run, because that's going to extend the build time and the run time for our runner, which is eventually going to cost us a certain amount of money. So this is the code that you can use. And if you look at the bottom right here, this is going to show us all of the code at the very end. So we can literally just copy all of this if we wanted to and just use that instead of what we put. So that's what we will do. So let me just delete all of this and then paste it in. And we have everything. And once again, we just want to change the name to be the repository name, which is right here. We could also use a secret for that, but don't worry too much about that. And that should be all that we have to do for the Docker integration. If you don't have a Docker file, then I'd recommend I'll just pause this video, create a file in the root of your project directory called Dockerfile with a capital D, and just copy all of this, or you can follow what I go through in the Docker section if you guys skip that. And I think that should be everything that we need. So let's go ahead and push this and pray that it does not break anything and it works just the way we expect it to. So we'll do git add --all, git commit added Docker, and then we'll do a git push origin. Yep, and it failed. So fully expected this. A step cannot have both uses and run keys. So what did we break here? Actually, it should, where is it telling us this? Yeah, this spacing got messed up. So that was a very obvious mistake that I should have caught. And I just have to move this back right there, and that should fix everything. So let's do this again. All right, so far it's not errored out, so it looks like things look okay. And we can see the build and push section failed. So let's see if there's an error. And it looks like there's some issue with the driver. Please switch to a different driver, docker build x create -- use. So let's see what that is in this case. And I realized the documentation was a little confusing. This section that we copied at the end, it didn't include one of these steps, which is the build x step. So after we log in, we want to set up a build x, which is the mistake that we ran into. So we want to copy this page right here, this section, and then we'll run that right after the login. And so now if we do a git add all, git commit -m, and then a git push origin main. Okay, so I think this time everything should work. But just to reiterate, because I think I went a little bit quickly, the steps are we first log into Docker using the login action right here. Then the next thing is we set up build x, and then we call the build and push action in this case. And here we specify the context, which is saying just this current directory, and then the location of our Docker file. And then we're going to use build x for the builder. And we set push to be true because we want to actually push it to the GitHub repo. And then here the repo is going to be our username / then the repository name, which happens to be fast API. We could store this in a secret, but I decided not to. And then these are just copied from the documentation so that we can cache all of the images so that we don't have to keep running all of this from scratch, which is a fairly long process. And then here we're just spitting out the image digest. And if we take a look at our workflows, and we can see that the last one, which is called ASDF, successfully ran. And if I actually go back to my Docker Hub in this case, and just hit refresh, right, we can see that we did successfully push an image a minute ago. So that means we have now successfully completed our entire CI portion of our CI/CD pipeline, the next step is to set up the continuous delivery, which is a matter of just providing a whole bunch of commands needed to actually push out our new code to our production network. And moving forward, just to kind of keep things simple and as quick as possible, I'm actually going to copy out all of the Docker steps because we're not even using Docker in production. So we don't actually need this. So we'll just comment that out just to make things as quick and as snappy as possible so that we don't use too many of our build minutes. So now that we set up the continuous integration part of our CI/CD pipeline, it's now time to move on to the continuous delivery aspect of our CI/CD pipeline. So this part is going to be responsible for pushing out the update to our production environment so that our code or our production environment is running our newest and latest code. So there's a couple things we can do, and I'm actually going to do this up here. Actually, we'll just do it down here. It's fine. So what we could do is, just to keep things simple, I could just provide another step, right? And we can give this, whatever name we want. I could say name, and then, hey, this is push changes to production. And then we can, provide the steps needed to actually push those changes out. However, instead of doing it like this, what I would like to do is I actually want to break it out into a separate job so that we can kind of have things nice and organized. And what I actually want to do is I want to rename job one because it's not very descriptive. I'm going to rename it to build. And then I'm going to create a second job and we'll call this one deploy. So we've got two different jobs. However, the issue with jobs is that they don't behave the way that you think they would. And let me delete this. The way that jobs work is that by default in GitHub, the jobs run in parallel. And so what I mean by that is that when our workflow runs, GitHub is actually going to run the build job and the deploy job in parallel at the same exact time. Now, we would definitely not want to do that because that would mean before we've even, run our tests and done anything else, we would try to actually deploy our new changes, which would be a terrible thing to happen. So we don't want it to run in parallel. How exactly do we configure that? Well, we pass in an option called needs. So you say needs, and here we tell it the list of jobs that need to complete before this job can run. So here we just say this needs to wait for the build job to run before this job runs. And so we just pass that into here. And you could pass in multiple jobs if you wanted to. We only have one other one. So this is going to cause this to run in a sequential order. And just like with the other job, we need the runs on property to define, that we want to run this on Ubuntu latest. And then I'm just going to create a test step. In this case, we'll do steps. And the first step is going to say uses. Actually, I'm just going to say name, deploying stuff. And here I'm just going to run a command on our server. And I'll just say echo going to deploy some stuff. All right, so let's test this out. I'll do a git add -- all, git commit -m. And if we go ahead and check GitHub and go to our actions, let's take a look at what happened in the adding deploy. And so you could see now that we have two different jobs, we can actually see the two different jobs here. And so it looked like build ran just fine. And then it looked like deploy also ran just fine. And so if I take a look at the deploying stuff, we can see that I ran the command going to deploy some stuff and it was successfully deployed, although we didn't actually deploy anything. But you get the gist of it. So now it's just a matter of figuring out what commands we need to run to actually push those changes out to our production server. And so, we covered two different deployment models in this course. There's Heroku, and then there's the Ubuntu server. So we're going to start off by going over how we can actually handle this with Heroku. And if we go to our code, right, here we're going to provide the steps to actually push an update to Heroku. Now, if you don't remember what we actually did to push changes out to Heroku, do a git remote, I think. Yep, so this is going to list out the the Heroku remote. So if you want to actually push out the changes to your Heroku application, you would do a git push Heroku and then your branch, which is main. And that's going to update our application. It's pretty simple with Heroku. So in this machine, right, in our CI/CD pipeline, it's not quite as simple as running git push Heroku main, just because we don't have Heroku installed on this machine. Because when we set up Heroku, we had to install the Heroku CLI. We had to run Heroku login, put in our credentials, and then we had to we have to get our Git repo, we have to add the Heroku remote, and then we have to do a git push. So there's a couple of different steps. And so manually doing it, I just want to kind of write this out. We would, install Heroku CLI. We would, actually, before we even do that, we would, first of all, pull our GitHub repo. Because remember, this job is essentially starting everything from scratch, potentially on a different machine. So anything we did here, none of this stuff is available. So we don't actually have access to the repo that we pulled here. So we would have to do it again here. So we pull the repo, we install Heroku CLI, then we do a Heroku login, and then we do we have to add in a remote in Git, and I forget the command. But we'll just say add git remote for Heroku, and then we have to do a git push Heroku main. So those are the steps that we would have to run to actually deploy our application in our CI/CD pipeline. And this is all technically possible. You can manually do this, but it's actually a kind of a pain in the butt to actually do this. And instead, what I recommend you do is look for a action in the GitHub marketplace that kind of does this all under the hood. So that's what we're going to do, because deploying to Heroku is a very common task. So if I go to the marketplace, which I forget which tab was the marketplace. Oh, I think it's this one. Yeah. And so here, if I search for Heroku, you'll see that we have a couple of different options for deploying to Heroku in the marketplace. Let me just see view all, because I got to figure out which one is the one that I want. And this is the one that I want by Akhilesh NS. So this is the one that's got the most stars. So we'll select this one. And you'll see that in the example, the way that we actually deploy to Heroku is we have to get a Heroku API key. We have to provide our Heroku app name. And then we have to provide our Heroku email. So let's get this from our account, and then we will create secrets within our GitHub repository so we can store that information, because we don't want to hard code that into our YAML file. So going back to Heroku, if you go to your account, which is the little logo here, and then select account settings, you'll see that the API key is right here. So we can just like reveal, and then I'm just going to copy this key. And what we're going to do is we're going to go to our GitHub repository. We'll go to settings. And then we can create our secret. So you can create a global repository secret, or you can do what I'm going to do, which is I'm going to create a brand new environment for production. We'll call this production. That is not how you spell production. And we're going to add a secret. And I'm going to, paste the value here, but the name, I'm going to just stick to what they used just to make it easier to remember. So Heroku _ API key, add secret. And then what else do we need? We have to add the email. So let's create a secret for the email as well, because why not? They didn't do that, but we're going to be a little bit more secure. And I'll call this Heroku _ email. And this is just going to be your email that you use to register. And then if you want to, you can also add the Heroku app name as a secret as well. You don't have to do this, but I'm going to do it. And what did I call my app? I can't even remember. Fast API Sanjeev. Yours is going to be different, so make sure you update it accordingly. Okay, so wait, what happened here? Why is there only two? I think I may have accidentally overridden one of these keys. So let me put this information back in just in case, because you can't actually look at the keys after you save them. You can only update them. Okay, so we updated that, and then the API key, I have to copy this once more. All right, so we got those, and then let me once again add the Heroku app name. This is going to be all right. So now we've got our 3 keys. Hopefully I set those all up correctly. And keep in mind the name of this environment is called production. So for the other job, which is the deploy job, we're going to specify the environment just same way we did with the first job, just by referencing this code right here and just updating the name. And so this is going to be production. And then we can remove this unnecessary step. And I'll change this to be deploying to Heroku. And then we'll change this to be use. And so just like in the documentation, actually, I might as well just copy it because it's a little bit easier. So I can just copy this. And we can just update the app name with the secret that we defined. As well as the secret for the email. And that's all we have to do for the Heroku side of things. It's as simple as that. So that's why I always recommend you look for a built-in action so that you don't have to perform all of these steps by yourself. And I realized before we even do that, we have to actually pull our code just like we did in the first job. So we're going to copy that section right here where we pulled the repo. All right, so we've got the repo and then we deploy to Heroku. And so what I'm going to do now is we want to check our code real quick and make some changes. That'll be easy to kind of quickly just test and see that we actually pushed out our changes. So under our main.py file, I'm just going to do what I always do. I'm just going to add successfully deployed from CI/CD pipeline. Okay, and so I'm going to save that. And then now we want to do a git add --all git commit -m push to Heroku example, and then we'll do a git push origin main. And before I do that, let me go to my app. So if I actually go to my app on Heroku, we can see it just says message hello world. And so after we commit these changes, we should see it send the new message. So I'm going to push this to GitHub now, and our CI/CD pipeline should run and push those changes out. All right, so now if I go back to GitHub and we take a look at the actions, I can see my push to Heroku example succeeded. And so you can see both the build phase and the deploy phase both succeeded. And if we want to take a look at the notes and then just see what happened with the deploying to Heroku section, we'll see the logs for this specific step. And so it looks like we can see Heroku's running in this case, and it looks like everything worked. So if I go back to my app and hit refresh, right, we could see we get the new message. So we have successfully updated Heroku using our CI/CD pipeline. It's as simple as that. And before I wrap up this video, this section or this video on deploying to Heroku, I found this one good article that shows you how to deploy to Heroku in a manual way. So if you don't want to use the built-in or the pre-configured GitHub action, you can actually create a custom workflow when it comes to actually manually logging in and then pushing all of these changes out to Heroku the manual way instead of using that pre-built action. But this is a little bit more complex, and this would only really be needed under very specific circumstances, or just for learning purposes. So take a look at it if you want to see how it's done manually, but you never actually have to do that. Now, before we move any further, there's one thing that I want to check to make sure that our CI/CD pipeline properly does, and that is that if we get any kind of errors in the build job, I want to make sure that the deploy job does not run, right? And so when I say errors, it could be anything, right? Maybe we're unable to install all of our dependencies, or maybe, and more importantly, if our tests fail, right? If my tests fail, I don't want to push my broken code out to production. So I want to make sure that if the test fails, we stop right there and we don't proceed any further with the deploy. And so from a configuration perspective, you don't technically have to do anything. That's the default configuration, but I do want to verify that it actually does what we expect it to. So in the tests files, or if I can find it, tests, I'm going to go to, it doesn't really matter what test. I'm just going to go under test posts, and I'm just going to modify this to an incorrect value. I'm going to put this in the notes, change to this one, so I remember which one I changed, so I can change it back from 200. So this should cause this test to fail, and if the test fails, then we want to make sure that we don't deploy. And I'm also going to go back to our main.py file to actually make some visible changes by changing this back to hello world to see if our code actually got updated accidentally or not. So we got everything set. We'll do a git add once again. We'll do a git commit -m broke stuff, and then we'll do a git push origin main, and we'll let that run. All right, so going back to GitHub now, let me go back to the actions page, and we can see the last run, it looks like it failed. So let's see where it failed. And so you could see here, it failed in the build stage, and then the deploy stage, if I select this check was skipped. So that means we actually did properly skip the deploy phase because the build phase failed, and we can see that we exited with an error code because one of our tests failed. Awesome. So let's go back. Let's fix this code real quick. And was it test posts? And we'll change that back to a 200. Don't need those notes anymore. And now let's push out those changes once more. All right, and we'll go back to GitHub again. And let's go back to actions and let's take a look. And we can see the last one did get deployed, built and deployed successfully. So if I go to Heroku, refresh this, we should see that this gets updated just fine. All right, so now that we can deploy our updates to Heroku, let's take a look at how we can deploy our updates to our Ubuntu server. So once again, it's just a matter of figuring out what exactly are the commands that we would need to run to update our production environment. So there's going to be a couple things. The first thing is, first of all, we would have to log into our Ubuntu server. And then once we log, and when I say log into our Ubuntu server, I mean like SSH to it. We would then have to move into our /app/source directory. And then we would run a git pull so that we can pull the latest code. And then we'd have to do a system CTL restart API. So how exactly do we do all of this? How do we log into our Ubuntu server? How do we SSH to it? Well, there's a really nice built-in action. If I can find the marketplace again. And I believe it's called SSH-action. And I don't think I can't find it in here, the one I used, but it's by Appleboy. And I'll just do Appleboy SSH. So search for that. There we go. This is the one we want, SSH remote command. So this will allow you to run commands on a remote machine. So let's take a look at how to do this. Here they give you an example. So you have to pass in the host, which is the IP address, the username, and the password. And then the SSH port is optional, but I think it should default to port 22, which is the one that's running on our Ubuntu server. So we don't actually have to define that. But that's all we really need. And then the script is going to be the commands that we want to run on the remote machine. So let's set this up. And I'll go down to here. And I'll say name deploy to Ubuntu server. And we're going to say uses appleboy /ssh-action at master. And then with. So first we have to provide a host. And I'm going to store this in a secret, and we'll call this, what do you think we should call this? How about Ubuntu _host? Actually, we'll call this prod host. And then username, same thing. We're going to store this in a secret. So we'll do secrets.prod username. And then password, once again, in another secret. And I'll call this prod password. All right, then we have to provide the commands that we want to run. And so since we're going to use more than one command, we're going to do the little pipe symbol. And then here we just list out the command. So the first thing that we want to do is we need to move into our app directory. So we're just going to be the app/source. And make sure there is no front slash. That's going to break things. Then we want to do a git pull. Now this is where it might get a little interesting. I'm going to do it the wrong way first. So we do a systemctl restart API, but we do need sudo privilege. So we'll do sudo restart API, or whatever you call it yours. And so let's define these secrets real quick. And we'll go into the environments, and then we'll go to our production environment. And so just go ahead and just create them here. All right, and then we're going to put in our password. I'm not going to show this one to you guys, so I'm just going to pause the video and then add it myself. And then finally, we need the username. And I believe I called mine just Sanjeev. I think that should work, hopefully. And so now we've got all of our secrets, and I think we should be good to go. Prod host, username, password. So let's try this. Actually, before we do that, I'm going to make one more change to the code so that we can actually see the changes. And so this is pushing out to Ubuntu. And we're going to have to do a git add once again. Then a git commit. And then git push origin main. All right, and let's go back now. Let's check on our actions. And it looks like it's still running. So it's in the deploy phase. And it looks like it's connecting. Oh, and it looks like it just finished. And it failed. So what exactly happened here? If we take a look at the logs, it says sudo, a terminal is required to read the password. So it's basically saying that when you run the sudo command, you get the prompt so that you can input the sudo password. And since this is all through a remote SSH connection, that's not really an option. So we have to pass in the -s option, the -s flag. And so the way we actually define this is going to be actually pretty interesting. But let's see, where's my file? So to use the -s flag, what we're going to do is we're going to say echo. And then we're going to echo the password, our sudo password. And then we pipe into the next command, and we do sudo -s. So the -s means that we're going to accept what the password as an argument, essentially. And this pipe command, what it's doing is we run echo, and then whatever our password is, So this we actually replace with the actual password. And it's going to pass that into the input of this command. So it's going to pass it into the -s flag, essentially. So that's how you do this with a one-line command. Here, we're just going to pass our same environment variable. So we'll do secrets prod password. And I think that should fix it, actually. So we'll do a git add --all, git commit -m, password fix, and a git push. Okay, so let's go back to our actions. We can see that the password fix commit ran just fine and it succeeded. So the build phase and the deploy phase succeeded. So if I go to my Ubuntu server and we take a look at this, we can see that we did get the updated code. So we did successfully update our production server. And on top of that, technically, since we never took out the code for Heroku, we should see Heroku also deploy. So if I go to my Heroku app, we can see that pushed out to Ubuntu. So we now have successfully completed our CI/CD pipeline. We set up all of the continuous integration steps, which included copying our source code, installing all of the Python dependencies, testing our application, and then we set up the CD phase, which was just a matter of pushing those changes out to our production environment.